Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. And today's topic is Advanced SAS tutorial. This is a 9.5 hour long Proc SQL and SAS Macro video. In here, this is how I am going to present this topic. What I will do is, I will initially introduce you to the topic of Proc SQL, and then I will give the brief introduction and what are the topics I am going to cover in Proc SQL. And then I will go in detail with each topic, and then I will conclude the Proc SQL. And pretty much same I will do with SAS Macro also, wherein I will give you brief introduction to SAS Macro, and then I will discuss what are the topics we are going to cover in SAS Macro. And then each topic I will go in detail, and then finally I will conclude SAS Macro. Now it's time to dive into Proc SQL. In here, this will be a complete Proc SQL tutorial, and this will be around 3.5 hours long. In Proc SQL, there are 8 topics which we are going to cover. First part, I will be covering on Proc SQL select and basic syntax. In part 2, I will be talking about where clause. In part 3, it will be more about group by. Part 4, I will be talking on set operators. Part 5, I will be covering on joins. And then part 6, subquery. Part 7, create and alter statements. In Proc SQL part 8, I will be talking more on insert, update, delete and drop statements. The way each part is organized is, it starts with very basic information and then it goes into lot of details or complexity. As we have covered most of the introduction, now let us dive into our first part. Proc SQL part 1, basic syntax, select and others. Now let us see what are we going to discuss in this topic. Initially, I will cover Proc SQL syntax, then we will discuss on select star and select columns. Then we will look into how to apply format and label for columns. Then we will look into how to create new columns. Then we will get into creating new columns using case when statement. And also in case when statement, I would add few more tips, and we will cover 3 scenarios, and then we will talk about how to limit the rows when doing a select, and finally we will conclude our topic. SAS implements SQL in the form of Proc SQL. Now let us look into Proc SQL syntax. Proc SQL syntax is simple, straightforward. You need to remember it needs to have 3 semicolons. First, it should start with Proc SQL, and then we have a semicolon, and then we have our query part, and then just before quit we need to have one semicolon followed by quit and semicolon. So all we need to remember is Proc SQL semicolon, and our query just before the quit we need to have another semicolon followed by quit, where we need to have one more semicolon. Now let us discuss about Proc SQL select. Proc SQL select is again very simple and straightforward. Here we have 2 keywords for simple select. The first keyword is select, and then the second keyword is from. And after the select, we need to mention column names or anything related to column. And after from, in general, we need to have table name or dataset name for a simple select. So in here, we are doing select star from our dataset SAS help.class. In this presentation, I will be using SAS help.class dataset, which is available with SAS Studio. So whenever we mention star, we will have all the columns from SAS help.class dataset. One point I want to remind you here is, whenever we do a select, it means we are just controlling columns. We might be applying up functions or anything, but it is just related to columns. It is not related to rows. We can nowhere control the number of rows or anything in a select. In a select, we can just control columns. Now, let us move to the next slide, wherein here we talk about how do we pick up fewer columns. In earlier slide, we had Proc SQL select star. Whenever we say star, it will pick up all the columns in dataset. To have fewer columns or the columns we want, we need to mention the column names, and then for every other column we need to have a comma. Say select name, comma, age. If we had another column, we need to have another comma. The comma will not be there only for last column in the select statement. In here, age is the last column in the select statement and it does not have comma. Another way is to use drop equal to dataset option. It is again simple. All we need to do is next to the dataset, we need to put a bracket or parenthesis and then drop equal to column names we want to drop. Here the column names we want to drop are height and weight. If we have multiple columns, we need to have a space between them. And this will give us all the columns other than height and weight. So now that we have looked how to get fewer columns, now let us look into another thing where we can change the attributes of column or assign the new attributes. Here again we are having the same dataset SAS help.class. Here instead of sex I want to label this column as gender. So again changing the attribute, which in this case is label, is very simple. All we need to say label equal to and whatever the name we want to in quotes, and this will print the value of the column as gender. And here I have shown only the partial results. I have not shown all the values just to keep it simple. What I mean to say is I have not shown all the rows. Now let us see how we can change more than one attribute. Here we have a weight column, and in this weight column I want to change two attributes. I want to change the label to weight of the person, and I also want to have a format equal to comma 6.2. If you see here, I'm easily able to do these attributes by just giving a small space and then format equal to comma 6.2. Now you can see here the values are in comma 6.2. What I wanted to emphasize here is changing the attributes is simple. All you need to mention is the attribute and its value next to it. If you have multiple attributes, you need to have a space between each attribute. Another thing I want to remind is if it is not your last column, you need to have a comma after your column attribute. Here sex label equal to gender, you need to have comma because it is not the last column, weight is the last column. Now let us look into creating new columns. Till now we have been just discussing how we can use the columns which are there already in a SAS dataset. Again, it is very simple. In here what I am doing is I am doing select star, which will pick up all the columns in dataset SAS help.class, that is name, sex, age, height, weight. I am using an int function on weight and creating a new column. So whenever we create a new column, we need to mention as the new column name. So here the int function simply picks up the integer part from the weight. So 112.5, just becomes 112. It's just picking up the integer part. The most important point I want you is to remember that whenever you make a new column, you need to have as new column. So basic syntax always should have as new column name. So here we are using int function on weight, and then we are saying as new column. Now that we have looked into creating new column in a simple way, now let us look into using case when statement. Case when statement assigns the values for new columns conditionally. Before going into those details, I would like to show the basic syntax of case when statement, and then we can further go into the details of conditional assignment. To understand the syntax of case when statement, I have color coded it. Now let us look it part by part. The first color code part is case and as. It is color coded in yellow. So whenever you write a case when statement, it should start with case and it should end with and as and whatever the column name you want to give. So it should start with case and then and as whatever the column you want the name to be given. And in the middle you have when statements. This is where you are conditionally assigning the values. Here I am saying when sex equal to M, then male. When sex equal to F, then female. So when then statements will allow you to put or will allow you to assign values in relation to another value. Here, when sex equal to M, we are able to say that it is male. So here I have couple of whens, but you can have as many whens as you want depending on your data. But more than 5 or 6 whens, it becomes very complex. And after when then we have an else statement. Else statement is also very important statement because it captures all the values which were not captured in when statements before, when then statements before. We can understand this better in the next example. But basically, else is very useful if something does not fall into earlier when then buckets. Say here we had other than M and F, if we had other values, all of them would have gone to have a value of missing. Now here you can see our results. Again, these are the partial results which I am showing just to keep it simple. Now let us try to understand what happens when we do not use else in case when statements. The first scenario where I have spoken about case when statements, it was a perfect scenario where everything was in proper order. This scenario and the next scenario which I am going to talk about case when statements is when there can be some issues if case when statements are not constructed properly. So let us start with our missing else scenario. Here I am doing select name age and I am building my case when statements. Case when age equal to 11, then 11 when age equal to 12, then 12 and as age in words from SAS help.class. So here if we see we have many ages 11, 12, 13, 14, 15. So what is happening here is we are not capturing ages or we are not capturing the values for other than 11 and 12, which will lead to missing values in the new columns. And whenever you don't use an else statement, you will have a note saying a case expression has no else clause. Cases not accounted for by the when clause will result in missing value for the case expression. It is pretty clearly stating us that whenever we do not have all the values covered in when then statements, we will have missing values. So we have not covered when then values for 13, 14 and 15. So it is having a missing values. By modifying the above query and using else statement and saying else teen, we are going to capture all the other values and we are going to put them in one bucket. Any age other than 11, 12 will have the value as teen. See here, the values 13 and 14 has teen, 12 has 12 because we are assigning from when then statement. And it is always important to remember to have an else statement, and also always need to bear in the mind how we are assigning these when then values and what is going into else bucket. Else is one large bucket, and whatever we have not assigned in when and then, all of them will go into else statement. Now let us look into another scenario for case when statement. In this scenario of case when statements, different values, especially with different data types, are assigned, which can result in error. This is very important point to remember, that whenever we write a case when statement and we are assigning a value, say here we are saying case when sex equal to m then male, when sex equal to f then 2. Here if you see that we are assigning a value of male and then 2 and then missing to a new underscore column. So a column can never have two data types. We have indirectly told it to have a character data type here and a numeric data type here. This will always result in error, and this error is result of when clause 2 is not of same data type as preceding results. Take home message from this slide is, we need to have all the values or all the assigned values of one data type. That is, it should all be numeric or it should all be character. If we do not do that, it will result in error. Till now we have been just focusing on select. Select, as I mentioned, only focuses on the number of columns. It cannot manipulate number of rows. Say if you have a data set with 100 million records, and if you are going to do select star and it's going to print all the results, it will take forever and it is not efficient. So it is always important to limit the rows whenever we are doing select star. Especially when we just want to have a quick look, we can limit rows by using out ops equal to after proc SQL. Here, after proc SQL, out ops equal to 5, select star from SAS help.class quit will print only 5 records in my results window. This is very important, especially when you just want to check a sample. And here also we will get a warning in our log saying that statement terminated early due to out ops equal to 5 option. Till now we have been looking into presentation. Now let us quickly look into our code in SAS Studio. First, let us look into select star. Select star selects all the column. Now let us quickly run it and see the results. It shows all the columns which we have: name, sex, age, height, weight. Now let us quickly look into selecting fewer columns. Here we are doing by naming the columns. Now let me quickly run it. Here we only see 2 columns. Now let us see how we can have fewer columns by using drop equal to dataset option. So here we are only having 3 columns. Now here we are creating a new column. Let me quickly run this. Here we are using int function. This creates the new column int underscore weight. Now let us look into adding column attributes. Here I'm adding single column attribute label equal to gender. Here instead of sex, our results will show gender. See here, we can see the gender. We can also do multiple attributes for a column by using a space between each attribute. Now let me quickly run this. Here you can see that we have changed both the attributes. One is label name, another one is the format. Now let us try to look into our case when statement. This is a perfect case when statement. Now let me quickly run this case when statement. Once we run this case statement, it shows when sex equal to m, the new column is equal to male, f, the new column is equal to female. Now let us look into what happens if we don't have an else statement. Now let me quickly run it. Here we are only covering buckets with values of 11 and 12. All others have missing value. Now let us also quickly look into our log. Here we have a note saying that a case expression has no else clause. Cases not accounted for by then clauses will result in a missing value for case expression. Now let us add our else statement and quickly run this. Once we add our else statement, everything is fixed. Now let us look into another scenario where we have assigned different data type values. That is, in this scenario we have assigned male, true and missing to the new column, and what happens. Now let us quickly run it. Once we run this, as shown in the presentation, it will have an error saying result of when class 2 is not same data type as preceding results. Now let us finally look into how to restrict number of rows by using out equal to 5, and if I run this query, it should print only 5 records. So here it prints only 5 records, and it also shows in the log that statement terminated early due to out equal to 5 option. It's time to conclude our topic. Select is used to manipulate number of columns or columns itself. New columns are created with as column syntax. Whenever we want to change an attribute, all we need to do is mention the name of attribute equal to its value. Case when statement is used to do conditional assignment. Else is very important in case when statement, and also everybody should be careful of data types when they are assigning the values. Out equal to number restricts the number of rows. That's all for this topic. Proc SQL part 2, wherein we are going to discuss about where clause. Now let us see what we are going to discuss in this topic. Initially, I will introduce you to where clause, and then how where clause is applied on numeric variables and character variables using comparison operators will be discussed. With respect to character variables, I will also discuss case specificity and wildcards. Then we will talk about logical operators followed by the precedence in logical operators. And the next topic would be between clause, and then I will conclude this topic. Now let us try to understand where clause, what exactly it does. Where clause restricts or manipulates number of rows, unlike select clause which restricts or manipulate columns. So the bottom line here is where clause is used to restrict or manipulate number of rows. Select clause without a where clause will give all rows in table. It is not very useful in the real-time scenario. To conclude, where clause is very useful and it helps to answer a lot of business questions. Now let us look into where clause on numeric variables. Here we are going to talk about comparison operators. The word comparison means we are comparing one value to another value, whether it is equal to, or whether it is not equal to, or whether it is greater than a particular value. Before going into any more details, I would like to say one important point here, that I will be using SAS help.cars table to explain most of the fundamentals here. So let us try to understand comparison operators here. Here, what I'm trying to do is I'm trying to use where cylinders equal to 4. So basically I am doing a select columns from sashelp.cars where cylinders equal to 4. So I'm comparing a column to a particular value. This will give me all those rows which have cylinders equal to 4. You can see from here the results that we have got all the rows with cylinders equal to 4. This is the partial result. I did not keep the complete result because this space will not be enough. And also we can have where cylinders not equal to 4. So we will get the rows where the cylinders are 6 and 8. So here what the point I want to mention is, by using simple comparison operators, we were able to answer some of business questions. If somebody tells, I want to see the data where cylinders equal to 4, a simple where clause would be helpful. Or if someone comes and tells, I don't want to see the records or the rows with cylinders equal to 4, then all I need to do is a not equal to, and it will help me get only those rows which do not have cylinders not equal to 4. And we can also use greater than or less than comparison operators too. Here we want to have information wherein MSRP is greater than $50,000. All we need to do is we need to mention in the where clause where MSRP is greater than 50,000. This will give us all the information needed. Here are some of the records which shows that where MSRP is greater than 50,000. Now let us look where clause on character variables, especially related to comparison operators. Again, here we have only equal to and not equal to, because it does not make any sense to do a less than or greater than when comparing character variables. So let us look into the examples here. If you want to find all the cars which belong to make of Acura, all we need to do is we need to mention select and mention all the columns from the table name where make equal to Acura. So it is pretty much similar to what we have done on numeric variables. All the difference is we need to use quotes and the value in here. So where make equal to Acura gives all the tables, sorry, all the rows which have Acura in it for make column. Now let us look into not equal to. Here we want to have cars where the make is not equal to Acura. All we need to do is we need to change the symbol to not equal to, and we need to give the value Acura in quotes. I want to mention a very important point here, and this is where sometimes people will have wrong results. If you see the make here, Acura, A starts with ACURA. A is in capital. So this is a prop case, and we have given exactly the same value. If we don't give exact same value, then we have different results. For example, instead of capital A, if we mentioned small a in here where make equal to Acura with small a, then we will not get any rows in the results because there is no row in here which has small a cura. So This is one point which we should always remember, and this relates to case specificity of values for character variables. Now let us go into little bit more details about case specificity and how we can solve this problem. Here we are going to create a new data set, data have, with values of bat in different cases. That is, in the first row, bat is in prop case, in the second row, bat is in up case, in third row, it's in the mixed case. So if you want to pick up the row where var equal to bat, if we have written something like where var equal to BAT with B in capital, that is prop case, we will get only one record. So it is very case specific. What do I mean by that? Values in rows are case specific for character variables. So if we want all the three rows to be captured, we need to upcase on the variable, and also we need to upcase on the value. So it matches on the both sides and it gives us all the three records. So it is very important to understand the case specificity. So whenever we want to look into every record of a particular value, we need to do an upcase, low case. Basically, we need to match values at both the ends. Now let us look into wildcard. Wildcard is like a joker in playing cards. It can match for anything. In Proc SQL, we have two wildcards. One is percent, another one is underscore. A wildcard is one which matches any character or sequence of characters in a search. Underscore implies one character. That character could be anything. Percent symbol or percent implies any number of characters including no character. Concept of wildcard using examples. Here first we will look into underscore. Underscore implies one character. That character could be anything. Now let us go into an example wherein we are creating a new data set, data have one, and it has records like this: FATA, FAT, CAT, BATA, BAT, ACT, ATA. Before going into the details of queries related to underscore, I want to mention one important thing. We need to use like operator as shown in here whenever we are using a wildcard. So any query which we are using a wildcard, we need to use a like operator. Say in case if you want to have records which are having AT at the end and only one character in front of AT, all we need to do is put an underscore. This underscore can take any values. It can take F, it can take C, it can take B. So when we do where name like quotes underscore AT, this will give us values of fat, cat and bat. So here you can see underscore was able to take any value. That is the significance of wildcard. You can also use double underscores, which means it can have two character values, any that could be any value. In our case, it is 80. So when we use where name like B underscore underscore A, it gives us the results as BATA because that is the only one in here. So underscore can be used by using it multiple times like 2, 3, and we can try to use them in our queries. We can also use underscore at the end and it can have one value at the end. That could be anything. In our case, it qualifies for this record 80A and we get our results. Now let us try to understand wildcard percent. Percent implies any number of characters including no character. This is one of my favorite, and in the real world scenarios we will be using this a lot. So to understand this wildcard is very important. As I said, percent implies any number of character including no character. Now let us try to understand it through queries. Say if I want something to start with A and it could have anything after A, then I could write something like where name like A percent, which means anything can come after A. So it will pick up these two records. Now if we have percent in the front and A at the end, it will give all the records which have A at the end, and it can have anything in the front of A. And if we want anything in front of A or anything after A, we need to give percent A percent. So it qualifies almost all records because all of these records have something in the front or something at the back. One important thing I wanted to remind here is, again, these are also case specific. So it is important to do upcase to get the records you want. And with the wildcard, we always need to use like operators. Now I would like to discuss application of percent wildcard in SAS help.cars. Here I would like to find 4-door cars from modal column. If you see the modal column, it has a long text, and to find 4-door we cannot use equal to or not equal to. We need to use wildcard, something like where modal like in quotes percent 4 dr percent quotes close. This will give us all the cars which has 4 doors. Final point I want to make through this slide is, whenever we have longer text and the value we want is embedded in the long text, wildcard helps in those case scenarios, especially percent wildcard. Now let us look into logical operators. They are or, and, not. Logical operators link other operators. Now let us look into and, slash, or logical operators. How they link other operators, what is the impact of linking with and also what is the impact of linking with or. We will go in details and especially through examples. Now I have a query here wherein we do Proc SQL select make model MSRP cylinders from SAS help.cars, where cylinders equal to 6 and make equal to Acura. So here what we are doing is we are taking two comparison operators. The first one is cylinder equal to 6, second one is make equal to Acura, and we are linking through and. So when we link through and, it has to, or the query has to satisfy both the condition. It means our results should have both cylinders equal to 6 and also make equal to Acura. We can understand this better by looking into the results of our query on the right side. Here we will have only those results where make is equal to Acura and also cylinder equal to 6. We get only those results which satisfy both the conditions. Whereas in the case of OR, it also links two comparison operators. Similar query as shown in above, but we have changed AND to OR. For OR condition, all we need to have is to satisfy at least one condition. So we will get results if it satisfy cylinders equal to 6. We will get results if it satisfy make equal to Acura. Cylinders equal to 6. If we see results here, these are only partial results though. We have lot of make of Audi cars where cylinders equal to 6, and we also have make equal to Acura in here. So to finally conclude, for R any condition can be satisfied to give results, and each satisfied condition will give its own results. Say in here cylinders equal to 6, if this condition satisfy, we get results related to this condition. If this condition satisfy, it gives results related to this condition. But for whereas and, both of them has to be satisfied. Now let us move on or on same variable. If we have or condition on the same variable, like in here where cylinders equal to 6 or cylinders equal to 8, we can use in operator and make the query as where cylinders in parenthesis starts 6 comma 8 parenthesis close semicolon. So whenever we have more or conditions, say for example here we have or cylinders equal to 4, all we need to do is we need to add one more 4 in here. Instead of writing same variable equal to a value with or again and again, if we can write something like below and use in operator, this will decrease the amount of code we need to type, and it is efficient in the terms of code writing, and it looks much cleaner. Now let us talk about another logical operator, not. Not also links comparison operators and other operators, but in a different way. In the query in here, we are having where not make equal to Acura, which gives the results which are not made up of or which are not make of Acura. So we are using the comparison operator, but we are negating the value in here by using not. In this Proc SQL, I have also mentioned number next to it. I have done that just to see the row numbers in here, because Proc SQL as such does not show the row numbers, but when we add number in the results, we can see the row numbers as shown in here. And also our results do not show make equal to Acura. From here it is very clear that we do not have make equal to Acura. These are again partial results. I have not included every other results so that it is clean, and also the space will not be enough. Now let us move into our final topic, logical operators precedence. In logical operators precedence, not is greater than and is greater than or. And if something is in parenthesis, it is greater than all of them. What does that mean? So whenever we have not and not is evaluated first, and whenever we have and or, and is evaluated first. If there are any expressions in parenthesis, it is evaluated first, then anything else. Now let us try to understand it much better, looking into some examples. It is very important to understand this concept, because if we do not understand, this concept, we will be making some queries which will be giving the results which are not expected. Now let us look into the two queries where we describe the impact of order of precedence. Here we have our two queries in the where class. We are trying to use and or. I have highlighted both these queries in yellow to show that that is the part which will be executed first. Now let us look into the first query and try to understand how order of precedence has impact. In this query, we have select make model MSRP cylinders from SAS help.cars, where make equal to Acura and cylinders equal to 6, or MSRP is greater than 50,000. So what happens in here is, first make equal to Acura and cylinders equal to 6 gives a result, and then it does an OR on MSRP greater than 50,000. So our results will have either the first condition, that is where and end clause, or it will have this result, that is or MSRP greater than 50,000. So if we see here results on the right, we have Acura and cylinder 6, which satisfies this and condition. And then here if we see, we have MSRP is greater than 50,000, and this satisfies this condition. The important point to remember here is the first part where we have and is executed first, and then MSRP will execute. This is what is known as order of precedence. In the next query, we have a very similar query, but it has a small change. Let us look into that change. Here we are saying where make equal to Acura or cylinders equal to 6 and MSRP is greater than 50,000. As and has higher preference, this part executes first, that is cylinders equal to 6 and MSRP is greater than 50,000. Once we get this result, we will do an OR where make equal to Acura. Now let us try to understand by seeing the results in the right. So first it will execute cylinders equal to 6 and MSRP is greater than 50,000. That is the results in here, which shows cylinders equal to 6 and MSRP is greater than 50,000. And also then it tries to satisfy the condition where make equal to Acura, that is make equal to Acura. So here our number of records is very small. It's almost came to an end at 13th record, but here their records are close to 200, which I have not shown. Here the important point I want to emphasize on is wherever your end clause is there along with or, it may be there in the front or it may be there in the back of the query, but always and will execute first. Now let us see how we can change order of precedence using parenthesis. We have same query what I have shown to you earlier. To change the order of precedence, all we have done is we have used parenthesis. If you remember from the very first slide, parenthesis has highest priority and it executes first. So instead of giving more priority to and where it executes first, what we have done is we have used parenthesis so that we have changed the order. So our results will again depend upon the query here. So first make equal to Acura or cylinder equal to 6 will execute, as we have an AND condition here after this parenthesis, the results which we have got, that is make equal to Acura or cylinder equal to 6, should also have MSRP greater than 50,000, then only we will see the results. Now let us look into the results to understand it better. So here, when it was executed, the first part of the query was executed. If we got Acura, that is our condition in a bracket, it has 6 cylinders and the MSRP is greater than 50,000, that is our AND class also got satisfied, so we see the result here. The remaining results has the OR condition satisfied here, the cylinder equal to 6. Once this condition was satisfied, it also satisfied greater than 50,000, so we can see the BMW here also in the result. In the same way, Benz and Porsche also come because they are 6 cylinders and they are satisfying one condition in here, and also they are satisfying the AND condition here. So order of precedence is very important, and the way we change it will change the results. Now let us see how we can apply a NOT condition or NOT operator on two conditions. The problem with the NOT is NOT has higher priority than AND or OR. So what happens whenever we put NOT and any other condition, always NOT has the higher precedence. To negate two conditions, for example, if we don't want to see make equal to Acura and cylinder equal to 6, we need to put that in the parenthesis so that this part first executes and then we are applying NOT. Otherwise, NOT will execute first and we will not get the accurate results. Same in the case of OR condition. If we want to not have cars which has make equal to Acura or cylinder equal to 6, all we need to do is we need to put them in the bracket. So it executes first and we are negating using a NOT. From all of these slides which I am showing on order of precedence is, it's important to know how the order of precedence works, and also if you want to change the order of precedence we need to use parenthesis. Now let us look into one last thing, which is numeric range. Here we can use between and clause. So whenever we want to find a range of values, here we want to find the range of MSRP between 30,000 and 50,000. All we need to do is we need to write where MSRP between 30,000 and 50,000. In conclusion, I want to say where clause is used to manipulate number of rows. Where clause can be applied to both numeric and character variable. With the character variable, everyone should be very careful of case specificity, and this can cause some confusion in the results. Apart from comparison operator, wildcards can also apply to character variables. It is very important to understand how logical operators work and how the precedence applies in logical operators and how the precedence can be changed. Ranges can also be applied in numeric values by using between clause. That's all for this topic. This topic is Proc SQL Part 3, Aggregate functions, group by, and other related details. Now let us see what we are going to discuss in this presentation. In this presentation, I will be talking on aggregate function and concept of re-merging summary statistics. And then I will be discussing on group by with aggregate functions, and then I will explain the concept of re-merging summary statistics with group by clause, and then I will discuss having clause, and then we will move on to having clause and its comparison with where clause, and then finally I will discuss a case statement with group by class. Now let us look into the dataset briefly on which most of this presentation is prepared. This dataset is SAS help.prd sales. It has sales data of various products being sold in various countries. If you look into the column names and labels, it is pretty self-explanatory. So basically we are selling some products, and here we also have the information about actual sales and predicted sales, and information about country, region, division, and also in which month, year and quarter these products being sold. I want to just add one more line to this is it has many more rows than what I am showing in here, with different countries and other details in those rows. Now let us look into the first topic, aggregating column and concept of remerging summary statistics. Now first let us try to understand what is an aggregate function is. An aggregate function, popularly also known as summary function, is a function where values of multiple rows are grouped together to form a single summary value. So to tell in short, whenever we apply an aggregate function, it works on multiple rows and creates a single summary value. Some of the popular aggregate functions which are used routinely are sum, count, min, max, mean, nmiss, and range. There are many more aggregate functions which I have not discussed in here. Now let us look into the first aggregate function, that is sum function. Here we are doing select sum, and we are doing sum function on column which is known as actual, which contains actual sales information. So once we apply this sum function on actual sales column, it sums all the rows in the actual column and gives one summary value which can be seen in here. Now let us try to see some more aggregate functions and how they work. Here another aggregate function I am using is nmiss actual. Nmiss function tries to find how many missing values are there in actual column for all rows in actual column. Here, as there are no missing values in actual column, we have 0 as the result. And once we look into the min function, it again, once we apply on actual column, it looks into all the rows of actual column and tries to find the minimum value, that is 3. And the same in the case of max. The max is 1000 here. Another interesting function is range. Range is simply nothing but the max actual minus min actual. That is the range of the values which are there in actual column. So bottom line to understanding this aggregate function is an aggregate function works on all the rows in a column and then gives a single value. Now let us try to understand aggregate function with and without distinct. Here I am talking about another aggregate function, that is count. If I do a select count country, it gives me there are 1440 countries. And once I apply distinct and do my aggregate function, first the distinct function applies to the country and it just picks up only distinct countries, and then we do count, and the count is 3. In this table we have only 3 countries, that is USA, Germany and Canada, but they are repeated many times. So once we do the distinct, we get only the distinct value. Now let us try to understand the concept of remerging summary statistics and what it is and how we can understand about it. Here, let us look into the query here. Here we have select country, predict sum actual as sum underscore actual. So here we are applying aggregate function sum here, and we have two columns which are nowhere related to this aggregate function. Whenever we do select on any columns which do not have aggregate function, it will give all the rows of those two columns. And we have aggregate function and it just gives one row as we have discussed earlier. So here if we see our result, we have country and predict and sum underscore actual column which has repeated value. Now whenever we run this kind of query, we have a note. The query requires re-merging summary statistics back with the original data. Before explaining the concept of re-emerging summary statistics, I would like to explain one thing. That is, whenever we apply an aggregate function and the result we get is known as summary statistics. Remerging summary statistics happens in two steps. The first step, just the select the aggregate function works and it gives us the result as shown in here. In the second step, it takes care of all the select columns which do not have an aggregate function and it gives the result in here. So next step what happens is, once these two are there, the merging happens and we get the result in here like this. All of this happens under the hood. We will not see all these results. We directly see one result like this, what I am highlighting in here. Now let us see the concept of group by and remerging in group by. Till now we have seen aggregate function. This aggregate function has given one single result. This result is often not very useful because it is not giving us a lot of details. When we apply group by, the aggregate function is applied to a group instead of all rows, and we get single value for group. This is very useful. Say once we have done select country and some actual and we have done group by country. If we see results here, we see the results for each country, how much sales or how much money has been made. If we increase columns in group by, like shown in here, group by country comma region, and we have country comma region in our select also, and we are doing sum our aggregate function, then we get more results or we get more information because now the group by is done at country and also region. It has to include both country and region. Now earlier if you see here, we had information for Canada only. Now we have information for Canada and for the region East. Now we have for Canada the region West. As we increase the columns in the group, our group size increases and we get more results or more information. Now let us see what happens if we use group by clause without aggregate function. Whenever we use group by clause without aggregate function like shown in here, wherein we are selecting country, region, predict from SAS help.pid sale, group by country, region and predict. In that case, what will happen is a group by will be converted into order by and our data will be ordered. And we will also have warning, a group by clause has been transformed into order by clause because neither the select clause nor optional having clause of associated table expression referenced a memory function. So this is one important point to remember. Now let us dive into some more important topic, that is remerging statistics in the case of group by. This happens when columns not in group by but they are in select. Now let us try to understand this through an example. Here we are doing proc SQL select country comma region, and also we are doing our aggregate function on actual column from sashelp.prd table group by country. If you see, only country is the column which is there in group by and select, but region is an extra column which does not belong to group by. Whenever we do this kind of query, remerging happens something like this, where aggregated value is repeated, and we will also have note saying that the query requires remerging summary statistics back with the original data. Now let us try to understand it better through an example and also looking under the hood what exactly happens. So here is our query where we are using only one column in the group by, but we have two columns in the select, and we get a result something like this. How this works? Again, this works in two steps as previously shown for another scenario. First, what happens is our group by class works and we get our aggregated values like this. So first select country, sum actual as sum actual from SAS help.prd sale group by country works, and we get our results here. That is, we get our summary statistics here. And in another step, it will run select country region, these two columns, and we will get results something like this. So once we have these results, if you see here we have Canada, so this value will be allotted to Canada, so this value will be repeated here, and in case of Germany it will get stick to country when it is Germany. I was not able to show that because the place is very less in here. And in case of USA, if the country is USA and the region whatever it may be, this value will be repeated. So basically remerging happens again in two steps. In the first step, it will do the group by. In the next step, it will do the select, and then it merges both these steps to make something like this. Everything of this sort happens under the hood. I have just tried to show this by expanding everything so that you can understand it much better. But basically, remerging statistics means, remerging summary statistics means it will first give summary statistics and then it will have a select, and both of them get merged and it gives us the final result. And again, this final result is something which we see, and this happens under the hood. Now let us talk about having clause. Having clause is an important clause and usually used to filter the rows on the basis of aggregated column values. Now let us look into the query here. Here we are doing proc SQL select country, region, product type, comma, sum actual. This is where we are doing aggregation, and we are doing from the table name group by country, region, product type. Now we have wealth of information here, but if we want to answer any particular question, say for example, I want to know which region in Canada and which product type is having more than 50,000 of sales. Or if I want to see which region in Germany is having more than 50,000 sales, I can do that by using having clause. So having clause is generally used on aggregated column value, and when we apply the having clause, it filters the records and gives us only those records which are greater than 50,000. Now you can see the result in here. So now we are able to answer multiple things. For example, there is a business question wherein they ask what are the regions which are doing better or doing more than the threshold we have expected, or what are the regions which are doing a bad business or which are less than the threshold we have set. So that is where our aggregation followed by using having clause will help us. Now let us try to understand other forms of using having clause. Having clause can also be simply used by doing having and giving the aggregated function followed by greater than 50,000. So instead of the column name, we can directly give the aggregate function in here. And also another important usage is not to have the aggregate column in the select clause like shown in here. If you see both these queries, the aggregated column is not in there. Both of them will work, but in the below query, we will not have the aggregated column. So for the group by to work, we need to have either aggregated column in the select clause or in the having. One will work. But if you don't want to see in the report or in the print here, all we need to do is we can skip the aggregated column in the select clause. Now let us try to understand having versus where clause. Now let us try to understand the difference between having versus where clause by an example. Here I want to do an aggregation and I want to do aggregation for only those values which are part of Canada, where country equal to Canada. I can do that in two ways. First, where I can write my regular select country region, some actual as some underscore actual from SAS help.pid sale, where upcase country equal to upcase Canada, group by country comma region. In similar fashion, I can write another query instead of where I can write an having clause having upcase country equal to upcase Canada. This gives me same results. So it begs the question, what is the difference between having and where clause? First difference between having and where clause is pretty straightforward. Where clause cannot work on summary function or on the columns related to summary function. Say here we are having our query select country region and our summary function or our aggregate function, and we are getting a value here from sashelp.pid sale. If we do where sum actual greater than 50,000, it will result in error. So we cannot reference summary function values or the resultant thing in our where clause. If we do, we will get an error saying summary functions are restricted to select and having clause only. Now that we have looked into the first scenario wherein we can find the difference between where and having, now let us look into second scenario. In second scenario, what I'm going to show you is where clause executes much earlier than having clause. Here we are showing the general query execution methodology. This is just the partial query execution, how it happens. I'm not given the complete details in it, but the point I want to focus it is where clause is executed always earlier than having clause. Now let us try to understand this concept by an example. The data set needed to explain this concept is created from SAS help.class, and we are doing if sex equal to m, so that we only have the records with m, that is when the sex equal to male. The reason I am doing is just to have fewer records so that I can show it more clearly in next slides. And also I have done keep equal to name age so that we have only two columns, so that our focus again is on very few variables rather than many variables. This example, which I am going to show in the next slide, is heavily inspired by Ian Whitlock's post in the link given below here. Now let us try to understand what is the difference between where clause execution and having execution. Here we have two queries. Both the queries are exactly similar except the highlighted portion. That is, in one query we are using where clause, and in another query we are using having clause. Other than that where and having part, everything is exactly same. In this query we are doing two things. First one is we are renaming age column to p underscore age, and another thing is we are using case when statement on age column, and we are saying when age in 11 12 then 9, when age in 13 14 then 10, else 11 and as age. Basically we are creating a new age column with change in the ages. Whenever the age is 11 or 12, the age is converted to 9. Whenever the age is 13 or 14, the age is converted to 10. If the age is greater than 14, then the age will be 11. Once we do where age greater than 10, we see that all the records are still there. The where age greater than 10 has not worked in here. Why is it so? Because age was previously there in class table, and where class executes immediately and does not wait for new variables to be created, so it does not understand this new age column, and then it executes it so fast with the previous age column. In the previous age column, if you see, all the values are greater than 10, so everything qualifies and nothing gets filtered out. In the second query, where we are using having age greater than 10, we see only 3 records. This is because having executes much later, and also it sees all the new variables getting created. So it sees the new age column, and then in here we have only 3 records which are greater than 10. So we get 3 records instead of 10 records in the case of where clause. The point here I want to mention is where clause executes much earlier than having clause. And to sum it up, there are two main differences between where and having clause. The first one is we cannot use where clause on summary function, and the second one is where clause executes much earlier than having clause. With where versus have, always the good practice is to use the results of aggregate functions in having clause. Now let us discuss group by with case when. Aggregate functions can also work on case when statements. I would like to illustrate this by an example. Here we have dataset SAS help.class, and we have male and female sex in this table, and we want to count how many people are there with age 11 in male, 12 in male, 13 in male, 14 in male, 15 in male, and the same thing for female. Now let us try to understand step by step how we can achieve this without writing any code at all. Firstly, say first what I want to do, or what we want to do is we want to do a group by. Means we want to do things only for male and do only things for female. That is, we want to find count separately for male and separately for female, which can be achieved by a group by statement. Then, for example, if I am looking for age 11 and want to find the count for age 11 in male, what I will do first? I'll go to male and then I will check whether it is 11 or not. If it is not 11, what I will tell is to add a 0. So now the count is 0. Then I will come to the next male and then see is there any 11. If it is not there, again I will add one more 0. So the value is still 0. Then I will come to another male. It is 12. It is not 11 yet. So add one more 0. And then I will do the same, and once I find the male as 11, then I will add 1. So we have one male with age 11. So the logic was simple. If we find that particular age, we added 1, else we have added 0. Let's try to understand for one more age. For age 14 in male, what we have done is we have checked here 14. Yes, there is a 14 here. So we have added 1. And then another male, we have added 14 is there, we have added 1. So we have two males with age 14. We don't have any other age with 14. Say here we have 16. So we are adding 0. We are adding for 12, we are adding 0. So the bottom line I want to say is we are counting in such a fashion in a group by saying if we have this particular age, then 1, else 0, and sum it up to get the end count. Now let us try to see the code and we will understand it better. So when it comes to code, we will have select sex and we have group by sex, and we are doing sum, and in the bracket we have case when age equal to 11, then 1, else 0 end. So whenever it finds age 11, then it will have 1 and else it will have 0, and it does summing every time. In this fashion it will give us count, and we are doing same thing for 12, 13, 14, 15. Here if you see, we are having for female and male, we are having the counts, and you can see the output in here. So the bottom line what I want to say is we can use aggregate function on case when statement, and the syntax we should remember is sum or any aggregate function. The case when statement till the end should go as in the bracket as column name. Now it's time to conclude this topic. Before the conclusion, I want to mention 2 points. The first one is I have not written quit semicolon for many proc SQLs. SAS itself adds quit semicolon whenever you have one semicolon, but it's always a good practice to have quit semicolon. And another thing is I might have mentioned at some places Re-emerging, it is wrong. The correct usage is re-merging. In the conclusion, I would like to say aggregate function without group by works on all rows, and with group by it works on groups. Remerging summary statistics happen when there are extra columns in select which are not there in group by clause. Having clause works on results of summary function. Group by and aggregate functions can be applied on case when statements. That's all for this topic. Part 4, we are going to talk about set operators. Now let us quickly look into what we are going to discuss in set operators. In set operators, I'm going to talk about general properties of set operators, followed by significance of all keyword, followed by core keyword, and also I would like to discuss special case of intersect. All of this we will be discussing through various examples. Now let us quickly look into what do set operators do. Set operators affect number of records vertically. How do they do it? We will look into it very quickly. And what do they do again is they impact number of rows. Basically, whenever we use set operators, we are impacting the number of rows in one way or other. And also, set operators are different than joins, wherein we are usually intended to compare one table to another table completely. And again, this is most of the times. Unlike joins, whenever we compare two data sets or we do something with the join, it is more or less done on the basis of one column or one variable, not on the basis of the whole table. Now, let's get into general properties of set operators. Before going into that, I would like to say the types of operators, how many are they? There are 4 types, and they are union, except, intersect, and outer union. If you see here, I have mentioned in here outer union as SAS specific. In SQL, set operators are there and they are standard for any databases or pretty much anywhere SQL is implemented. Outer union implementation is something which is very SAS specific, and you don't see this kind in any other SQL implementation. Now let's look into union. What does union do? Union appends data and removes duplicates. Now let us try to understand through an example in here. Here we have two data sets, dataset 1 and dataset 2, and in both the case we have two variables, ID and name. And if you see here in this dataset we have 1A, 2B, and in this dataset 1A and 4B. And we can do union of these two datasets as follows, wherein I can write proc SQL semicolon select star from 1 union select star from 2 semicolon quit. So if you see, we are combining these two tables with the help of union. And what this does is it combines these two tables or data sets, and also it removes the duplicates. If you see here, if we just append it in a regular fashion, our result should be 1A, 2B, 1A, 4B. But if we just mention union, it will not allow the duplicates, and you will have only 1A and 2B and 4B from here. Again, to sum it up, union appends data and also it removes duplicates if there are any. Now let us get into intersect. Intersect, again, to explain this topic, I am going to take the same example which I have shown you earlier, where we have two data sets and the data which I have shown you is the same. Instead of union, I am doing an intersect here. When I do intersect, what it does is it gives the common rows, that is 1A, and also it removes duplicates. Intersect is little bit more nuanced, and little bit more details of intersect we will discuss at the end of this presentation. Now let us quickly look into except, and again we are taking the same data set, and if you look into here the data sets are same, and instead of intersect we are using except here. Everything else is same. Except is little different. What it does is it finds non-common rows from the first table, and if it has duplicates it will remove them. Now let's try to understand this one little bit more in depth. So here we have 1A, 2B, 1A and 4B, and I am doing except, and I am using select star from 1, and this is my first table. Whenever I mention select star for the first time in here, whatever comes second, it is the second table. So here in the first table I have 1A and 2B, and in the second table I have 1A and 4B. If you see here, I'm telling very specifically it finds non-common rows from the first table. So this 2B is not there anywhere, but 1A is there. So this 2B is the non-common row. So that comes out as our result in here. Now let us pause for a minute and let's think up for another scenario. For example, if I have mentioned select star from 2 first and 1 later, my result would have been 4B. So the except results depend on the first table. It is not an overall comparison. Even though I am comparing first table to second table, the results which come out are usually from the first table. Now that we have looked into 3 set operators, the 4th set operator, outer union, I will discuss at a later point, and you will understand why I have discussed that at a later point. Now that I have explained these 3 set operators, I want to discuss very briefly the properties of these set operators. But I will explain only through union. But those properties are same for except and intersect. Now let us look into what are those set operator properties. Here everything else is same what I have discussed previously with one change. That is, in the first data set I have the variable name changed to new underscore id from id. So when we do union, what it will do is the result will be exactly same from what we have seen earlier. The only thing changes here is the variable name changes to new underscore id. And I want to discuss at least couple of points here so that the concepts are a little bit more clearer. So if we have done the same kind of thing somewhere in our data step, you have to remember that in data step, whatever we do is lot of variable dependent. That is variable name dependent. But here it is always about position. Here new id and id, they match. Means their data types are same. So here the append happens and they come out in the same variable, but the name from first data set. This is an important observation from the regular SAS properties what we do in data step. Now let us look into another property. That is, here we have the same data sets and everything is same. Only thing we have changed is data type for id. And here we have a character, and in the case of here we have a numeric variable. So we cannot do a union, intersect or except whenever we have different data types and we are going to get an error saying that this particular ID and this particular ID are not of same data type. So in SQL, in general, all it matters is position, not the name of variable. Now let us look into something different than what we have been seeing, that is all keyword. Now I will explain this all keyword with the context of again union, and then I will not be explaining the same thing for except and intersect because it will become very redundant. The results will be exactly what you expect. But let's try to understand the all keyword. Here we have two data sets which we have seen, and when we do union, whatever is the common observation here, that is 1A, it is removed. Here the append happens and also a duplicate is removed. But when we add an all keyword, it does not remove duplicates. It just straightforwardly appends. Now let us see what is the advantage of this kind of scenario. Whenever we use all, what it does is it just easily appends both of these data sets. But when we do not have this all keyword, what happens really is, first, the SQL optimizer, what it will do is it will first check whether there are any duplicates. If there are duplicates, it will remove the duplicates and then it will append these two data sets. So if you see, whenever we just use the keyword union, it has to take two passes. The first pass is to check whether there are any duplicates within the data set or with other data set, and then if there are, it will remove. That is the first pass, and then it will append. With the all, it just appends without doing those two passes. For example, you have a data set which does not have any duplicates. You can simply use union all, and it is much more efficient as it has to go only one pass. And also, if you are fine with the duplicates, then you need not use just regular union, but you can use union all. So union all will be a little bit more efficient. And now, as I said earlier, it is the same with the case of intersect and also except. Now let's look into something entirely different, that is outer union. Outer union, as I have explained you before, it is super different than what we have seen, and it is SAS implementation. You don't find this kind of thing in another databases or another SQL implementation. Here, let's try to understand outer union. Here again, I have the same two data sets. Instead of union, I am using outer union. What this does is it just stacks, it just appends. But if you see, it does not understand anything. All it does is it sets up the values for first data set and then sets up the values for second data set as shown in here. And there is no all concept here. If you see in here, ID are same, name and name are same, we know that. But they are stacked differently as a different variable. Now, if we want to come together as we expect that ID values of these two and these two match, then what we need to do is we need to use a core keyword. Now let us try to understand this through an example again. Here, everything being same with what I have shown you before, all I have done is added a core for this outer union. What this core does is it combines the data sets on the basis of column name or variable name. Now let's quickly go back and see our simple outer union. Here you can see that simple outer union just stacks. But what it does not do is it does not combine the variable names. This kind of results are pretty useless. So outer union without core does not make much sense. So whenever you use outer union core. And also there is no concept of all in the case of outer union. So whenever we do outer union, always remember to use core, and here we will not be able to remove duplicates. Now let's go a little bit deeper into the concept of core, but this time we will be trying to understand with relation to union, except and intersect. I will be showing only the results with relation to union, and I will not be discussing about except and intersect, as this will be very redundant if I do so. Now here we have data sets, and in these data sets we have two variables, ID and name, in the first data set. In the second data set, if you see, the variable names are ID and names. Now if you look closely, these two variables are not same. And if we do union core, what it is going to do is it is going to only combine those variable names which are matched. Now if you see here, we have a result in which we have only ID variable, because only ID and ID variable names match. Now let us look into union. Everything is same here, and all I have done is union. When we do a simple union, if the data types match, it's all good, and then it is going to combine the data sets, and the variable names are picked from the first data set, as I have explained earlier. Now here you can see that union core is depending on a variable name, whereas in the case of union it is all about data types in the positions. If they match, the append or union will happen. Now let us dig even deeper and try to understand in what kind of scenarios union core might be useful to us. Let's look into the example in here. Again, I have two data sets here. In these data sets, the variables are at different positions. What do I mean by that? Let's quickly look into these two data sets. I have variable name and ID. Name is in first position, ID is in the second position. In the second data set, ID is in the first position, but name is in the second position. If you see, there is a variable names match, but if you see, the positions do not match, and if we are going to do a simple select star from one union, select star from two, it is going to fail, and it is going to say that the data types are not matching. Here again the same data sets and the variable names are at a different places, but the names do match. So what happens is it picks up the variable names from the first data set and it gives the results as shown in here. This is very useful whenever you have different data sets where the variable names are not at the same position, but variable names are same. Now let's also look into outer union core and union core to understand it even more better. Now we have data set 1 and data set 2. Here in data set I have ID and name, whereas in the case of dataset 2 I have ID and new underscore name. What outer union does here is it will combine both the data sets, and as I am using core in outer union here, whenever the variable names match, they come into same variable whenever the variables do not match, that is in the case of name and new underscore name, they do not have counterparts in both the data sets, so they just stack as shown in here. Now you can see that this outer union core is giving results whenever the variable name matches, it stacks, and when they do not match, it still keeps those values in here and those variables in here, but missing values whenever they don't have counterpart. But when we use the same data sets and we do union core, it is only going to give one variable, that is ID, because that is only the match. This is the main difference between outer union core and union core. Now, if we look closely into the results of outer union core, what we can see is this looks very similar to our data step results. We can append the data set in data step by using a set statement and mentioning data set names, and you get pretty much the same result. One use of this outer union core or all the set operators is, more than often whenever we are using set statement or doing any kind of merge in data step, we should be always be careful of length statements, and we can land up in data truncation. And we can avoid this by using this outer union core or generally SQL whenever we have different length in different data sets. I have made a video on the same topic and I will give the same link in the description below. And now let's look into another topic, that is special case of intersect. Now, as I said to you earlier, intersect is little different. Now, what I want to show you in here. Now, I'm doing an intersect all here, which means it should not remove any duplicates. Now, let's look into our data set. We have data 1 and we have data 2. And here in data 1, I have ID and name, and data 2 also have ID and name. But if you look into observations, I have 1A, 1A, 2B, and here I have 1A and 4B. Now after intersect all, we are going to get the result as 1A. Why are we not getting 1A, 1A and 1A? Why are we just getting simple 1A? Even though we have intersect all. Now we can understand this better by looking into another example, and we will quickly come back and I will address this in a minute. If we see the data sets here, I have 1A, 1A and 2B in dataset 1. In dataset 2, I have 1A, 1A and 4B. If you see the result in here, I have 1A, 1A. Now what can I interpret here? Now to understand intersect, what we also need to understand is whenever I have 1A here and 1A counterpart here, that means it has a match. So that's what we see in the result in here. And 1A, and there is 1A for this 1A. So that's what we see in here. So to understand intersect, what we have to understand is the exact number of values should also match in both the data sets. And now let's quickly get back to our earlier results. If you see, I have only 1A because for this 1A in dataset 1, I have 1A here. So that is what we see in the result in here, but there is none for this 1A. That's why we do not have anything in here. So this is an important point we need to understand in intersect. Now that we have discussed a lot about set operators, I quickly want to summarize this. To summarize this, what I have done is I have made all the information in groups. So in the first group, I'm saying as a group 1, I'm going to summarize about union, accept and intersect. Simple union, accept and intersect, they operate by position. They take name from first table and data types should be same. Those are the requirements for union, accept and intersect. Whereas when we use all keyword along with them, that is in my group 2, they will not remove duplicates. When you do not have any problem with the duplicates, then you should always use all keyword because it's more efficient. Core operates with variable names. Now let's look into group 4. Group 4 is about outer union. In outer union, everything gets stacked and we always need to use core keyword to match column names. If we are not going to use core, whole the outer union concept becomes pointless. Unmatched columns will be there in outer union core, which is different from regular union core where unmatched columns will not be there in final output. There is no concept of all for outer union. I have not shown you couple of things. That is, I can also use union all core. The results will be like what you can expect. That is, it is dependent on variable names and also it will not remove duplicates. And also I have shown you set operators with only 2 data sets. But more than 2 data sets can be used in set operators. I have shown only 2 data sets to keep the whole topic little bit simpler so that it is easy to understand. And also one another important point to note here is accept results are dependent on first table of set operator. That's all for this topic. Topic is about joins. This is one of the most important or interesting topic in SQL. Now let's look into what are we going to discuss. In this topic, I will be discussing about types of joins with relation to only one condition and 2 data sets or 2 tables. And in here, I'm going to discuss inner, left, right, full and cross join. And also we will look into special conditions of self join and join with the index. Then we will look into how do we do joins when we have more than one condition and when we have more than 2 tables. Then we will look into cardinality in joins, that is one to one, one to many and many to many joins, followed by couple of miscellaneous topics, that is what happens when we do joins with aggregation and then what happens when we do select star from 2 joining tables. Now let us first start with types of joins. Now let us first discuss what is a join. This is just simple explanation and we are going into looking into examples and then we will try to understand joins. Join is nothing more than combining 2 or more data sets horizontally on the basis of common variable or variables. The general idea to do a join is to bring different variables from different data sets into one query or table. But you can do a lot more than what I'm saying in here. Now let's first talk about simple inner join. And in here, when we are talking about inner join, we will try to understand this through an example. Here we have 2 data sets, dataset 1 and dataset 2, and we have variables ID and age in dataset 1 and ID and salary in dataset 2. And in here, what we are doing is we are doing a inner join. And let's look into the code below. And let's start from the from clause itself. Here we have from 1, inner join 2. So whenever we want to do an inner join, first we need to say from dataset 1, whatever we want to put in here, and dataset 2. And then we are going to say on 1.id equal to 2.id. What is meant by 1.id? When we say 1.id means this id variable is from dataset 1. When we say 2.id, it is from dataset 2. This is especially important whenever we have the variable names which are same in both the dataset. If we are not going to mention 1.id and 2.id, we are going to get an error. Now let's look into our select clause. In the select clause also, I have mentioned the variables as 1.id, 1.age and 2.salary. And in here, I need to definitely mention 1.id because if I'm not going to do that, it is going to give me an error. But 1.age and 2.salary are not important. But it is an important practice to have things like 1.id, 1.age and 2.salary so that whoever is looking into the code, he can directly understand that these particular variables are coming from this data set. And even if we don't mention 1.age, 2.salary, it's not going to give any error. It's just a best practice to do so. Now let us try to understand results in here. And whenever we do an inner join, results are based on matching of the joining column. That is, whenever the ID in this data set matches to ID in this data set, we are going to get the results in here. Here, ID1 is there in both the tables. So we have results related to ID1 and ID2 also is there in both the data set. So we see the result as shown in here. ID3 and ID4 are not present in both the tables, so you don't see that in your result. That is all about simple inner join. Now let us see how can we make this code little bit more simpler. Generally, what we do is we write from 1 as A, or we can just say from 1 and A. And this is known as aliasing. Instead of using 1, now you can use A.id. Same is the case of 2, wherein I have mentioned B and then I have mentioned B.id. So instead of writing full name in our on condition, we can do an alias. An alias, we can write 1 as A, but 1 and space A also works. In simple inner join, your results are based on matching of joining column. Now let us quickly go ahead and look into a left join. A left join is also very similar to inner join with some additional results. Let's look into the code first and then we will go ahead and discuss the results. We are doing everything same in here, what we have previously done in the inner join, but we are going to mention left join. What is left here means? What does the join name here means? The first table, whenever you have, it is always known as left table, and the second table is your right table. So whenever we have said left join and we have used from 1, this particular table becomes left table. Now the code is almost similar what we have discussed. Let's look into the results and also let's discuss briefly about left join. Left join gives the results based on matching of the joining column like what we have seen in inner join, and also it brings non-matching data from the first or the left table. What does that mean? Is that when ID1 is having a match in both the tables, we see the results in here. When ID2 has a match in both the data sets, we see a result in here. And ID3 does not have a match in data set 2, but because this is a left table, the information from the left table will also come into the result, and we will have missing information from right table variables. Here if you can see, here right table variable is b.salary and it will be missing. To sum it up, whenever we do a left join, we have all the information from the left table. That is what all the variables we kept in our select will have all the values, and matching values only from the right table, and it will also have missing value from right table whenever it does not have match. Now let us talk about right join. Right join is pretty similar to a left join. Only difference is now the important table is our right table or our second table. Here it is 2. And you will have all the information from right table, and whenever there is no match, that is in the case of 4, there is no match, so we will have the information related to 4 ID also, but you will not have any information related to 4 in here. So for right join, we will have all the information from right table, only matching information from left table, that is when ID is 1 and 2. And I want to mention a very important point here. If you see, I have written b.id, and if we go back, here it is a.id. Whatever is our right table, we need to pick ID from that variable. If we are not going to do that, and if we are going to do a.id, it is going to be missing here. This is one important point we need to remember. Other than that, everything is same. Now let's go ahead and discuss full join. Full join, with the name itself, it is again very clear that we want information from both the tables. That is, whenever they have a match, we want that. Whenever they do not have a match, we want those information also. And here the keyword, obviously we have changed from left and right to full join. If you see here, I am interested in ID variable for this data set, that is data 1, and also for this data set. Because it's a full join, we want all the information from all the tables. That means whenever we have our joining variable, I want this 1, 2, 3 also to come into my data set, and also I want this information also to come into my data set, that is 1 to 4. And couple of important points. Here for this particular ID there is no match, so we have those values 3 and 45 and missing values for corresponding data set 2. And the same is the case with the 4. And here I have a.id and b.id, unlike what we have seen in right and left join, because we are interested in both the IDs. Again, to sum it up, we have information from both the data sets. Whenever we do not have any information related to that particular ID in another data set, that will go missing. Now let us look closely into the results. Here we have two variables ID with the same name. And if you see here again, another important point is the information is redundant, means I have value 1 and 1 again, 2 and 2 again. 3 and 4 are fine because they are there, because they are not duplicated. Now, how can we make this look better? It is super simple. All we need to do is we need to apply Colli's function on a.id comma b.id, and then we need to say as id. So what Colli's function does is it picks up first non-missing value. Say here we have id 1 and 1, it picks up first non-missing value 1, and that is what we want. Here it picks up 2, and in this case this is the first non-missing value, it picks up 3, and in this case this is the first non-missing value, it picks up that one, and it makes it look much nicer. Whenever you do a full join, please remember to pick the main variables from both the data sets, and in this case I am taking that as id, and then I am using Colli's on that. Sometimes you may have more variables in which you are interested. Remember, if you want the information from both the tables, you need to do a Colli's and do something like this, which looks much elegant. One another important point to remember is whenever we do a select, we get a result like this, but we can't create table like this because we can't have two variable names in one data set. So it does not work in create table statement. Regarding create table statement, we will be looking into our future videos. Now that we have looked into all kinds of joins, now let's go into something unique and different join, that is cross join. This kind of join we rarely use, and then what we are going to do here really is we are going to join this data set with this data set, but this join is not based on any variable. What does that mean? I want, for example, in this data set, this Toyota 10,000 to combine with all of these values, Honda with all of these values, BMW with all of these values. So how can I do that? I can simply do that by using cross join. Now I want you to focus here. I do not have anything like on, means I'm not joining on any variable. All I'm doing is I'm using cross join. What this does is this just combines this value with all other values in the data set, and it is shown as here. I do not want to delve too much into cross join, but I want you to be also to be careful whenever you are doing a cross join. If you see here, I have 3 records in here and 3 records in here. When we do a cross join, we get 9 records here. So what happens if we have 1,000 records here and 5,000 records here? You can imagine you are going into a big number when you have little bit more higher numbers and you are doing a cross join. So always be careful of doing a cross join. Now we have looked into all the categories of joins, but I would like to go a little bit more deeper, and by using these joins we can do something special. One of those is self join, and the second one is join on index function. Let us first look into self join. To understand self join, we also need to understand couple of things. whenever we are trying to do a self join, the information we want is all there in one table, but not in the way we want. So unlike where we do joins with multiple tables, the information is spread over multiple tables. That is, you want variables from this particular data set and that particular data set, or you want to compare two data sets. But in the case of self join, all the information is embedded in one data set. The only difference, as I said earlier, it's not the way we wanted it. So to understand this point, let's look into a data set. Here for this data set, what I have done is I have taken this data set from internet. Here I have a create table statement followed by insert into statement. Here we are creating a table which has employee ID, and it has first name of employee ID and last name of employee ID, and we also have manager ID. Manager ID is nothing different. Actually, for this employee ID, this particular one is manager ID. What does that mean? To understand this, let's also look into the data so that it becomes more clearer, and especially let's look into first and second insert statements so that we can understand it more better. Here we have one as employee ID, first name as Windy and second name as Hayes, and then we have no manager ID for this particular person. And in the case of second insert, our employee ID is 2 and her name is Eva Christensen and her manager ID is 1. So for example, now instead of 1, I want to see the name of that particular manager. Who is the manager? If you look closely, 1 is here too, but it is known as employee ID. But when we use for manager, we call that as manager ID. So both are same, but one is used for finding employee, another is used for manager. So if I join this observation or this row with this row on manager ID equal to employee ID, then what I will get is I can pull this information of Windy Hayes. That is, in my final observation, I will have 2 Eva Christensen and then Windy Hayes as manager ID. I know it is not fully clear. Now let's look this through code, and also I will show this you visually so that it is more clearer. On the top, I have visual representation. On the bottom, I have the code. Now first, let's look into the code as we have been looking all the way through. Here, let's look into our from. Here I have employee, that is our table name. And also after inner join, I have another employee, which means I'm using the same data set twice. So that is what is generally called as a self join. And also I want you to understand that we have aliased them differently, one as E and one as M. And then we are joining on E.manager ID equal to M.employee ID. And we can try to understand this better with the picture in here. In the picture here, I have mentioned table E and table M. As you know, these are aliases and the result in here. So what we are saying in here is whenever that E.manager ID equal to M.employee ID, I want that in the result. Now couple of points in here. I have color coded all of this to explain you that whenever the manager ID and employee ID matches, they have similar color. This is just a visual representation. And also in our select, what I'm saying is concatenate first name and last name of E table and make it as employee. That's what you can see in the result in here. And also we are concatenating first name and last name from M, and then that we are calling it as manager, and you can see in the results here. So remaining part of the results are self-explanatory. What I wanted to tell you here is instead of having two different tables, what we have done is we have used the same table twice. That's what is all about self join. And this inner join is no different than joining two different tables. Self join is just a special case and it is little different. And now let's look into join on index function. To understand the join on index function, we need to understand a little bit about the data. Here I have data new and data new one, and here I have var1 and here I have call1. And then if you see here in var1 I have answer, question and joker as values. In call1 I have ans and joke. The idea is to find whether this particular string is present in this particular string. And to do that we use index function. And I'm not going to go into details of index function, but we again can do the similar inner join, but now we are saying on index a.var1 because I have called this table new as a, and then b.call1 on the index function when it's greater than 0. And why I'm interested to show this join on index function? This is because of two reasons. One, I can do join just not on the exact equal to condition, but I can do on substrings and also on other variations. So whenever this index finds this particular string, we are doing our results, or we are getting our results as shown in here. And here I'm just picking up the values from only the data set new. So we have answer 100 and joker 89 because this is where our values match. But whenever you are not joining on equal to condition, be always careful. Why? For example, if we have other rows which also had ANS in it, it will join with that. And also you can also have a Cartesian product. More on what is Cartesian product in very few minutes. But be always careful while doing joins like this. Now let's also quickly look into different things. As till now I have been just joining with only one table. Now let us discuss about joining with more than one table and using additional variables on join. Here I have three data sets in which I have called as data 1, data 2 and data 3. So what we are going to do? We want to do inner join between these three tables. And these three tables I want to do inner join on the basis of ID variable, which is the common variable. And here you can see only 2 is there in all the three data sets, and that's what we see in our results here. But let's look into the code. And our code for the first join is very similar, wherein we say from 1A inner join to B on A.id equal to B.id. This is what we have seen before. So we are writing our first join wherein we are joining our A table to B table. And then we are writing inner join after this first join, and we are telling 3c, and then we are writing on a.id equal to c.id. So once this inner join we have written, we are writing a keyword inner join and then writing our third data set name, and then we are saying a.id is equal to c.id, and we are getting our result in here. Now let us also quickly look and try to understand how we are going to get our results. So when we are doing these joins which have more than one table, we need to understand that this takes place in a step-by-step fashion. What is that step-by-step fashion? When we are saying from 1a inner join 2b on a.id equal to b.id, that first does the join and gets you a result. Here 235 and 3000, there is a match. So we get this row into our result. And then once we get into that result which we do not see, this one joins back to this one. So this is happening in two steps in the memory. So this is what you see in the result. So to sum it up, you write from 1a inner join 2b on a.id equal to b.id. The first join you write, and then you mention inner join 3c. So this is going to function as I have told to you earlier. Now what will happen if we do our left join? Again, the code is pretty similar, and here we are doing a left join all the way through, and only thing we are changing in the code is left join keyword instead of inner join, and this is what we get as a result. But I would like to explain how this whole thing is going to function. Again, here you have from 1a left join 2b on a.id equal to b.id. So first 1, 2, 3, because this is our left table, and it joins, and we get all the information from left table 1, 2, 3, and we are going to get the information we need from the right table. This is what we get in the result first. That is, we get this piece of results first, and then we are again doing left join with the third table on a.id equal to c.id. And here again third table is the right table. So again we are going only to go get the result where it has a match, remaining all will be missing. So it is important to understand that this is our driver table, or we can say the important table we want all the results from. So we have kept this table the leftmost, and then we have done a left join. So we got these results, and in the results we have written a.id, a.age and b.salary. So salary only we get it when there is a match, and these results we get and they stay in the memory, and then another left join happens on a.id equal to c.id, and then you get this y here because you have written c.bonus underscore offered. Till now what we have seen here is very simple case scenario for our multiple table joins. We were either using inner join in both the ways and also the left join for both the times. So what I would want to show you, what happens if we swap one of this, and then we can understand it better. And also our on conditions were also very similar. We have taken one table as a driver table and then joined based on that. Now let's go a little bit more deeper. Here, for understanding this, what I have done is I have created a different data sets, and these data sets are known as test 1, test 2, test 3. And in the test 1, I have ID sal, in test 2, ID age, in test 3, ID and bank underscore amount. And here what I'm trying to do is, again, I'm trying to do a join on the base of ID. Here the data is little bit more so that we can understand the results better. So what are we going to do here? Here I'm trying to do an inner join followed by a left join. On test 1, inner join test 2, on a.id equal to b.id, left join test 3. But in the case of here, I am doing test 1, left join test 2 followed by an inner join. So what is happening in here? If you can see, the results are dramatically different. So let's try to understand this little bit more deeply. So first, when we do inner join between test 1 and test 2, what are we going to get? Here 1, 2, 3, 4 are IDs in my data set. But here I have 1, 3, 4. When I join on the basis of ID, I'm going to match 1, 3, 4 and 1, 3, 4. That's a part of my result. So my result will have ID 1, 3, 4 and respective sal values as 200, 400 and 400. And also I have age 35, 90, 29. As I said to you, these results are stored in memory and this happens in step-by-step fashion. So once you got this result, we are doing a left join. But now what are we trying to do is we are trying to map, or we are trying to compare this ID to this ID. So I already have the results and this ID 3 only has the match. So we get our result as follows. So this result we are able to understand, but let's try to do another one and try to understand what happens in here. Here I am doing test 1A left join test 2, which means I'm going to get 1, 2, 3, 4 and also the matching values of 1, 3, 4. So here my results have become little bit different in the first phase itself, where I have all the values from here. But what I'm doing in the next step is I'm doing an inner join with what the result I have got here, that is 1, 3, 4, and then I'm doing on a.id equal to c.id. As if you see here with the inner join, 2 and 3 only match. So even though in my temporary result set I have 1, 2, 3, 4, once I have told inner join, it is going to have 2, 3 information only. So in the final output we have 2, 3 and we have 300, 400 because for 2 age is not there, so it will be missing. So if you see here, by just changing the order of join, our results do change. So it is very important to understand the order in which we do our joins and how we get the results. Obviously, whenever you have a missing value, that indicates that for that particular variable we do not had a match. Now that we have understood that order of join condition does definitely matter, now let's also look into something different. Now what I'm changing in here is again very subtle change. In here I'm writing a.id equal to b.id, wherein I am joining test1 left join test2 and then left join test3 again a.id equal to c.id. Here again my scenario is entirely same except that here I am doing on b.id equal to c.id. So here again if you see the results do change. And what is happening in here? In here again whenever we do the left join between two tables, we get a temporary result data set which is stored in the memory, and in here it is again joining on a.id to c.id, that is our test3 tables. As it has match for 2 and 3, we have the values for 2 and 3. But whereas in the case of the second query, the query is pretty similar. So our results have same number of rows, but what we have differed is b.id equal to c.id, which means we are picking up the values from C only when it matches with B. That is only 3 matches. So only we have the value for 3. Here when we are telling C and A to match, here we have 2 and 3 matching. So we have the results for 2 and 3. Whereas in the case we are saying B and C, we have the value only for 3 ID, that is this to this. So it is very important to understand what should be our joining tables, even though our conditions are same. To get the values in the variables in which we want to see, we need to do that. And one another subtle difference is the order in this particular ID for this particular code is little different. And really that does not matter because the results are what we have expected. Now let's look into little bit different topic about how to give additional conditions. Till now we were just talking about just one single on condition. And if you want to have an additional condition, all we need to do is we need to add an AND condition. And now our joining will happen both on the basis of these two conditions. First, when a.id equal to b.id and also b.salary is 2000. Only this condition matches this only for id equal to 1, and I have in my select clause a.id, a.age and b.salary. So you can see the result as shown in here. If you have more conditions, you can add more ANDs. But here I want to tell one another thing. There is little bit difference between and where whenever we do a left join. I have made a video on that topic also. I will give the link for the same in the description below. Now let's move on to a different topic of cardinality, where we will talk about one-to-one, one-to-many and many-to-many joins. Till now, what we were mostly focused on about joining conditions and other things. We were not too much focused on the data itself. But now we are going to look into the data and we are going to talk about cardinality, that is one-to-one, one-to-many and many-to-many. Here, first we are going to talk about one-to-one join. One-to-one join is very simple and we have already spoken about that. One-to-one join means whenever you have the joining variable has only one value in first table and second table, as shown in here, it is known as one-to-one join. And here you can see the result whenever you have one-to-one join. For inner join, what we will have is 1 and 1 and the results related to that. 2 id2 and id2 here and the results pertaining to that. Whereas in the case of left join, we also have information from the left table where it does not have a matching ID in the right table. So basically the number of rows in the left join will be the number of rows which are there in the left table, and number of rows for inner join will be number of matching rows. Now let's look into one to many. In one to many, what I have done to show that concept is I've added many one IDs in here, and then we are doing the same inner join and we are doing the left join here. Whenever you have one to many, what will happen is this one will join with both ones, and now for this one in the result we have two ones, wherein we are going to see the result as 1 1 and also 2 where it has match. So whenever you have 1 to 1, you are going to multiply those values with 1 into how many manys you have here. Here you have 2 only. If you have 3, you will have 1 and 3 combinations. Here as we have 2, we see only 2 combinations. So which means one to many will have results in the form of 1 into many of the next table. So now for the left join, the results are also same, except that you have also the information from left table which does not have any matching in the right table. Now let's look into many to many, and many to many also follows the same pattern as we have shown in here. In many to many, what I have shown here is I have many same IDs here and many same IDs here. Now let us look this little bit closer. So this 125 will join with these two. This 130 will join with these two, which means whenever you have many to many, you have to kind of multiply the number of many to many records you have. When you have 1 to 1, you multiply, it becomes 1 only, but you have 1 to many, you have 1 multiplied by many, whereas in the case of many to many, you have to multiply these 2 with these 2, which means now we are going to have 4 rows. That is 125 with these 2, 130 with these 2, and you can see the result in here in our inner join. And we have to be always careful about many to many joins, especially when we have lots and lots of observations and lots of many to many joins. Then we are going to have a problem, because our data set or our resultant data set will have many rows. And in the case of left join, we will be additionally seeing the information from the left table which does not have match in the right table. Now that we have looked into many topics, now let us quickly look into some miscellaneous topics about which I will not go into a lot of detail, but I will quickly browse around those. The first one is, whenever we do a join, we can also do the aggregation in the same step. Most of the time when we were doing a join, what we were doing was we were joining the first table and the second table, and we were just bringing the variables by just doing from one inner join 2, and then we are saying on a.id equal to b.id, and we were bringing the variables. In this case, we were bringing id and salary from these two data sets, but we need not do just that, but we can also do a sum on this salary variable by just adding group by id. And in here I am saying group by a.id, and then I have select a dot id, and then also I am doing sum on this salary. So this gives me results as follows. So not only you can bring the variables, but you can do the sum also in the same step in the inner join which we were doing. Now let me also talk about another topic which is not often very much discussed. What is that? In here, what happens when we have same variables in both data sets and we used them in the query and as well as in the create table? Now let's try to understand this through example. Here I have data set 1 and data set 2, and both have same variables id, age, and data set 2 also have same variables. Now whenever we do a dot star and b dot star on our joining thing which we have discussed for a while, what will happen is we will see all the variables id, age from both the data sets. So this is simple and nothing to talk about. But another important thing to remember is what happens when we create the table. When we create table, it cannot keep the same variable name twice. What it does is whatever we mention first here, that is a dot star, those variables will be kept in the data set and it will drop out the variables which are similar ones in the data set 2. So if you see in the results, we have information from data set 1 because the variables which are similar in data set 2 will be dropped. So this is one important point to remember. That's all for this topic. This topic is about subqueries, and this is part 6 of Proc SQL series. In this video, following topics will be covered. What is a subquery and what are types of subqueries, that is non-correlated subquery and correlated subquery, and also we will be discussing about some conditions like any and all, also exist and non-exist in subqueries. Now let us briefly look into what is a subquery. Subquery is nothing more than a query embedded within another query. If you look into the code here, there are two select queries, and the select query here is known as inner query or known as subquery. The outer one is known as outer query. Now that we have looked into what subquery is, now let us quickly look into types of subqueries. Types of subqueries are based on how outer query is related to inner query or how our subquery is related to outer query. In this we have two kinds. The first one is non-correlated subquery and the second one is correlated subquery. Non-correlated subquery is one in which the subquery is not dependent on outer query and can execute in isolation. Correlated subquery, if you see from the name itself, it's a subquery which is dependent on outer query and it cannot execute in isolation. We will try to understand both of these with the help of examples. I'm going to take these two data sets as an example. Here we have debit data set and credit data set. Debit data set tells about how much money has been deposited by each customer for a particular date. And the credit data set tells about how much each customer has taken from it or did a credit on a particular date. Here customer is represented as cust underscore ID and money underscore deposit indicates that money has been deposited on that particular date, and deposit underscore date indicates a particular date on which the money was deposited. And also cust underscore ID in the credit also indicates about the particular customer. Money underscore credit indicates that money has been taken and credit underscore date indicates that on which date that money was taken. Now let us see how subqueries will help us in solving a business problem. In here, my business problem is to get all the records from debit in which the customer IDs are there in the credit. So I want the information from debit to be seen, but the cust underscore ID should be there in credit. Now let us try to understand how this code works. In this code, as I said to you, the outside query is known as outer query, the inner query is known as subquery. Here what happens is inner subquery runs first and then it gives 1, 3 and 4. And once we get that results, the outer query runs and then what it does is it picks up only those records from debit which has either 1, 3 or 4. As we have only 1 and 4 in here, we get all the records related to 1 and 4. Here if you see, as I was saying you, that the inner query or subquery runs first, which means this part of the query can run on its own. Means if I take this query out and put it in separate Proc SQL, it will work. So this kind of query which is not dependent on the outer query are known as non-correlated subquery. Now let us look into another scenario, very similar and almost the same, but with a small difference. Here I want to find those observations in which the cust ID is not there in credit. Again, pretty much the same code, and only thing I have changed here is not in. Again, this query works exactly what I have explained you before. That is, the inner query or the subquery runs first and it gives the cust IDs of 1, 3 and 4. And now we are doing a select star from debit and we do not want cust IDs which belong to 1, 3 and 4. And here if you see, only 2 is the one which is not there in here, and that's what we see in the result here. Subqueries are pretty powerful in these kind of scenarios wherein we want to find records which are not there in another data set. Especially if you see the code here, the code is pretty clean and easy to understand. And if you want to do the same thing in a different way, the code is often little complex. Now that we have looked into non-correlated subquery, let's quickly look into correlated subquery. Before going into correlated subquery, let's again revise what is a non-correlated subquery. Non-correlated subquery is one in which our subquery or inner query is not dependent on outer query. Now let us look into correlated subquery. And I'm going to discuss this concept with the same example what we have been using before. I have just made this example little bit more simpler so we can discuss this concept in an easier manner. Now here again we have two data sets, debit and credit. And here the goal is to find observations from the debit data set where money underscore deposit is greater than average money underscore credit for a particular cust underscore ID. Now I will also try to explain this with help of a particular cust ID, and this particular cust underscore ID here is 1. Now let us quickly look into the query. Here I am saying select star from debit and I am aliasing this as A. As I want the records from debit data set, I am writing select star from debit. And here where money underscore deposit, here I want the money underscore deposit to be greater than select average money underscore from credit, which I am aliasing as B. This And also I want this money underscore deposit to be greater than average money underscore credit, but I want where a dot cust underscore id equal to b dot cust underscore id. So I want to compare this money underscore deposit with average money underscore credit only when the cust underscore IDs match. And how I am doing this is by writing a where clause here where I am saying this cust ID and this cust ID should match. And if you see this here, this kind of query is known as correlated subquery. This is because if we remove this particular piece of code and we want to run on its own, it will not work because it will be looking for a.cust underscore id which is there in the outer query. As I said earlier, I will explain whole of this concept through cust underscore id equal to 1. Now let's look into the code detailedly. When we do select star from debit, it is looking into the first observation when our cust underscore id equal to 1 and money underscore deposit equal to 1000. I'm not going to discuss about deposit underscore date because it is not very relevant. And this observation where the money underscore deposit is 1000, we are going to compare with cust underscore id equal to 1 and we are going to do average of money underscore credit. To do the average, we need to do 700 plus 1500 divided by 2 and it comes to 1100. 1000 is less than 1100, we are not going to see this observation into our result. But when we go into the next observation, we see our money underscore deposit is 3500 and the average is again 1100. So we will see this 3500 in the result because our money underscore deposit is greater than average money underscore credit. And the same is the case with cust underscore id 1 and money underscore deposit 4000. This also comes into our result because it is greater than the average. Now the important point I want to mention over here is this particular piece of code wherein in our subquery we have where a.cust underscore id equal to b.cust underscore id. This makes sure that we are comparing money underscore deposit and average money underscore credit from two different data sets only when the cust underscore IDs match. And this particular piece of code where a.cust underscore id equal to b.cust underscore id is what makes this whole query into correlated subquery, which means you just can't take out this query and run on its own. If we try to run, it looks for a.cust underscore id. So these kind of queries, again, how they run is it runs select star from debit and also it runs select average money underscore from credit simultaneously. They do not run one after another. But if you look into the code in here where I am talking about non-correlated subquery, I was saying that this select cust underscore id from credit runs first because it is not dependent on outer query. But here the inner query is dependent on outer query, it runs simultaneously. When I say simultaneously means both the queries are run in tandem. We have looked into non-correlated subquery and correlated subquery. And till now what we have discussed is the select star from outer query itself. We are not capturing any results from inner query. And in correlated subquery, we have an opportunity to capture the results. Now let's look into how we can do this. Here, for each particular cust underscore id, we want to capture when cust underscore IDs match the average money underscore credit. Instead of comparison, we want to capture this money underscore credit into our main data set or into our main query. To do that, it is pretty simple and straightforward. instead of doing our where comparisons like what we have been doing, what we will do is we will write select star, and this star is from debit dataset, and here we are mentioning that as A. And here we are not doing any where comparisons like what we have been doing, but what we are doing here is we have kept a comma and we wrote select average money underscore credit from credit, and we have said B, that is the alias for credit dataset B, and we have also where a dot cust underscore id equal to b dot cust underscore id. Here what we are going to get is we are going to get average credit for each cust id. Whenever the cust id matches from debit, we are going to get the result, and we are going to capture this result into a variable which is known as avg underscore credit. If you look into the previous query and this query, we have the same subquery, pretty similar, nothing different. All we are not doing is we are not doing a comparison, and we are also making this as a part of this particular query, and we are capturing this as variable. Now let us discuss any and all condition. Here, to explain this any and all conditions, I have taken different examples. The first one is data 1 and the second one is data 2. Both have variables name and money. And what we are going to do is we are going to compare money of dataset 1 with money of dataset 2. And whole of this thing we are going to do with the help of non-correlated subquery. Now first let's look into any, and then we will talk about all condition. For understanding any and all, we need to understand in which business requirement these conditions fit in. Here I have money in dataset 1, and here I have 3 rows, and in dataset 2 I have 2 rows. I want observations from data 1 wherein money is greater than any of the money in here. So the code exactly transforms to what I have specifically told about the business. That is, I want select star from 1, that is I want observations from dataset 1 where money is greater than any, and then here I am having my subquery where I am selecting money from dataset 2. So as I said to you, this is a non-correlated subquery, and this gives 150 and 205 as the result. And then we are going to compare each one of these with these two observations. So 100 is not greater than 150 or 205, so we are not going to see the first observation in our result here. Then if you see here, B 200 is greater than 150 and it is less than 205. As we have said any, we are going to see this result. Basically any means if it is greater than any of this money value, we are going to see in the result. And if we see 250, 250 is greater than both of them, so we are going to see them in our result. For all, my business requirement is I want to find observations from dataset 1 wherein money is greater than all of the money in here. Again, very similar code here, and exactly the business requirement transforms exactly into the code, and here I am saying money is greater than all. So here in the results what we see is we see those records in which in dataset 1 the money is greater than all of the money in here. So only C250 qualifies for this result, and that's what we see in the result in here. Now let us talk about the last topic, and this is exist and non-exist. And exist and non-exist condition I'm going to explain through an example in here. Here I have two data sets. The first data set is known as doctors underscore info, and the second data set is known as patients underscore info. Doctors underscore info has all the information about doctor. That is, doctor underscore ID tells about which doctor it is, and name, which tells about doctor's name and his specialty and hospital. Basically, detailed information about the doctor is there in doctor underscore info table. And patients table basically consists of the patient's visit to that particular doctor. Here we have patient underscore ID, which gives the information about the patient, and doctor underscore ID tells about doctor, and money tells about the money the patient has spent to the each visit to the doctor. Now here is the goal to find out all the variables from doctors underscore info table, wherein doctor underscore ID of doctors underscore info matches with doctor underscore ID of patients underscore info, and money is greater than 4,999. And here there are a couple of points to remember. If you want to directly change our business requirement into code, it is pretty straightforward. First, we need to write select star from doctors underscore info, and we are aliasing that as A because we want to see the results from doctors underscore info. And then we are testing for a condition here. That is, we are writing where exists. Exists basically means true condition. Whenever the condition is true, please give the results from outer query. That is, whenever the condition is true in our inner query or subquery, we are going to result from our outer query. So here the condition is select star from patients underscore info B, where A dot doctor ID equal to B dot doctor underscore ID and B dot money is greater than 4999. So whenever the doctor ID from this table and this table match, and also money is greater than 4999, whenever this condition is true, we are going to get a result from our outer query. And again, this kind of query is known as correlated subquery because we can't just run this part of subquery separately. And both of outer query and inner subquery are related. And also I want to iterate one important point here. Here, when we were doing other scenarios like comparing with the greater than or anything in the correlated subquery, we were comparing variables. But with exists, we are not comparing variables, but we are trying to find whether the condition is true or not. If it is true, we are going to get the results from outer query. And the very similar approach with non-exists also. In the non-exists, I want to find all the observations when the conditions do not match. So I want all the rows from doctor's info where this condition does not match. When I say not exist, whenever it is false, I want results from doctors underscore info. So basically this is very similar to what we have seen here. The only difference is here we are looking for a true condition whenever this matches, but here we are more looking for whenever the condition does not match. Now it is the time to conclude our subqueries topic. Subqueries are usually more readable. Subqueries gives tremendous flexibility, especially when you are doing some comparisons like greater than, or you are trying to do not in or not exist. Subqueries are easier queries to write. That's all for this topic. Topic is about create and alter statements. This is part 7 of Proc SQL series. In this presentation, I will be talking about various ways of creating table and how to look into table definition, and also I will be discussing on views too. And also we will very briefly touch on alter statements also. Now first let's look into how to create a table, and in this we are going to look into how we are going to create an empty table. An empty table can be easily created by using a create table statement. Here what we need to do is, after proc SQL semicolon, all we need to do is we need to mention create table followed by table name, followed by parenthesis. In this parenthesis, we are going to mention a variable followed by its attributes, and then a comma, and then another variable followed by its attributes. In this example, I have two variables, and these variables are known as name and age. And after name, I have these particular variable attributes, that is character, which I am mentioning as char, and also length I am mentioning in the bracket as 50. And then here the second variable I am just mentioning as num. Here for age variable we have mentioned only one attribute, that is its data type, and that is num. I can include more attributes like format, in format, and others. Simple rule to create table is just giving a create table and table name followed by a variable and its attributes followed by a comma, and then another variable. If we have more variables, we will put a comma and then we will write another variable. Now that we have looked into how we can create a table without any data, now let's quickly look into how to create a table with data. In this example, here we are creating data from another table. And in here, again, create table statement is very similar. We have proc SQL semicolon, and here I am mentioning create table and table name. And what we need to do here is we need to write as select star from the table which we want the data from, and then semicolon and then quit. In this case, the important point is we are writing a as, and then we are doing a select from another table, and we are creating a new table. Here there are certain important points which I want to discuss. I don't have to write star always. I can select fewer columns, and also I don't have to pick everything from SAS help.class. I can include a where clause, and then I can filter the data. Now we have looked into both how to create table without data and with data. Now let us look into something which is little bit more interesting. Here we want to create a table as other table but without data. For this, the code is little different than what we have seen before. Here I am saying proc SQL semicolon, again create table, table name. This is pretty standard all the time. As we want to create a table like other table, we are using like, and then here I am picking up the information from SAS help.class. Here one thing to remember is we are just copying the table structure. Here I would like to show that we can add one more important attribute, that is constraint. To be more precise, these are integrity constraints. And here for the name variable, I have written car 50, and also I have mentioned not null. Not null is an integrity constraint. I have made a very detailed video on the integrity constraints, and the link for the same I will give in the description below. Now let us look into something different. We can also alter the table. What do I mean by alter table? Let's look into the example here. Here I am using a data step and I am creating a data set. And this data set is BDF. And here I have three columns, col 1, col 2 and col 3. And here I also have a data. So after I have created the table with the data, I can add new columns also. And this is usually done with the help of alter table statement. And this is done by using alter table, and we need to give table name And here, as I'm adding a column, I need to mention add, and the column name I want to add is call4, and the attributes I want is car50. Not only I can add variables, I can also drop variables. All this can be done with the help of alter table. So alter table statement is mainly for adding or dropping variables after creating the table. This is sometimes useful, but most of the time we may not use alter table statement. Now let us look into another important thing. Now that we have created a table, let us see how we can see the definition of the table. To get the definition of table, we need to use describe table statement. And it's also super simple. All we need to say describe table followed by table name. And we are going to see the following in our log. It tells about how the table was created, and it pretty much looks similar like what I have shown you for create table statement. For this kind of thing, generally we use proc contents. Now that we have looked into how to create a table and how to look into the definition of the table and alter table also, now let's quickly look into view. Before going into the details of the view, I want you to understand few things. A view is nothing more than a query stored, and more on this with the help of an example here. Here I have a data debit and data credit, and I want to create a view out of it. And for this I have a subquery here. About this subquery I have discussed in detail in one of my other videos. A link for the same I will give in the description below. But now I want to focus more on the concept of view. Instead of saying create table, I'm saying create view. By using the word view, what we are really storing is this particular query wherein we are doing select star comma, and then we are writing parenthesis followed by select average money underscore credit from credit B, where a dot cust underscore id equal to b dot cust underscore id as average or avg underscore credit from debit A. I want you to understand that whatever I have set from the select star to quit, that part of the code is all stored in this particular view. So a view is nothing more than a stored query. There is no data in the view. And now let's try to understand this view little bit more. When I say this view means the concept of view, and let's try to understand it in a very step-by-step manner. Let's also do a describe view. When we write describe view, we get the following in the log. In the log, if you see here, there is a definition of view which is nothing more than a particular code which we have stored by writing create view. If you look into table definition, it has variables and it has a particular definition related to variables. But when we look into the view, it is all about the code only. Now, I also want you to understand it even more better what happens when we run a particular view. Here I am doing select star from our view, that is debit underscore credit. When I do select star from debit underscore credit, if it would have been a table, the query would have gone to table and got the data from the table. But this is not a table. So what happens here? When I say select star from debit underscore credit, what happens is first this piece of code runs, that is select star comma and parenthesis select average money underscore credit from credit B, where a dot cust id equal to b dot cust id as avg underscore credit from debit A quit. So the view runs and it fetches all the data. So you need to understand that a view is nothing more than a code, but when we run the code, we are going to get our results, and the results are pulled back again into this select star. So again, in two steps, I want to say, whenever we do something like select star from debit underscore credit, you need to understand that this debit underscore credit is nothing more than a piece of code which I have shown here. That piece of code runs in SAS and gets all the data, and then we are going to do select star from that data. Now that we have looked into view, I quickly want to tell one another point, that is, views are generally used for two purposes. The first purpose is for security. When a team decides that they do not want to give table access for each and every one, what they do is they create a view and give the view access to those people who are directly not involved in the business but they want to look into the data. That's the one reason. The second reason is sometimes some of the business users may not be able to write complex code. So what the team which is directly involved in the business, what they will do is they will create a view which may have a very complex code, and a business user who is not very well versed with SQL, what he does is he simply runs select star or select from that view to get his results. So he doesn't have to really write a complex code, but somebody is helping him out. That's all for this topic. Topic is about insert, update, delete and drop statements. And this is part 8 of Proc SQL series. Now let us start with insert statement. There are various styles of writing insert statements, but all of them have one thing in common, that is insert into table name. Let's look into the first one. To do that, first let's create an empty table. This empty table is ABC and it has two columns, name and age. Name is a character variable, age is numeric variable. And here we are inserting into ABC, the dataset ABC, and here we are giving values clause and we are inserting John and 40. So one thing always to remember is whenever we are doing SQL, the insert or whatever the operations we do depends upon the position. What do I mean by that? Here the first variable is name. So John, which is in quotes, gets inserted in this variable and 40 gets inserted into this variable. And here once the values are inserted, you can quickly see the results by doing select star from ABC, and this is the result we see here. Values clause is used to insert independent or single values. Generally this is not a preferred way of inserting rows, because whenever we want to insert we have to again insert a new value, again insert a new value. Most of the time we do inserts from other table. That's what we are going to look into the next slide. Here again we have two data sets, CKG, which has two variables, call1 which is a character variable, call2 which is a numeric variable, and it already has Johnson and 15 as its data. And we have another data set, CKF, and it has call10 and which is a character variable and call2, and it has values Madan and 19. Now if I want to insert into CKG from CKF, CKG table is known as target table. CKF from which we are entering the data into CKG is known as our source table. Again, we want to insert into CKG from CKF. and it is pretty straightforward. Again, for every insert we need to write insert into that particular data set name. So insert into CKG and select star from CKF. This inserts one row from CKF into CKG. And here I want to mention couple of points. Here whenever we do insert, we will see in the log also saying that one row was inserted. And also I want to mention one important thing here. That is call10 value is inserted into call1, call2 value is inserted into call2. As I said to you earlier, everything in SQL is dependent on positions, not the variable names. Generally, if we see in data step or proc append, it is all about variable names, but in SQL it's all about position. Now that we have entered one row from CKF into CKG, we can proc print the data of CKG and you can see the result in here that it shows that one row is also inserted. Now we have two rows, one initial row and then one inserted row. Even though insert statement looked very simple, I want to mention one important thing in here. Now we are looking into a different example where we have data test with call 1 and call 2. Call 1 is a character variable, call 2 is a numeric variable. And here we are having another data set test 1. Here the important thing to remember is call 10 is $15, which means the length is 15, whereas in the call 1 the length is 8. In input statement, whenever we don't mention the length for character variable, it defaults to 8. So here the call1 length is 8 and call10 length is 15, and here also you can see that the variable length is much longer than 8. So when we do insert into test from test1, where test1 the variable length is longer, we see something different. We get a message or warning in the log saying that character expression will be truncated when assigned to character column call1. Indirectly, it is saying that whenever we are trying to insert row from test1 into test, we are going to have a truncation. Now, if we see that after our proc SQL insert into test, select star from test1, after the insert is done, if we see the result by using proc print, we can see that our variable Madan Rao Chand has been truncated and it doesn't have the complete name. So whenever we are doing insert, one important thing to always remember is we should be very careful of lengths. And whenever our source table has a longer length, truncation will happen. So data gets inserted, but truncation will happen. So we have to be careful in this kind of scenario when the source table has longer length. Now let's talk about another scenario. Here again we have two data sets. Here we have data have in which we have three variables. Whereas in the case of data have one we have two variables. And if you see here, when we try to insert from our source table into target table, we get error message saying that our target table has more columns than our source table. And this is because this call 1 and call 1 matches, this call 2 and call 2 matches. But as we do not have call 3, we just cannot simply have the same syntax what we previously had. We need to modify our code little bit. Here we need to say proc SQL insert into have, and we need to mention the column names. We need to say call1 comma call2 and select star from have. So what we are directly telling is here we have call1 and call2. This call1 data will enter into call1 and call2 data enter into call2. As we are not mentioning call 3 will have a missing value as shown in here. And this is not the only way of inserting. There is another style which we can be done. That is insert into have. Now we are doing select call 1, call 2 and null or missing as call 3 from have 1. And then here what we are doing is call 1 of have 1 goes into call 1 of have, call 2 goes into call 2, and here call 3 we are inserting the missing value. The whole idea here is to map variables of have to have 1, and positions should match and they should be always same. Here there are two variables we are mentioning, and when we are doing select star, here also we are having two, then it works out. When here it has three variables, we are making sure that we have three variables in select. How many our variables we are mentioning in our insert, same number of variables we should also have from our select. And when we do proc print, it shows the inserts of this particular instance and also this particular instance, and you can see in the result in here. Now let's also quickly look into what happens when we insert with the fewer columns in target table. Here again, this is another example. In here we have a data set in which we have only two variables, call 1 and call 2, but our source has three variables. So in this kind of scenarios, when we have fewer columns in target table, we just can't use the simple syntax of select star. And if we are going to do that, we are going to get an error saying that our target table has fewer columns than our source table. So to adjust to this, what we need to do is we need to write insert into test, that is our target table. And instead of doing select star, we can just use call 1 and call 2. So the call 1 value goes into call 1 value of test, and call 2 value of test 1 goes into call 2 value of test. And after the insert, we can do a proc print and we can see that the particular observation or row is inserted. One important point here I wanted to mention, which I have not earlier discussed, is apart from matching of the positions, one more thing is also very important. Say here call 1 and call 1, if you see, they both are character variables. So when you are inserting, the matching columns by the position should also be of same data type. Now I would like to discuss one more aspect of insert. For example, here we have a data set, or here we are creating a data set wherein we are having an integrity constraint, and that integrity constraint is not null. So we have name, age, two variables in new underscore test data set, but for name we have not null integrity constraint. We cannot insert null values when we have not null integrity constraint. And if we try to insert null value into a variable which has not null integrity constraint, it's going to give us error. And the error will be something like this, saying that the add or update has been failed and it does not comply with integrity constraint. Now let us look into another statement, that is a delete statement. To understand this delete statement, we are creating a new dataset cars from SAS help.cars. Delete is exactly opposite to what we talked about insert. And here we want to delete all the records in a table. We can just say delete from and the dataset from which we want to delete records. This will delete all the records in the table. And also in the log it will tell how many records have been deleted. But in case if you want to delete only those records which belong to a particular category, we can use a filter something like this, wherein we are saying delete from cars where make equal to Acura. Means we want to delete those records only where the make variable has the value of Acura. So it will delete those records only. And not only this, we can delete records from one table based off another table. I don't have any code to show in here, but that is also another possibility. Now let us look into drop statement. Drop statement is little different. Here we are going to drop the table. What is the difference between delete and drop? Delete means we are deleting records in a table. Still the table will be there. Drop means we are totally dropping the table. The table will be no longer available. Now let's look into update statement. To understand update statement also, let's try to create the cars data set from SAS help.cars. Update statement is generally used to update values in a data set. And the syntax is pretty simple. Here we are saying update and then we are mentioning the table name followed by set. The set statement which we are using, there we are going to give our variable or variable names to which we want to assign a value. Here I am saying set type equal to SUVS. So what I am saying is update cars and for the type variable change all of the variable to SUVS. So what this will do is in our cars data set the type variable will have SUVS as the value. Now here we are updating all the values, but we don't have to do that way. We can only update those values in which we are interested. That again we can do by adding a where clause after update and set. Here we are saying update car set type equal to SUVS where type equal to SUV. What we are saying here is please change the variable value of type to SUVS when type equal to SUV. Whenever the type is equal to SUV, then only the values change or values are updated. Unlike the upper code or query which I am shown, wherein all the values of this particular variable are changed. And here these are simple update statements. Now let us look into update statement where it requires more than one table. And in here to understand this, let us look into two data sets, and these data sets are known as master and transact underscore file, and both of them has ID and name variables. And in here the goal is to update the name variable values in transact files, and we want to update these values whenever the IDs match in both the tables, and we want to pick up the name variable value from this data set, that is master. So we are updating transact underscore file and the variable which we want to update is name. Now let us see how we can code this. Here I am saying proc SQL, I am saying update transact underscore file as G, and as I want to update the variable name, I am saying set name equal to, and I am saying select name from master as m where g.id equal to m.id. So what I am saying here is whenever the IDs match, please pick up the name variable value from master and update the variable of name for the transact underscore file. So what this does is whenever the IDs are 1 and 1, these ITH and T are updated with Smith because the IDs match. This kind of code is known as subquery, and I have discussed in subqueries in detail in one of the videos, and the link for the same I will give in the description below. And once I proc print this transact underscore file, we can see that the ID 1 and 1, the values ITH and T are updated to Smith and Smith. And that's all for this topic. Now that you have watched this complete Proc SQL tutorial, now it's time to wrap up. To conclude, I would like to say two important points. The first one is, as you have learned Proc SQL, try to solve some problems. You can find a lot of problems in communities.sas.com or stackoverflow.com. And also, I want you to check out my other Proc SQL videos which cover some special scenarios. Now that we have completed Proc SQL, let us get into SAS Macro tutorial. And this is a complete SAS Macro tutorial and it will be around 6 hours long. Let's quickly look into the topics we are going to cover. Initially, I will be having introduction, then macro variables, and then I will also be talking about macro and macro parameters, and then conditional and iterative macro statements, followed by creating macro variables in Proc SQL and how to use them, followed by call SYMPUT, and then macro functions, and also about macro libraries, call execute, and scope of macro variables. And now I would like to advise one thing. When you want to watch this video, please do watch one video after another in the order I have mentioned in here. The reason being, one video or one topic builds upon the knowledge from other topic. So always go in particular order if you are starting, or if you know or already have some knowledge, you can pick up any topic and then learn. But if you are starting, please go in the order. We are going to see the part 1 of SAS Macro series, and this is introduction. And here I would like to tell a couple of things before going into the topic itself. Here I will be presenting a lot of information. Most of the information which I am trying to present here is what I will be covering in the future classes. So this will be a very high level class wherein I will be introducing a lot of concepts, and I want to show you here what macro can do and what is all about macro. But the details of all these things we are going to understand in the future classes only. So to sum it up, this class is all about giving a high level information about SAS macros. Now let us try to understand what is the main goal of macro. The main goal of SAS macro is to generate text. It works more as a text generator or a source code generator. Now we will try to understand this with examples. So in the text generation, we are going to discuss two kinds. Initially, I will discuss simple text generation like text generation for dataset names or variables, or how to generate lots and lots of code using SAS macro. Now, as I said to you, this is a very high level class, and in the future I will be going into details of all of this. Now let's try to understand the simple text generator. And here I'm using this with the help of %let statement, wherein I will be showing how to generate text, especially in the case of simple scenario. Now here I have a %let statement, and here I am saying %let dsn equal to SAS help.class. Here we are creating a macro variable, and a macro variable has the value of SAS help.class. So what do you need to understand here is whatever we are storing in the macro variable itself is simple and plain text. And here, once we have defined our macro variable, I can access this macro variable in the below proc. So what is happening in here is I am referencing this macro variable by using ampersand dsn. So when ampersand dsn is used, what is happening is it is going to generate this SAS help.class here and here. So if you can see in this example, what we are doing here is generating simple text for our procs. Now more on %let statements and others in separate classes. I will be having individual class for %let statement. Now let us quickly run this code. Here I have added one more thing in here, that is option symbol gen. Symbol gen is one of SAS macro debugging option wherein it gives the value of macro variable itself, or it gives how this value is resolved or what is the value it is resolved into. Now let us quickly run this piece of code and see what is happening in the log and also what is happening in the result. In the result we can see that it has done proc print, proc mean and proc freak. And let's also look into the log. In the log it says that our macro variable &dsn is resolved to SAS help.class. This is what I was talking about. That is, this DSN is resolved into a text, and this text is used here for our proc print. Now this proc print becomes proc print data equal to SAS help.class run. In the same fashion, for other two procs also, this DSN, or rather ampersand DSN, is resolved into SAS help.class. This is, in a way, we are providing text to these procs with the help of our macro variable which we have created in here. Now let us look into our next example. Here we are going to generate code, not simple text like what I have shown you earlier. To understand this, let us look into an example here. Here I have a dataset have, and I want to append have to dataset want. I can simply use proc append, but I want to do it 100 times, which means I want to do proc append base equal to want, data equal to have, run. I want to write 100 times so that the data in the have appends in want for 100 times. So if I have to do this without the help of macro programming language, what I need to really do is I need to write this step 100 times. Instead of that, what I can do is I can create a simple macro and then execute that macro, which will create all of these statements 100 times. So in a way, we are generating code 100 times. I again know that I have not taught you anything about creating and executing macro, but we will be seeing that in our future classes. Now let us see this in real time, how we are going to do it. Now here I have the same data set have, and I am using here a macro which I am calling it as ABC, and then I am also executing this macro by using %abc. You need not know everything, or you need not understand everything in here, but what I want you to understand here is how macro programming language is helping us to generate the text without we typing it. Now I also have options mprint in here. What mprint does is it gives the SAS statements which are created in SAS macro. SAS macro is nothing but whatever we are creating in between this macro and ment. Now let us quickly run this whole of this code and then look into our log, and then we will understand it much better. Now once I have run this code, and let's look into our log. If you look into our log and let's go very up, we can see that there is a lot of proc append statements here. See here, there is one proc append statement, there is two, there are close to 100 proc append statements. So if you think closely, without typing this proc append base equal to want, data equal to have, run, the macro itself is creating these statements for us 1 time, 2 time and 100 times. And if you look into the data of the want will have close to 400 records because it has appended so many times. 4 records, each one of them have, and then I have appended it 100 times. Here another important thing I want you to remember is I have made a video on this, and link for the same I will give in the description below. It goes in little bit more detail about this. But with these two examples, what I want you to understand here is macro programming language is more of a text generator, and I want you to think in the terms that whenever you want to provide some text or whenever you want to generate some code, you always think about macro programming language. Now that we have looked into how macro programming language works as a text generator, now let us quickly look into how the macro program is used in the real time. These are some examples. I'm not going to go in detail into any of this. I will touch base it at a very high level. Again, we are going to come back to all of this in the future sessions or classes. Now, the macro programming language is helpful in 4 points here. I don't want to read out, but let's see it in here. So, macro programming language, we can create a macro variable in some step. That is, here I have a proc SQL step, and these macro variables which I am creating in here, I can use in some other step. So macro programming language is very helpful if you want to create macro variables in some step or somewhere and use it somewhere else. And then next one is, as I've already shown you, you can repeatedly execute any procedure or anything. Here we have repeatedly executed this code 100 times. And the next example, let's look into, again, I'm not going to go in the details of this one. Here again, we have a macro. And here what we are doing is, depending upon the parameter we pass here, we will either proc print or we will either do this data step. Whatever the value we pass here, if we are going to pass happy here, if happy equal to happy, then this is going to execute. So again, we are creating a macro and we are executing a macro, but the control we have is if we want to do this step or we want to do this step, we can conditionally execute it. These percent if, percent then, percent do look little bit complex. So I don't want to go in detail in here, but we will be touch basing that in the future classes. But what I want you to know is a macro programming language gives you a control to conditionally execute a data step or a proc step depending upon the value we pass in here. Now let us quickly run the code what I have shown you earlier. But here also I have options mprint and mlogic. I have spoken about mprint earlier. Mprint, mlogic are SAS macro options which we generally use to debug the code. Mlogic tells about how a macro is executed. Now let us quickly compile our macro and also let's run the options too. The compiling of macro means we are running the code from %macro to %ment, which is our macro. And once we have compiled, I can pass the parameter I want to pass. That is, here I am passing val equal to happy. That means I am giving this macro variable value val as happy. And then let's quickly run that. Once we run this code, you can see that SAS help class has been printed. And let's quickly look into the log also. Here the log, you can see that proc print data equal to SAS help.class run has been printed, and you can see that the condition happy equal to ampersand val is true because we have passed happy as the value. Now if I run val equal to sad, that is my macro variable or my macro parameter value as sad, then you are going to see that we are creating a data set. And let's quickly look into the log. So in the log you see that the happy equal to ampersand val condition is false. That is what our mlogic tells us. But the most importantly, you can see that this piece of code is executed. So what I want to tell from whole of this thing is, depending upon the value we pass, we can have control to do a proc print or to create a data set. This kind of thing is generally very difficult to handle without having any macro. Again, I want you to focus on one important thing. That is, whenever we are running this whole of this code, you need to remember that we are generating this text or this text. After the code is generated, it is executed with the SAS compiler. One of the most powerful aspect of SAS macro programming language is how flexible it makes the code and also how generalized it makes the code. Let me explain you through an example. For example, here I have three procedures which I want to execute, that is proc print, proc means and proc freak. And I want to do that on a same data set, that is SAS help.class. So what I could do simply is I can write %let dsn equal to SAS help.class and I can reference them at three places like this. What is the advantage of writing in this fashion? For example, tomorrow you are not interested in SAS help.class but you want to do SAS help.cars. So what you can simply do is you can simply write %let dsn equal to SAS help.cars. As the macro variable name dsn is same, it will pick up now SAS help.cars instead of SAS help.class. Now let us look into the code we have just now discussed. Here I have my %let statement here wherein I am saying %let dsn equal to SAS help.class, and then I have my proc print, proc means and proc freak. All of them have data is equal to ampersand dsn. Now let us quickly run this piece of code, and after running the code, let's quickly look into the results also. In the results you can see that we have proc printed SAS help.class and we have means related to SAS help.class. And here now I want to change this class to cars. So simply what I can do is can change the SAS help.class to SAS help.cars. It is super simple. I did not have to change at three places, but I have to change in one place. And once I run this code, it will print and it will do everything related to SAS help.cars. Now, the data set of SAS help.cars is much bigger, so it took some time. Now you can see that we have different proc print and different proc means and others. So if you see, there is a lot of different information here. The main emphasis point I want to say in here is, for example, if I had some 20 or 30 statements, which are most often the cases in the real world, I have to change at one place and everything follows through. This gives a tremendous amount of flexibility. And whenever you have a scenario when you're using the same thing at multiple places, always use a macro variable so that if you want to make any changes in the future, it will be smooth and you don't have to repeatedly write the code. You just need to change at one place and everything flows through. I just came up with some applications. There could be many more applications. Now that we have looked into what is a SAS macro and what are some common applications, now let us look into how SAS macro works. So whenever we have SAS macro related code, that is whenever we have percent or ampersand symbol, which are known as macro triggers, they work first and then the remaining code, which is a data step code or maybe Proc SQL code, it runs later. So to understand this, let us try to understand it little bit slowly. Whenever we have macro references along with the code, we need to understand that macro references are resolved first. And this is because of design, because we want macro processor to generate code for our data steps or other procs. This is a very important thing to understand. And let's try to understand this by looking into next slide. Here again we have %let dsn equal to SAS help.class, proc print data equal to ampersand dsn run. When we run %let dsn equal to SAS help.class, we are going to create a macro variable. And we are going to reference in this proc print. Now we need to understand one thing in here. When we run this proc print, the proc print itself is not going to run immediately, but first this ampersand dsn resolves to SAS help.class. Something like this, proc print data equal to SAS help.class run. After this ampersand dsn is resolved into SAS help.class, then only proc print runs. And as I said to you earlier, anything with the symbol of percent and ampersand followed by a non-blank is known as macro triggers. When SAS macro processor looks into this ampersand or percent symbol with a non-blank character, it will execute immediately. And this is very important to know. And now let us try to understand whole of this in more detail and in a form of a visual. Whenever we run our code, for example, in here we have our code like %let macvar equal to SAS help.class, data class set ampersand macvar run. We need to understand that the code immediately goes into memory, and this is known as input stack. Once the code is in input stack, what happens is there is a word scanner which looks into each of these words and will try to understand what kind of words they are. Or rather we could say it looks into them as tokens, whether this is a literal token or whether it is a number token or whether it is a name token and whether it is a special token. Percent symbol and ampersand symbol are special tokens. Whenever this percent symbol or ampersand symbol are seen by macro processor, it immediately executes them. In here what is happening is, as soon as it sees the %let statement, what happens is this macro processor looks into them and then it creates this macro variable and keeps into a symbol table. More on the symbol table as we move to the future classes. And then this whole of this code goes into a compiler. And once this ampersand macvar is resolved into SAS help.class, which gets its value from the symbol table, then the compiler will compile this data step and the code execution happens. I have not really gone to the details of how tokenization happens. That is how each word is checked line by line, word by word, and then how they are analyzed and all those things. But the important point here, what I wanted to say was, there is a macro processor after this tokenization wherein it looks into macro triggers and will try to resolve or work on them immediately even before the code is compiled. Now I would like to focus or explain how I am going to teach SAS macro programming language. I will be discussing or I will be focusing on three main concepts, and these three concepts are very important to know to work in the real time. The first one is simple substitution. Second one is how to create simple macros. And the third one is dynamic programming, wherein you are not going to do any hard coding or you are not going to pass parameters, but you are going to write programs which are data driven. And here we will be using call SYMPUT or into clause followed by usage of control table and call execute. Even though I have mentioned here three concepts, we will be covering various topics like %if then statement, SAS macro symbol table, SAS macro function, SAS macro libraries, and others. Now let's look into each one of them very briefly. Simple substitution looks something like this, wherein we will be creating macro variable and we will be referencing those macro variable in our programs. And also the macro program creation is also something like wherein we start with a macro and wherein we end with mend, and we have lot of program in between, and then we are going to execute this macro. And the third and the final one is dynamic programming. Here, to understand this, let me explain you with a simple example. Now I want to proc print all the datasets of SAS help wherein the dataset name starts with C. Instead of passing something like this wherein I can pass dsn equal to SAS help.class and something like that, I want to write a program wherein I really don't have to hard code anything, but I can create a macro variable somewhere in here like as shown in here, and then I can do a proc print. This kind of program is not dependent on any human intervention or hard coding, but rather it depends upon the code the way you have written it, which means you are handling everything in a very dynamic way and very data driven way. Now it's time to conclude our introduction. In this introduction, I have covered quite a few topics. The first one is I try to explain what a macro facility does. And what a macro facility does is it generates text. It should be text generation, not text substitution. And it can generate simple text or lot of text. And macro programming language has lot of applications like passing values between one step to another, running multiple times same proc or data step, or conditionally executing proc or data step, and also it helps us to make a flexible code. And now let's try to look into another important point which we also discussed, how macro facility works. The most important here is macro triggers, which are percent and ampersand followed by a non-blank character, work earlier than our SAS programs, which could be data step or Proc SQL or anything else, are compiled later. And our learning strategy will be simple. It will start with simple substitution followed by writing macro programs and finally dynamic programming. That's all for this topic. Topic is SAS Macro Series Part 2, and in this we are going to talk about macro variables and %let statement. There are many ways to create SAS macro variables, and one of them is %let statement. And here I want you to understand few other things about macro variables. Macro variable, the naming convention is very similar to SAS data step or Proc SQL variables. And those rules are the variable name or macro variable name should not be greater than 32 characters. And also the variable name should start either with underscore or with a character. And also we can have only underscore, character or number as a part of our macro variable. Once we have looked into what are the characteristics a macro variable name should have, now let us also try to understand here the %let statement very quickly. Here I am defining %let dsn equal to SAS help.class. Here dsn is our SAS macro variable name, and here SAS help.class is its value. And I want you to also remember the value of the macro variable should not be more than 65534 bytes. This is not a very important thing to remember, but just in case. And also, this value is a text. Once we have created our macro variable by running this particular statement, we can reference this macro variable by using ampersand dsn. Whenever we are doing ampersand and the name of the macro variable, this is known as referencing the macro variable. Now here we have proc print data equal to ampersand dsn run. This macro variable value resolves once we run this proc print, and then the proc print itself will work. Now I want you to understand how the code works. When we run proc print data is equal to ampersand dsn semicolon run semicolon, we need to understand that first the macro variable resolves and it becomes SAS help.class, and then proc print works. Here I want to remind you one point which we have discussed in the earlier class. That is, ampersand and percent are macro triggers and they execute first even before any other code is compiled and executed. So always macro variable resolves first and then this piece of code runs next. Now let us look into another aspect, that is percent put statement. Percent put statement is very similar to put statement. Put statement deals with the text and variables of data step, whereas in the case of percent put, it takes care of text and also macro variables. Now, when we say percent let dsn equal to sashelp.class semicolon, and when we run this code, we are creating a macro variable and we are referencing this macro variable by using a percent put statement. As and when we use put or percent put, we have to remember that the main concept there is to put the values in the log. But percent put deals with macro variables rather than variables. Now, when we run this percent put statement, we are going to see this in the log. That is, we are going to see that this ampersand dsn has resulted in SAS help.class. Now that we have understood percent put, now let us quickly focus on what is the difference between put and percent put statement. Here I am having a data step data underscore null underscore, and I am having a put statement and I have some text. Whereas in the case of percent put, I have another text. If you see here, put statement comes before percent put. When we run this piece of code or when we run this data step, what you will see is, you will see this percent put executing first even before put. And this is pretty clear from what we have discussed in the last class and just a slide before. That is, percent and ampersand are macro triggers and they always resolve first than anything else. So here, if you run this code, this is what we see in the log. We see this is for percent put statement. We see this resolving first and then this put statement value resolving next. So let us try to understand how this whole thing works. When we try to compile this code, what happens is, even before this data step is compiled, this percent put statement runs first and it gives us this value. Then this data step compiles and then this put statement gives us the result as you can see in here. If you see here, the put statement value, this is for put statement, comes after the data step is complete, which means after this code is compiled and executed. And percent put statement is very useful, especially to debug. Now let us look into another aspect of macro variable resolution. Here I have pretty much the same code, but here we are creating a new variable %let mac var equal to m. And here I am doing proc print data equal to ampersand dsn semicolon where sex equal to double quotes ampersand mac var double quotes run. Here it is going to resolve into m, and then we are going to get the proc print where sex equal to m. Here the important point to remember is here we have double quotes. And macro variable, when kept in the quotes, it only resolves when it is in double quotes, but not when in the single quotes. When we try to resolve the macro variable in the single quotes, it just simply picks up as a variable value but not as a macro variable. So whenever we try to put ampersand in a single quote, it will not look for macro variable. Now let's also try to understand by running the code. Here I have my %to let statements, and here I have proc print where I say where sex equal to double quotes ampersand mac var double quotes close semicolon. Here another important point to remember is I have option symbol gen. Optional symbol gen helps us to understand what the macro variable has resolved into. Now once I run this piece of code, it's going to proc print SAS help.class where sex equal to m. And also if you look into the log, it's going to tell us that macro variable mac var has resolved to m, and then it has printed what we want to print. We can also see that from the note, wherein we can see where sex equal to m. That is our mac var has resolved into m. Now let's try to run the same thing but in single quotes and see what happens. And here we don't see anything in the results here. But let's also have a quick look in the log. In the log, we see that ampersand dsn as resolves to sashelp.class, but there is nothing related to ampersand macvar which is in single quotes. What does this mean? This means now this value appears more as a variable value rather than a macro variable. So it is no longer going to look into macro variable and then going to pick the value from there. Here also it says that no observations were selected because there is no data with ampersand macvar in sashelp.class. So it is very important to put double quotes whenever you want to put a quote and resolve the macro variable. Now I would like to emphasize on another important concept, that is macro variable is a text. I might have repeated this so many times, but this is an important point to understand. Here, if you look into previously, what we were doing, we were trying to get %let mac var equal to m. And then what we are trying to do is ampersand mac var, and we are trying to put double quotes around it. But if you want to have the same thing, we really don't have to have double quotes and everything in here. What we can directly do is we can define %let new mac var equal to m double quotes, and we can do the same proc print. What is happening in here is it finally resolves to where sex equal to double quote m here. So what I want to make you understand is either this way where you create a macro variable and put it in double quotes will work, or directly put a double quotes here and use it in here. Now I also have %put statement here, so I can put the value into the log. And here I have also written additional text so that my %put is more cleaner. Now let us try to understand these by running in our SAS Studio also. Here I have my %let statement, that is %let new mac var equal to double quotes m. And I have also have my %put statement where I am saying value of new mac var equal is ampersand new mac var. So when I run this, it is going to put the value of m with the double quotes in log. Run. Now let us run the proc print too. In the proc print, you can see in the log that new macvar resolves to double quotes m. So whenever you want to create a macro variable, think strategically. Think in the terms of that it is a text and first it resolves and it gives the value you want. So you can put the double quotes or whatever it is in your macro variable itself. I want to continue couple of more slides and explain you in more detail that macro variable is text. So one important point when you talk about macro variable as text, that we are indirectly telling that it's neither a character nor a number, it's just a plain text. So there is no concept of null. When we talk about a character variable or a numeric variable, we have a way to represent null or missing value. But in the case of macro variable, text is there or text is not there. For example, here I have %let hello equal to semicolon. I don't have any text. This is what it does not have a value means. So it is not like a null or an unknown value. So if we want to use this ampersand hello somewhere like this, it's not going to resolve into any text and it is going to proc print without any problems. In here I have proc print data equal to ampersand macvar1 which resolves into SAS help.class and ampersand hello, it resolves into no text, so it just stays as sasf.cars and this proc print will run fine. Same is the case with proc means here where I have sasf.class and ampersand hello. Ampersand hello does not have any text, so it stays as sashelp.class itself. This is a very important point to remember. Now let us take it further. I have some examples of %let statements and also have my %puts in here. One another important point to remember from %let statement is whenever you have space in front of text or after the text, it is not stored in your macro variable. And also I have three other macro variables wherein I am creating with some other thing than what we generally think of text. I have quotes here, I have double quotes here, I am having some symbols here. The important point to remember is whatever you have will be stored as such. It's not going to resolve into something else. It is a plain text and it comes out as text when you try to resolve in it. Another important point to remember is the space in front and the back of the text is not stored, especially when you are creating macro variables using %let statement. Now let us try this in our SAS Studio very quickly. Here I have the same thing what I have shown you in the slide, and here I am trying to do the %let statements followed by my %put, and also I have the pipe in here. The advantage of using pipe like this, if there is some space in front of it, it will show up. Now let us quickly run all of this and see what are our results. Now here if you can see our results are value of A is high. Even though we have space, that space was removed. And here we had a space at the back. For C we had a space in the front and back. All the spaces have been removed. That is true with %let statements. Whenever we create with the %let statements, we cannot store the space before and after the text. And if you see here, the macro variables wherein we have quotes, it resolves as it is, as the text you can see in here, as the text you can see in here. Now let us look into another concept, that is overwriting macro variable values. And we will try to understand this through an example. Here I am defining macro variable %let dsn equal to sashelp.cars, and I am referencing this macro variable in my proc print in here. As my macro variable value is sashelp.cars, the proc print will print sashelp.cars dataset. Now that we have created a macro variable does not mean that the macro variable is there for the whole SAS session. We can always overwrite it. Overwriting the macro variable is again very simple. All we need to do is %let dsn equal to sashelp.class semicolon run. That is, we need to run another %let statement wherein we can change our value, and here we have changed the value to sashelp.class. And now when we proc print, the proc print will print the data set related to sashelp.class because now our macro variable value is sashelp.class. So overwriting macro variable values is super simple. All you need to run is run again the %let statement followed by proc print or whatever you want to do by referencing that macro variable. Now, we should also look into another important aspect. That is, there are some macro variables which belong to SAS session and which are created by SAS, which we can't overwrite. Those macro variables are known as automatic macro variables and we cannot overwrite them. To look into what are those automatic macro variables which are created in the beginning of the session, all we need to do is we need to write %put underscore automatic underscore semicolon, and when we run this we will find the automatic macro variables. There are many automatic macro variables which are created in SAS session, but here I have pasted few of them. If you look in here, sysday is another macro variable which is the value of Friday. I ran this %put underscore automatic underscore on a Friday, so my sysday has a value of Friday. If I try to do something like %let sysday equal to Sunday semicolon, it is going to give me an error and it will say that attempt to assign a value to read-only symbolic variable. What does that mean? Symbolic variable means macro variable. Whenever it says read only means we have only the way to read from that value but not write to that value. Now let us dive into another topic, that is how to add text to the macro variable. I have made a very detailed video on this topic and I will give the link for the same in the description. Now let's get into the topic itself. Here I am defining my macro variable %let c equal to hi. This macro variable I can reference as $c or $c dot. Both of them are going to give me the same result of hi. Now if we run this code, we are going to see the following result in our log. If you see, the value of c without dot is high, value of c with dot is high. So both of these statements just resolve to high. I mean to say the macro variable resolve here into high. So the dot in the macro variable, what it tells is, it tells that this particular macro variable has ended. And anything after that dot is not part of that macro variable. This is very important and very useful, especially when you add text. Now let us add some text to the macro variable and see what happens. Now here my macro variable I have defined as %let macvar equal to Smith. I can add text in front of the macro variable. In this case, I have done %put name is $macvar. Here, what happens is, as this $macvar, ampersand is a macro trigger, this $macvar resolves first, and as name is in front, this becomes name is Smith. So this is pretty straightforward scenario. But what happens if we add text at the back of the variable? That is, if I add $macvar, after that if I want to add John to it, what will happen is it will think that the macro variable you want to give is ampersand macvar John, and we will get a warning saying that apparent symbolic reference macvar John not resolved. So it is very important to do something wherein we are saying that this macro variable is ended and everything afterwards is text. Now let us see how we can do that. Doing that is super simple. All we need to do is we need to add a dot, and then this resolves to Smith John now. So what is happening in here, ampersand macvar dot first resolves into Smith, and John is a text and it becomes Smith John. And this is very important to understand. Whenever we want to add text to the back of a macro variable, we always need to add dot, and this dot is the part of the macro variable and it resolves. If we are not going to do this, we will be having the problem that the particular macro variable does not exist. And if we want to have something like Smith.John, we need to add two dots here. That is %put ampersand macvar dot John. So what is happening in here? First ampersand macvar dot resolves into Smith. The next dot is a text. You can see here, and John. And this becomes Smith.John. Now let us look into the last topic, that is direct and indirect macro variable reference. Till now what I have discussed is direct reference. That is where we are using single ampersand. For example, here I am defining my macro variable %let name1 equal to hello, and I am trying to reference this macro variable using a single ampersand. That is %put value is ampersand name1. This is a single ampersand and this resolves into hello. This is a pretty straightforward scenario. Now let us look into an indirect macro variable reference. This is really very helpful, and the reason for using this kind of thing we will discuss in the future classes, but for now let's try to understand what is indirect macro variable reference. For understanding indirect macro variable reference, let us try to use the same example. That is, we want to use %let name1 equal to hello. Here I have another macro variable %let I equal to 1. The goal now is to use name, which is a part of macro variable name here, and ampersand I, and we want to resolve hello, which means a part of the macro variable name here and this macro variable to resolve into this particular value hello here. If I do %put ampersand name ampersand I, what happens is, as we have not defined macro variable name, we are going to get a warning saying that apparent symbolic reference name not resolved. But ampersand I is there, ampersand I resolves to 1. So finally we are not able to resolve back to hello. How we can do this? We can do this with the help of indirect macro variable reference, which is by using multiple ampersand. Again, instead of using single ampersand name ampersand I, if you use double ampersand name ampersand I, this resolves to hello. Now let us try to understand how this works. Macro variable reference starts from left to right. So what happens in here is two ampersands resolve into one ampersand first, and this ampersand I resolves into 1. Now it will again go into another pass wherein this ampersand name 1 resolves into hello. So to sum it up, in the first pass, ampersand ampersand name ampersand I became ampersand name 1. In the second pass, ampersand name 1 resolved to hello. Now let us try to understand this more deeply by using SymbolGen. Option symbol gen helps us to know how macro variables are resolved. Again, here I am using percent put ampersand 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 I, but I have the option symbol gen. So option symbol gen tells us how the whole thing resolves. Symbol gen says that ampersand ampersand resolves to ampersand. Ampersand I is resolved to 1. And now we are left with ampersand name 1, that is macro variable name 1. Macro variable name 1 value is hello. Here the important thing is to understand that if we have used a single ampersand, it would have resolved immediately. Because we have used two ampersand, what has happened is the macro variable has not resolved immediately, but it resolved when we wanted it to resolve. So these two ampersand became one ampersand and this became ampersand name 1 and we were able to get hello. I have covered lot of topics for macro variables, but not all the topics related to macro variables, and some of them we will be discussing in the future classes too. That's all for this topic. We are going to look into SAS Macro series part 3, wherein we are going to discuss about macro and macro parameters. Let us quickly look into what is a SAS macro and what is compilation and execution of SAS macro. Here SAS macro can be defined by writing %macro followed by name of the macro. Name of the macro should follow the same rules which we follow for variable name. And then we have some code in here. For our context here, this code is not very important for now. And this macro ends by %ment and we have macro name. We don't have to give this name, but for more clarity, we can have macro name also followed by %ment. So this is a simple macro. And once we run this piece of code, it is known as compiling a macro. And we can execute this macro by doing % and the macro name. Now I'm going into lot of details with what is this compilation means, what happens at compilation, what happens at execution. Before doing all those things, I would like to explain briefly what are the advantages of SAS macro when compared to simple %let statements. %let statements is designed to replace simple text, whereas in the case of macro, you can create or generate a lot of text and also you can automate a lot of processes by embedding a lot of logic in the macro. This kind of macros we will be seeing in the future classes, but now I just want you to understand this one difference before going into the details. Now let us try to understand what happens during compilation of macro. During compilation of macro, only macro related syntax is checked. And if there is a syntax error, we will see that a message saying that there is an error and a dummy macro has been created in our log. And when we say dummy macro means the macro which we want to create has not been created. And couple of things happen during compilation of a macro, and this are important to know. First, macro will be stored in a macro catalog and macro statements are compiled and stored while everything else is treated as text. And now let us try to look into our macro once again. Here only where we have %macro and %ment, this syntax is only checked, and proc print, which is not related to macro but it is a simple procedure, will be treated as text. Now let us try to understand this in a more of pictorial form, and this is something which I have shown you before in the very first class. That is what happens when we run the code, what happens and how macro processor deals with whole of these things. Let's try to understand the same, or let's try to use the same and try to understand our SAS macro compilation. Whenever we run the code will be in input stack, that is in memory. And word scanner looks into word by word and understands whether it is a literal number, name, or it is a special token. And once it understands that this is a special token and also it has a percent and it has a percent here, macro processor understands these percent symbols. As I have told you earlier, percent and ampersand are known as macro triggers, and macro processor understands this, and then once it looks into macro and percent meant, during compilation what it does is it stores the macro in macro catalog. Now how it is stored and what are the some more details of this catalog, let me show you in here. Here the catalog is in work area and the name of the catalog is SAS MAC1, and this is for SAS Studio. For others, this catalog name could be different and it could be something like SAS MACR. But the important thing to understand is whenever we run our macro or compile our macro, it will be stored in one of the catalog in here. Now I have used proc catalog and set catalog equal to work.sasmac1 contents run and quit. This will tell me what are the macros that are stored in my catalog, that is SAS MAC1. It tells me that there are a lot of macros, but I am more interested to show you there is a test macro which we have created in here, and then you can see that when that macro was created and whether it was modified or not. So the important point to know is your macro is compiled and it is stored in a particular catalog. And now I want to go into further more details about the compilation itself. Here again I have my percent macro and percent meant, but after this macro I do not have a semicolon. After the macro name, it was supposed to have a semicolon. I did not write the semicolon for the purpose of illustrating that when you don't have a semicolon or macro syntax related issue, we are going to see an error saying that expected semicolon not found, macro will not be compiled. And also we will have an error saying that a dummy macro will be compiled. Now let us try to understand the same thing pictorially. Again, the code goes into the input stack and the word scanner does the tokenization. Here the macro processor understands that there is a syntax error and it will no longer store the macro in macro catalog. And if we run proc catalog and try to see whether this macro has been stored in the catalog, we will not be able to see that the test one has been stored in the macro catalog. Now let us quickly go into little bit more deeper and try to understand more about the compilation. Here everything is same, the macro name is test2 here, and one difference in here what I have done is I have given syntax error for this proc print. As I told you earlier, anything which is in the macro, if it is not related to macro statements, it will be treated as text. So it will never look into the syntax error of this proc print. I wanted to say that this proc print is missing a semicolon in here, but it is never looked into because this whole thing is treated as text, and once we compile this macro and we run proc catalog, we can see that this particular macro has been compiled and stored. Now let us look into macro execution. A macro execution can be done by writing percent followed by a macro name. We don't need any semicolon for this. And when we run this piece of code, that is percent macro name, what happens is it comes into input stack. And then word scanner looks into this. As we have percent sign followed by macro name, percent sign is a special token and it is also a macro trigger. So macro processor understands this, and what it does after it sees percent followed by macro name, it opens the macro catalog and reads this macro. And then what it does is it finds the text in here and it puts into the input stack, and then again the word scanner reads this, and there is nothing here for microprocessor, so it goes into the compiler and proc print data equal to SAS_help.class run will run. So here I want to mention couple of things. Whenever we are executing a macro, generally it is a repetitive process. Here what happens is, first it opens the macro catalog and it reads this macro, and then it puts whatever it is there in here into the input stack, and again it follows the same process. Here we are talking about a simple macro, but what happens if we have macro parameters and macro statements? We will look into that later. Now that we have looked into SAS macros without any parameters, now let's try to understand SAS macro parameters. SAS macro parameters are nothing different. They are also SAS macro variables. And SAS macro parameters, what they do is they make the SAS macro more dynamic and useful. Two of the important parameters which we are going to discuss are positional and keyword parameters. These macro variables which are created as a part of parameters are known as local macro variables. Local macro variable means those macro variables which are available to that particular macro which creates it. Now let's try to understand these positional parameters and keyword parameters with an example. Here again I have my macro and meant, and after my macro I have a macro name, and here I have given it as more functionality as its name. And in the bracket or parenthesis you can see I have three parameters. The first one is known as DSN, and then I have a comma, start, comma, and then end. Means here I have three macro variables. And the first one is DSN, second one is start, and third one is end. So here when we are saying three parameters here means we are creating three macro variables. And these three macro variables I am using in here, and in here. And in here I have proc print data equal to ampersand DSN, first ops equal to ampersand start, ops equal to ampersand end, and then I am closing my parenthesis, semicolon, run, and then percent meant. Means I am finishing up my macro in here. Here I have also written SAS macro execution, wherein I am passing SAS help.class, and this will have the value of DSN. Means this SAS help.class will be passed on to here. And when I am passing 11 and it is start, so it will have the value of 11, and for end I am passing the value 15, so it will be 15. So whole of this will become proc print data equal to SAS help.class, first ops equal to 11 and ops equal to 15. So simply what we are doing here is we are trying to do a proc print for a particular data set and starting from a particular observation ending with a particular observation. There are few important points to understand in here. This is positional parameter. What does that mean? Whatever I pass here will be passed on to this value. Means I can't change the order. The order has to be same. So here we have start. When I have 11 here, it corresponds to this value. If we try to change the order, for example, if I want to put 11 first and then SAS help.class, comma 15, what happens is 11 is the first value and DSN becomes 11. So this will become proc print data equal to 11 and this program is going to fail because our proc print is going to look into the value of 11. So the important point I want to mention in here is whenever we have positional parameters, the values we want to pass should be in the same position. Means whatever you want your DSN to be, you have to pass exactly as the first value. Whatever the start value you want to, it should be here. Whatever the end value, here. So this is position 1, position 2 and position 3. Our values should also match with that. So this is very important. Now let us look into keyword parameters. Before going into keyword parameters, I just want to re-emphasize one point. Each parameter is followed by a comma. Now here again the code is pretty much the same, but what I have changed here is I have written DSN equal to comma, start equal to comma, end equal to. This means I am creating 3 parameters in here, or I have 3 parameters in here, and these are DSN, start and end. Because I have equal to in here, equal to in here, equal to in here, these 3 parameters are known as keyword parameters. So again, whatever I pass for DSN equal to will go here, whatever I pass in here for start will go here, whatever I pass for end equal to will be coming in here while executing the code. So while executing the code, I am doing here %more functionality 1, DSN equal to SAS help.class, start equal to 2, end equal to 5, obviously with the commas after the each parameter I am passing. So this is very same to what you have looked into positional parameter, but it has some additional things to it. What is that? The first one is I can change my order. I can say start equal to 6. Again, it will just have the value 6 here. End equal to 9. I can do it in here. And DSN equal to SAS help.air. So this value will go for ampersand DSN. So the important point to remember is for keyword parameters, I need not follow the same order. Whereas for positional, I need to follow the same order. Again, whenever we are saying parameter, it is nothing more than we are creating a macro variable in here and we are using in here. And this is done through execution. Now that we have looked into positional and keyword parameter, I would like to get into one another point. For keyword parameter, I can also give default values while creating my macro. That is, in here I have given DSN equal to SAS help.class, comma, start equal to comma, end equal to. If you see, I have given the value of SAS help.class in here directly. This is another advantage of keyword parameter. So When I'm executing my macro here as %more functionality 1 start equal to 2 end equal to 5, you got to remember that dsn is equal to SAS help.class. It is already there. I don't have to pass it again. So this is sometimes useful when you want to have default values so that you get your result. And not only that, we can also override this SAS help.class dsn equal to SAS help.class by mentioning again dsn equal to SAS help.cars here, start equal to end equal to. So we can give a default value and we don't have to pass the value, and also we can override that default values. Now one another important point arises is when do we use positional parameter and when do we use keyword parameter. Positional parameters we generally use when we have one or two parameters and then it is easy to pass. Keyword parameters generally we use when we have lot of parameters. That is when we want to have keyword parameter. The advantage with the keyword parameter is when you try to pass the values, you kind of know what you are exactly doing, which value you are passing. It is more clearer. So whenever we have more parameters, we generally go for keyword parameter. I have just now observed that I was missing comma earlier, but there should be comma after this second parameter in here. And now let's talk about how we can mix positional and keyword parameters. Yes, we can mix positional and keyword parameters, but all the time positional parameter should come first. Here we have another macro wherein we have two parameters dsn comma drp underscore call equal to. The first one is positional parameter, the second one is keyword parameter. So whenever we have this kind of setup, the positional parameter should always come first and then keyword parameter come second, or whatever it is. Basically your positional parameter should come before your keyword parameter start. And here I am passing the macro variables, or I am passing my parameters, and here I am giving the value of class which belongs to this position, drop underscore call equal to age. That is, drop underscore call will have age as value. If you try to switch, then we are going to have an error saying that all positional parameters must precede keyword parameter. Here we have created a macro, but what we have done is we have mentioned keyword parameter as the first one and positional parameter as the second one, and we cannot do that, and while executing the macro we get an error saying that all positional parameters must precede keyword parameters. Now let us briefly look into the differences between positional and keyword parameters. Positional parameters main property is the order in which they are defined, and we have to execute or pass the values in the same order. For keyword we don't have to do that. We can also mix keyword and positional parameters, but positional parameter should come first. And with respect to default values, positional parameters cannot have default values, whereas keyword parameter can have default values. Now let us look into compilation with macro parameters. Again, here I have a macro with a macro parameter, and then what happens is tokenization followed by the same process which we have discussed earlier. And when the macro processor sees %macro and %men, it stores the macro in macro catalog. Now let's also try to understand how execution happens with macro when it has a parameter. Now here we have our execution wherein I am saying %test dsn equal to SAS help.class. Here I am passing the parameter. So whenever we try to do this, what happens is again the same thing, tokenization First, when it looks into %test, the macro processor, it opens this macro catalog and reads what is there in between this macro and mend. And when it sees dsn equal to sas_help.class, it creates macro variable dsn whose value is sas_help.class in local symbol table. And then whatever is there in here that is in between %macro and mend is put into input stack. And also ampersand dsn is also will be treated as text. And again the word scanner looks into this. As we have ampersand sign in here, the macro processor understands that, and what it does is it looks into local symbol table and it has the value of sas_help.class, and now this becomes proc print data equal to sas_help.class run, and now it is in SAS compiler, and the SAS compiler executes the code and it will do the proc print. Now let us try to understand compilation with macro statements and parameters. Here we have a macro. In this macro we have two parameters, and here we have our macro statement which starts with %if, %then and %do. Here the macro starts with %if and it also has %then and %do. And more on the macro statements in the future classes, but for now try to understand that macro statements have something like % in front of them. And here I want you to focus on few things here. Again, once we run this code, the code goes into the input stack, and again the word scanner looks into it, and when it encounters the % symbol, it compiles the macro and stores in the catalog. And another important thing to remember here is this %if, %then, %do statement is also compiled, because whenever we run any macro or whenever we compile any macro, we need to understand that all the macro statements are also compiled, which I have explained in the very beginning, and rest of them are treated as text. Now let us try to understand macro execution with macro statements and parameters. We can execute the macro by doing %test, which is our macro name, and then in parenthesis val equal to s, dsn equal to sas_help.class parenthesis close. Here we are passing our parameters as s and sas_help.class. Now let us see what happens in here. Again the same thing, word scanner comes into picture and it tokenizes and it looks into this % followed by macro name. So what it does is it opens the macro catalog and reads whatever is there between %macro and %mend. And then when it looks into these macro parameters, it creates two macro variables, val and dsn in local symbol table. Val will have the value of s, dsn will have the value of sas_help.class. Now let's look into what is going to happen next. What's going to happen here is something more interesting than what we have done or what we have seen earlier. Here, as I said to you earlier, this macro statement will be compiled. During compilation, that is why it first looks into this macro statement, that is our if %then %do statement. What it does is it reads this ampersand val equal to s into the input stack first, and word scanner comes into picture. As ampersand val has the value of s in the local symbol table, the macro processor understands this ampersand val and it assigns the value of s to ampersand val, and this becomes s equal to s. Now our macro statement becomes as follows, that is %if s equal to s, %then %do. As this statement is true, whatever the text next is there in here will come into as shown in here. That is proc print data equal to ampersand dsn run will come into input stack. Again, word scanner looks into this, tokenizes it, and then macro processor comes into picture as we have ampersand dsn, and ampersand dsn value is picked up from this local symbol table as the value of SAS help.class, and this becomes proc print data equal to SAS help.class run, and then it comes into SAS compiler and it runs the code. And further what happens is it moves to percent end. This indicates that the percent if then statement has ended. That is, our macro program statement has ended. And finally, we move further, and then here there is percent mend, and it indicates that macro has also ended and there is nothing more to read from macro catalog. And finally, this execution is complete. That's all for this topic. Topic is conditional and iterative macro statements. And this is part 4 of SAS Macro series. Now let us quickly discuss what are the topics we are going to cover. I'm going to cover percent if percent then, in which we will be talking about syntax and examples, and also what percent if percent then can do and when we should not use percent if percent then. And then we will go into percent do group. Here also we will look into syntax, example, and when it is useful. And also we will be discussing about percent do group in the context of using it in the open code. Then we will talk about iterative percent do loop. Again, here I will get into the syntax and also understanding implicit percent eval. And then we will be moving on to percent do percent while and percent do percent until. And here also we will discuss into syntax and examples, and also about how they are different. And also one example we will be discussing wherein I will be explaining how to write the code more efficiently. That is, how we can write our percent if then statements in a better way so that we avoid redundant code. Now let us quickly look into simple percent if percent then. Percent if percent then should always need to be embedded in a macro, means we can't run this code out of the macro, so always it should be in the macro. And every percent if percent then should have a semicolon at the end. And also here another important point to remember is, here we are saying percent if ampersand macro equal to test percent then percent put, this is correct input. So what we are doing is, depending upon this value, we are putting a text into the log. Here when we pass macro equal to test, this is what we are going to see in the log. If you see this percent if percent then, it is very similar to if then what we use in a data step. One major difference in here is, here percent if we are using on a macro variable or we are using a text. It is very important to know that percent if percent then we are not using on variables. We are either using on macro variables or text. I will go into detail on this topic in the future slides. Now let us look into percent if percent then and percent else. Now here we have else and everything else is similar. We have our percent if then, and then we have semicolon. After that we can have percent else and semicolon. This is very similar to what we see in our data step, but in data step we have else if, and here we don't have any else if. And here percent else, as I said, it should end with semicolon. And when we pass our macro variable value, if the condition matches, then this particular statement is put in the log, else this statement is put in the log. Here we are passing the value test, so it's going to put this statement in the log, and that is what I have pasted in here. Now let us go a little bit deeper and understand the execution pattern and what happens. To understand how a macro is executed, it is always important to have options M logic, it tells about how your macro is executed. And also when you have percent if then, it also tells what's happening in your percent if then else statement. When we have options M logic and we are executing our macro with the value of macro equal to test, then what happens is it tells us that the execution is started and the parameter we have passed is test and the condition here is true. This third line, if you look a little bit deeper, it tells about what has happened in the execution. That is why we see this particular statement in the log. For the same macro, when we are passing new test, as this new test is not equal to test, this will become false and our else statement will get executed. Now let us also try to understand what else we can do with the help of percent if percent then statement. Percent if percent then statement, apart from creating the text, is also useful to create macro variables conditionally. Here we have a macro in which we have our percent if percent then statements, and in here if you see after percent then we have our percent let statement, wherein when the condition matches we are saying we want to create a new macro variable in which I am saying in here its name is new macvar and I am giving a value to it. So just not creating the text, but we can also create new macro variables conditionally with the help of percent if percent then statement. And when we pass macvar equal to class, this class becomes class and then the value of macvar we can see as SAS help dot class. Sorry, the value of new macvar as SAS help dot class. And apart from creating macro variables, we can do many other things, but let's also get little bit deeper. After conditionally creating macro variables, like in here, we can also use them in the macro itself. For example, here we are creating a new macro variable by using percent if percent then and using a percent let statement, and the new macro variable which we have created we have used in here, and when we execute this by giving a class value, what happens is class becomes class and then new macro variable new macvar is created which we are using in here, and it has the value of sashelp.class and it proc prints sashelp.class. Not only creating macro variables conditionally, we can also conditionally execute macros with the help of percent if percent then. Here we have macro test and macro test one. They are just little different. We have different dataset names for both our proc print and proc means for macro test and macro test one. But we can conditionally execute this macro or this macro by using our percent if percent then statement in here. In here I have macro, a new macro which I am creating, and here I have percent if ampersand macvar equal to hello percent then percent test, which means when macvar, if I pass the value of hello, it will execute this macro. If we pass the value of macvar which is not equal to hello, it is going to execute test1 macro. If we see the two executions of percent both underscore test macros, what we have done is we have passed the value of macvar equal to hello, and this helped us to execute percent test, that is we were able to execute test macro, or when we have passed the value of hello 1, that is the condition has not matched here, it has executed test1 macro. Now let us talk about percent do groups. Again, this is percent do groups, and this is not about a loop or anything of that sort. Here we are talking more about groups. The groups we use generally, we want to address lot of SAS statements with semicolons or anything which has semicolons. Now let us try to understand more on this with the help of a macro in here. Here I have percent macro and I am naming it as do test and I have one parameter dsn equal to. In here I am saying percent if ampersand dsn equal to SAS help dot class percent then percent do proc print data equal to ampersand dsn semicolon run semicolon percent and then I'm ending my macro with percent met. Here, let's focus on our percent do. What if I don't have this percent do and end? As you all know, every do should have an end, and in this case, we have percent do and we have percent end. And we have this percent do to handle these two semicolons. That is, one after this proc print statement, another after run statement. As I have said earlier, whenever we have just percent then and percent if, it should end with a semicolon. And here we have two semicolon. Percent then cannot handle two semicolons. What I'm saying is not 100% true. There are ways to handle it by using quoting functions, but that's an advanced topic and we are not going into it right now. We will be discussing more on when I'm going to discuss about macro functions. But percent if percent then ends after one semicolon. We can't embed multiple SAS statements in here. So to handle these multiple SAS statements with semicolon, we use do groups. So percent do is mainly to accommodate extra semicolons. Now let us look into the execution. Here we have percent do test and here we also have a small mistake. This is supposed to be dsn equal to SAS help dot class and I'm sorry for the inconvenience. And once we pass the value of SAS help dot class for dsn, here this becomes SAS help dot class equal to SAS help dot class and these statements will be generated and proc print will run. And we can also add percent else to this also. But unlike percent if, percent then, here we also have percent else and we also need to do a percent do and percent end. And this macro is pretty similar to what I have shown in you earlier. Only difference is we have a percent else macro statement also in here wherein we have percent %l, percent %do and we also are adding a SAS statements in here. Of course, these SAS statements are nothing more than text to your macro statements. And this is proc means data equal to ampersand dsn semicolon run semicolon and it ends with and we have percent. Now let's also try to execute this macro. Here I'm executing the macro and in here I'm giving dsn equal to SAS help.cars. The if condition does not match because SAS help.cars is not equal to SAS help.class. So the percent else condition comes into picture and proc means of SAS help.cars runs and the results you can see in here. So the bottom line, percent do group is very similar to percent if percent then, the only difference being the accommodation of more statements which have semicolons. Especially we need this whenever we have lot of SAS statements which have semicolons embedded within them. Now let us try to understand one another important aspect of percent do group. The advantages of percent do group is we can run percent do groups in open code also and this started from SAS 9.4 M5. As you have seen earlier, whenever we wanted to run any of percent if, percent then, percent do, all I was showing you to embed them in a macro and then run them. But starting from SAS 9.4 M5, for do groups, we do not have to have the whole thing embed in a macro. For example, I'm showing the same thing what I have shown you before, but this is not embedded in a macro. There is no percent macro name, there is no percent mend, and I can just select this part and I can run, and then it executes and gives us the result we want. So here I have percent let dsn1 equal to sashelp.class, as it is sashelp.class equal to sashelp.class, and then whenever I run this code, it proc prints the result for me. %do group can also be used to conditionally execute macro in open code. Here we have %if, %then and %do, and then we are executing a macro whenever this condition matches. And finally we have our %end for this %do group. And here I want to tell couple of things. Earlier, whenever we want to use %if, %then, we have to embed them in the macro, but we are trying to use %if, %then, %do, so we can execute macro conditionally in open code. Another important thing is I have not put any semicolon after the execution, that is after %test. Macro execution does not need a semicolon, and if you don't put a semicolon, it is fine. So here I have defined my %let dsn1 equal to sashelp.class, and then this condition is matched in here, so this executes your macro. So %do group helps us also to make the code little bit simpler by not embedding them completely in macro whenever we want to do that. Now let us also look into something else which is important, that is how to think anything other than SAS macro statements as text and how it is useful. Now I want to illustrate this with an example here. In here I have a macro and I am calling this macro as simplify this, and my parameter is macvar equal to. Here I am having %if, %then, %do. When this condition matches, I want to have data sales, set sashelp.pid sale12, and I want to keep some variables followed by run statement and then end. For this %then do this end, if the condition does not match, that means whenever you pass a value which is not hello, then it should do this, that is %else, %do, data sales, set sashelp.pid sale, and keep some variables run, and then %end and %mend. So if you see here, depending on the condition, we are creating a data set in here or we are creating a data set in here. And the important point I wanted to understand in here is not to think in the terms of data step or data or anything else, but in the terms of text. Why I am saying this? If you see here, we have written 4 lines of code and we have 4 lines of code in here. Or for this macro, this is nothing more than text. So 4 lines of text, 4 lines of text. We have written 8 lines of text. But if we look closely, data sales is common in both the conditions and run is same for both the condition. So we can improve this macro by not writing this data sales and run multiple times. To understand this, what I have done is I have pasted the same macro what I have shown you earlier on the top and a modified macro in here. So what simply we can do is we can take the data sales out of these %if then statements and keep on the top And also what we can do is we can keep run also on the bottom. If you see here, I have moved data sales from here to top and run from here to bottom. So whenever the code gets executed, for example, whenever I pass the value of hello here, it becomes hello equal to hello, and it generates these two lines of text. And what happens is data sales is there on the top and run is there on the bottom. So it becomes data sales, set SAS help.pid sale and the keep statement with few variables and then run. And also if we are passing a value which is not equivalent to hello, what will happen is again it will generate these two lines of statements, and then we have data sales on the top, these two statements followed by the run. So it finally forms data sales set sashelp.pid sale and keep with few variables in here run. Bottom line, what we have to understand is what finally all these statements will become, means what are the text we want to generate and what is the text before and what is the text afterwards, and after executing what happens. This is very important point to understand and assimilate. We always need to think in the terms of writing less redundant and efficient code. Now let us look into another aspect wherein the new programmers often do mistakes on. That is, they will try to use %if %then statement on SAS data step variables. For example, here I have a macro and this macro I am calling it as ABCD, and then I have data cars set SAS help.cars %if type equal to SUV then new equal to 10. So the new programmers often think that this type equal to SUV should be understood by this %if statement, but that does not happen. What actually happens here is when we execute this code, this %if %then statement get executed first. So in this %if type equal to SUV, then new equal to 10 gets executed. So the type will be treated as a text. This text is not equal to this text, then this then doesn't execute. So it is very important to understand that part. And then finally what happens is these data cars set sashelp.cars run, these statements gets created and they get executed with the help of SAS compiler, and then data cars will be created. Now let us try to understand this even more better by looking into the similar macro, but here I have my %if statement changed. Here I am saying %if quotes SUV equal to quotes SUV then new equal to 10. And then what happens in this case when we execute this macro, this %if statement runs first. As I've said to you very many times, this symbol is known as macro triggers and it runs first. As SUV equal to SUV, this then will generate this new equal to 10, and then what happens is then data cars set sashelp.cars new equal to 10 run, these statements are created and SAS compiler understands them and it executes the code and a new variable is created. The point here I am trying to emphasize is %if then statements are meant for comparison of text or for the comparison of macro variables or comparison of text with the macro variables. Of course, the macro variable value itself is nothing more than a text. So be very careful in this particular point. Now we are left with percent do loops, wherein I would like to talk about iterative percent do loop, percent do percent until, percent do percent while. But before going into those details, it is again important to understand what macro variables are and little bit more about percent eval also we need to know. Now I can define my macro variable by percent let statement as my mac var equal to 1 plus 2. And if I want to see this my mac var value, I can use a percent put statement and I can reference my macro variable by using ampersand my mac var. And the result here we can see is 1 plus 2. So here this indicates that everything we mention in here is text. So we see the result also as a text and nothing happens even though we have a plus operator in here. But if we want the calculations to be done, we need to use something like percent eval. Percent eval is a macro function. More on the macro functions when we will be talking exclusively on macro function. And then we can do 1 plus 2. And when we look or when we try to see the value of my mac var 1, we can see the result as 3. So some calculations to be done, especially here addition, we need to use percent eval. Now I would also explain why I have told or why I have discussed this slide in a bit. But first let's look into percent do loop. Percent do loop is also very similar to what we have seen in a regular simple do loop. Iterative percent do loop. This is very similar to what we have seen or what we see in our data step do loop. It starts with percent do I equal to 1 percent to 5. Whenever we don't give by, it means we want it to be increment by 1, and we can have any statements in here. In our case, we are trying to find or we are trying to put this value to log, that is the value of I, and percent end. So percent do percent end is same, and instead of 2 we have percent 2. And important thing to understand in here is we are creating macro variable in here as opposed to variable when we use simple do loops. And also in percent do loops, we can execute whatever the code we have or whatever text we have this many times. But coming to the percent do loop in here, let's try to understand it better. When our percent do loop starts, the I value will be 1, and here you can see the value of I is 1. And then it increments by 1, it becomes 2, and then increments by 1, it becomes 3, then increments by 1 more 4, and it increments 1 more 5. It tries to increment one more time, but as the endpoint is already reached, it doesn't loop through anymore. And also remember, even though I have not shown you here, you can have a code here and can execute it multiple times. I have shown this example in very first macro class, wherein I have showed that how we can use proc append and run it 100 times. And I will give the link for the same in the description below. You can have a look into that also. Now that we have looked into percent do loop, now it is good time to understand what really happens. As I told to you, macro variable is text, but if you see, I'm again saying that it is incrementing by 1. How is that happening? This is what is known as implicit eval or implied eval. Let's call it as implicit eval. So what actually happens when we create this macro and compile this macro, and when we execute this macro, what really happening is this. Our percent eval is running behind the scene, and what it does is it creates the value of 1 in the first step or in the first iteration, and then in the second iteration it adds one more, but behind the scene percent eval is running something like this, wherein after it becomes 2 it adds one more, percent eval runs behind the scenes. So the important point to understand in here is an implicit percent eval runs whenever we do percent do loops like this. And more on this implicit percent evals when we talk about functions in the next class. Now let us look into percent do, percent while and percent do, percent until, but I would like to start with percent do, percent while. And here for both percent do, percent while, we do not have a starting point and ending point like regular iterative do loop where you give a starting point and an ending point, or a start or an end. But they have condition mention after percent do, percent while. In until also it is the same. You say percent do, percent until, and you have condition mention in the parenthesis here. Now to understand percent do, percent while, let's look into this macro in here. In this macro, I am defining percent let I equal to 1, which means I am creating macro variable whose value is 1. Now I am saying percent do, percent while, and I am saying in here in the parenthesis the condition is ampersand I le5, means I want to loop while the condition is true when my ampersand I is less than equal to 5. Means when I am entering into the loop, if the condition is less than equal to 5, it should loop. And in here, as you can see in percent do while, when we initially start to go into the loop, the value of 1 is less than equal to 5, and as this condition is true, it goes into the loop, and we also have a percent put statement which puts the value into the log. And then we have percent let I equal to percent eval ampersand I plus 1. So percent put will put the value of 1, and we are adding 1 to this ampersand I, and it becomes 2, and our I will have the now value of 2. And it again goes and checks in the condition here, 2 is still less than equal to 5, and it puts the ampersand I value, and again it adds plus 1 and it becomes 3, and it again loops through, and again it puts the value in the log. We are going to add 1 to this ampersand I, it becomes 4, and then 4 is still less than equal to 5, and then we put the value in the log, and then percent eval, again here we are adding one more. Now it becomes 6, and then once it is 6 it tries to loop again. As it checks in here that ampersand I is no longer less than equal to 5, it comes out of the loop and it does not put or it does not do anything. So the values of this you can see in here. So percent do while is always about having a condition in here, and then you loop through it, and once the condition is met, the loop is ended with the percent end, and you can see the values of your I in here, and I have pasted this from the log. So to sum it up, percent do while, the condition will be there and it executes while the condition is true and stops when the condition is false. Here the condition which I have given is more about dealing with numbers. This condition could be anything. And one important thing about percent do while is If you give a condition which is always true, it will loop forever. And you have to be very careful about that and what condition you are going to give, and you have to see that the condition is not always true so that it can come out of the loop. And again, %do while, what it does is before going into the loop itself, it checks the value on the top. What does that mean? Here I have %let I equal to 1. Before going into the loop, it checks the value in here, then only it goes into the loop. Now that we have looked into %do while in a detailed way, now let's try to look in for %do %until. Everything in here is same except that here we have %do %until. Here I am saying ampersand I greater than 5. %do %until execute till the condition becomes true. Means here the value is 1 till it reaches greater than 5. It loops through again and again and again and again until it becomes greater than 5, and once it becomes greater than 5, it comes out of the loop. So couple of things here. If we are giving a condition in %do %until which will never become true, it will loop forever. And again, in the case of %do until, here even though we have defined %let I equal to 1, it does not check on the top. It will loop at least once. This is something very different than what we have in %do %while. Say if the I is 6, it will still loop once and then only it will come out. Whereas in the case of %do while, it checks on the top. If the condition is not true, it will no longer go in the loop. These are some differences between %do while and %do until. And here in the %do until, the condition may not be related to numbers, it could be again anything. Now that we have covered a lot of concepts on %if, %then, %if, %then, %do loop, and %do while and %do until, I want to tell that now we have just learned fundamentals and how we can use these concepts. I will be capturing more of those in the future sessions. And with this, I want to conclude this topic. The topic is creating macro variables with Proc SQL and 3 ways to use them. Till now we have seen 2 ways of creating macro variables. First one is %let statement and second one is SAS macro parameters. Both these require user input. But while creating macro variable using SQL, it helps us to use data from the table to create macro variables. In this way, it is different from what we have seen before. This helps us avoid hard coding. We will get into at least 3 case scenarios where I will explain you more in detail on this part. And these are great tools to handle metadata. By using dictionary.tables and macro variable, we can have so many applications, and I have made at least 4 to 5 videos on this topic itself, and link for the same I will give in the description below. Now let us see, by using data, what kind of macro variables we can create. We can create 3 types of macro variable. The first one is we can take a single value from dataset and we can create a single macro variable. And the second type is we can take multiple values from a single variable and we can create multiple macro variables. And the third one is we can concatenate variable values into a single macro variable. Each of these we will be trying to understand with very simple examples. Now, let us look into how we can take a single value from data set and put it into a macro variable. To do that, it is super simple. All we need to do is we need to write into and colon followed by macro variable name. This creates macro variable CNT. Now let us try to understand this example better. Now here I have written proc SQL no print because we are interested to create a macro variable. We need not print the whole thing. So I have written no print option in here after proc SQL. Here I am saying select count star into colon CNT from SAS help.class and then quit. What we are doing here is we are taking the value of count and we are creating macro variable CNT. So to create macro variable from proc SQL, it is super simple. All we need to do is into and colon the macro variable name. And we can reference this macro variable name, or we can use this macro variable by doing %put and then by referencing it by ampersand CNT. Here you can see that the value of count is 19. Now let us try to understand little bit more. Whenever we try to take a numeric value and put it into a macro variable, especially when we do it from the data, what will happen is it will create left spaces. And now let us try to understand with the same example we have seen earlier. Everything is same in here what I have shown you earlier, except that now I have a pipe around my macro variable ampersand CNT. Here I have a pipe in the front and a pipe in the back, or you can say pipe towards left and pipe towards right. And when we see the value in the log, we see a space after the left pipe indicating that there is a left space in here. And whenever we want to find the spaces in the log, especially as log has lot of empty spaces, we always try to do something like creating a pipe in front of macro variable or after macro variable or after any values, or we either use star or something, and this tells us whether there is a space or not. Here we can see that there is a space. To remove the space, it is super simple. All we need to do is we need to use trimmed option after our into colon macro variable, and once we use this trimmed option, and if we are doing the same %put and we have a pipe and ampersand CNT pipe, here you can see that there is no left space. Till now what we were doing was we were taking a single variable value and we were trying to put in single macro variable. But we can take many single variable values and we can put it into many single macro variables. Now let us try to understand this through an example. Here I have the same example what I have previously shown. In earlier example which we were looking into, what we have done is we have done count star and we have one macro variable created. Here I'm also interested in average age, so after count star comma I'm saying AVG and then I'm running it on age, and then I'm capturing into two macro variables. And to do that, it is quite simple. All we need to do is we need to write colon CNT comma and then we need to write colon AVG underscore age. So this count star value goes into this colon CNT. This average age goes into this AVG underscore age macro variable. So how many ever values you want to do, what simply you can do is you can follow it with a comma and then you can also create macro variable by putting a comma. And to trim these values is also very simple. all you need to do is you need to say trimmed option after colon macro variable and then comma another colon macro variable and trimmed. And now that we have looked into very simple case wherein we are taking a single variable value and putting it into a single macro variable. Now let's get little bit deeper and let's try to understand how we can create multiple macro variables by using a single variable but by taking it multi values. This is very powerful. But to understand this, now let us try to quickly do an example in here. In here I am saying proc SQL select name from SAS help.class semicolon quit. So what I am interested to see is I am interested to see all the values in the name variable. Here you can see that it has 19 values. I know this value because I work a lot with SAS help.class. And then what you want to do is you want to create one macro variable which has the value of Alfred, the second one will have Alice, and the third one will have Barbara, fourth one will have Carol. Like this, I want to create 19 macro variable and first one will relate to the first one in here and 19th one will relate to 19th value. So to do this, the code is also super simple. What I need to do is, I need to write proc SQL again as I do not want the values to be printed. I am saying no print, and in here I am saying select name into colon nm1 dash or hyphen colon nm19 from SAS help.class and quit. What we are telling in here is I want to create 19 macro variables starting from nm1 and ending from nm19, which means my first macro variable should be nm1, second one should be nm2, nm3, nm4 to nm19. So if you see the values in here, my first macro variable is nm1, it has a value of Alfred, my second value is Alice, and my second macro variable name is nm2, nm3 will have Barbara, nm4 will have Carol, and so on. So that we have looked into it, let's also do a percent put on ampersand nm1, ampersand nm2 and ampersand nm3. To find these values, we need to do ampersand nm4 to ampersand 19. But before going into that logic, here you can see that nm1 has Alfred, nm2 has Alice, nm3 has value of Barbara. If you see that this is rather tedious to look into these values and it defeats the whole purpose of looking into the values in this fashion because we have to type them out. But if you look deep into it, we can find a logic. That is, we have ampersand nm in front of all the values, but our 1, 2, 3, the numbers are increasing. They increase till 19. So what we can do is, we can keep this ampersand nm constant and we can pass this 1, 2, 3 as macro variables. Now let us see how we can do that. So here what I am trying to show is, we have created these macro variables, 19 macro variables. How we can access those macro variables without writing each one of them separately. Now let's look into how we can do that. And I have written my code on the top again to show what is happening. And here again you can see there are 19 macro variables created starting from nm1 to ending to nm19. As these macro variables are created outside, These are known as global macro variables. And these global macro variables we can use in a macro. Now, what we are trying to do in here is I have a macro which has name as check many macvar with do loop. So as I was saying, only 1 to 19 are changing. What we can do is we can, instead of using 1 and 19, we can use ampersand I. Here to do that, what I am saying is percent do I equal to 1% to 19. In here, what I'm trying to do is I'm trying to access nm1 to nm19 by doing ampersand ampersand nm ampersand I. Whenever we have more than one ampersand, I have told that it is known as indirect macro variable reference, and I have gone into detail about this into one of my video, but I will go in lesser detail in here to explain this. So in here, what is happening is when I is 1, that is in the first iteration, we have macro variable value I as 1. And in here, when we are starting from ampersand ampersand nm ampersand I, what happens is these two ampersands will become one ampersand, and this ampersand I resolves and it becomes 1. And now we have single ampersand nm1, and single ampersand nm1 value is nothing more than Alfred, and we see that value in the log in here. Now what happens in the second iteration is this is going to become ampersand nm2, and then by doing each iteration we are going to access all the macro variables from nm1 to nm19, and in here you can see in the result in the log after executing this macro that we are able to access all of these values. So whenever we want to access many macro variables which has a starting point and an ending point, we simply can create that starting point and ending point in a percent do loop, and then we can use indirect macro variable reference to access these macro variables. As I said to you earlier, I have covered about these indirect macro variable references in detail in one of my videos, and link for the same I will give in the description below. Now, even though this looks good, it has one important limitation. That is, we need to know how many observations are there in this data set. In this case, I knew that there are 19 observations in SAS help class. If we do not know this one, then we have to open the data set and we have to look into how many observations it has. And by doing so, by writing this manually here as colon nm19 and 19 in here, what we are doing is we are doing certain type of hard coding. What are the problems of this kind of hard coding? The main problem with this kind of hard coding is what happens if somebody wants to add 20 more observations into this SAS help class. Now this whole code becomes void, and this 1 to 19 also becomes void or pretty much useless, because we are not able to take all the values and create macro variables out of it as per our requirement. So to avoid this kind of hard coding, what we can do is we can simply use colon nm1 hyphen, and this started from SAS 9.4 M4. I think you don't have to give really the end value, that is nm19. SAS itself does in the backend. And also, as I said to you, we also want this to be automated, or also we do not want to hard code it, and this is nothing more than a count. So what we can simply do is we can do select count star into count or colon cnt from SAS help.class and then quit. I think I have written quit here, but probably it should be in here. And then I can simply try to access my macro variables by doing %do I equal to 1 to ampersand cnt. This ampersand cnt is nothing more than 19, and in here we are doing indirect macro variable reference and we are accessing all those macro variables. Now let us look into how we can do the same thing in the earlier version than SAS 9.4 M4. In here again the things are pretty simple and straightforward, but with one small change. In here again I am doing select count star into colon cnt and I am saying trimmed. I want my count value to be trimmed. And also in here I am doing select name into colon name1 and then hyphen colon nm ampersand cnt. In here this is going to become colon nm1 hyphen colon nm19. So in here we have to give the upper bound, but again we are not doing this manually, but we are simply using the count value which is captured into a macro variable. And when we come in here, ampersand cnt becomes 19, and now we are accessing all the macro variables as we have been doing previously. Now let me tell you why I have used the option trimmed in here. When I am having colon nm ampersand cnt, if I do not use trimmed, what will happen is this will have space. So it will become colon nm space and 19. So this will cause an error. So after using this option trimmed, what this will become is colon nm 19. Now we have seen how we can create many macro variables from a single variable and how we can access them. Now let us look into something different than what we have previously done. Now what we want to do is concatenate all the values into a single macro variable. If you look into here into the SAS help.class dataset, we have Alfred, Alice, Barbara. If you see, we have one value after another, another after another. Now what we want to do is we want to create a macro variable which have all the values into one single macro variable, but all of these values concatenated with the help of a separator. Now let us see how we can do that. This can be simply done by using the following code, that is select name into colon all names. This is my macro variable, and this style we have been using previously. So we are creating only one macro variable, and also we are saying separated by space. And this is important. We have never used this word separated by and then any delimiter we want to mention in here. Here I am just mentioning space. And when we create this macro variable, if we do %put ampersand all names, this macro variable will have values like this. All the values concatenated as Alfred, Alice, Barbara, Carol, Henry, James. Now I want to discuss couple of things in here. In the separated by, I can give comma, I can give any other delimiter, and once we give a delimiter as comma, again one single macro variable we will have, and this will have the values like Alfred, comma Alice, comma Barbara, comma Carol, comma Henry, so and so forth till William. Now we have looked into how to create macro variables, but we have not gone into details how to use them. Now let us try to understand how we can use the macro variables that were created by Proc SQL into class. And in here I am going to cover three different styles. The first one is by simply using dataset values. And to understand this, let us look into a case study, or let's look into an example by which we can understand more. Here what I want to do is I want to create a table for each student name in SAS class. Without macro, how can I do this? Without macro, I need to write something like this. Data Alfred set SAS class where name equal to quotes Alfred, run. And for Alice, I need to write data Alice and where name equal to Alice, which everything being same. I need to write the same thing for 17 more names. Whenever we do this kind of thing, we have multiple problems in here. Our code becomes very long. What if we had 50 data sets to create? Then we have to write everything. We need to look into the data set and we need to write again. And one another problem is whenever somebody deletes or adds more rows, this code is not going to work. So long code, depending on hard-coded values, are the issues when we don't use any macro. And whenever we find that we are repeating most of the code, in this case, if you see, this code and this code is very similar, but the only thing is changing is dataset name and also the value for our where condition. So this kind of code can be simply made into a macro. Now let us try to make a simple macro. In here, I am making a simple macro wherein I am saying percent macro simple mac val equal to, and then I am saying data ampersand val set sasl.class where name equal to ampersand val, and I am putting this into double quotes because macro variables are resolved in double quotes, not single quotes, and then run, and then I'm ending my macro with %med. Now I have created my macro, and again I can execute this macro by passing Alfred, Alice and 17 more execution. The code is a little easier, little simpler by putting this into a macro, but still it has quite a few problems. Instead of Alfred, A in the capitals, if I give A in small letter or if I write the spelling wrong, the data set will not have any rows. So manual entry, and there is an issue, and if somebody adds or removes any rows, then we are going to have a problem because again we need to add one more execution or 20 more execution. So the approach with a simple data step is repetitive code and hard coding, but whereas with a simple macro, even though we do not have very much of repetitive code, but there is an issue of hard coding. How we can address this? It is again simple, and this is what we have already seen, but let me show you once again how to do this. In here I am creating a macro, and in here I am saying proc SQL no print, and in here I am creating my macro variables by doing select name into colon name1 hyphen from sasl.class. This will create 19 macro variables, and I have also have my count star into cnt macro variable, and in here I am doing %do I equal to 1 to ampersand cnt, and this becomes 19. And here I am accessing all the macro variables nm1 to nm19 by doing indirect macro variable reference, and this I am doing for data ampersand ampersand nm ampersand I, and also in my where condition. So this becomes ampersand nm1, means this has a value of Alfred, and this also becomes ampersand nm1, and this becomes Alfred, and this creates our Alfred data set. When it goes to second iteration, it makes it Alice data set, and then it makes Barbara, and so on and so forth till the William. So what is the advantage of this kind of approach? Now we are directly pulling the values from the data set and we are using them without manually entering it or without hard coding, which means this program is almost the which means we are making this program very dynamic and data driven, and this leads to no manual errors, especially related to values. Now let us quickly try to compile this macro and run this macro. Now I am also compiling and execution in one step, and then in here if you see that I have created 19 data sets, each of them have one single row. So the first approach what I was telling about is simply using dataset values. Now let us try to understand what is the another way that we can use macro variables created into Proc SQL into class and solve some problems. And this involves dictionary.tables, and there are some other related tables also which belong to dictionary library. Before going into the details of dictionary.tables, now first let us look into what is the problem we want to solve. Here I want to proc print all data set which start with A in SAS help, and I just want to proc print first 5 rows. Here if you see the SAS help library, I have 1, 2, 3, 4, 5, 6, 7, 8 data sets which start with A as the word. And then how can I solve this without using any macro? Again, I can simply use proc print data equal to and SAS help dot the dataset name which we want to, and then ops equal to 5, run. So I can do for all the 8 data sets very easily. But what is the problem here? If I have 50 data sets, how can I do the proc print? It becomes tedious and it becomes redundant code, and this kind of code, as explained to you earlier, it is better to use macro variables. Now you see everything in here is same except the dataset name is changing. So what I can simply do is I can pass a parameter, and then I can execute all these macros by passing the dataset name as a macro parameter. But it is the same problem what I have previously discussed. That is, we are hard coding, we are passing hard coding values. If there are more data sets, then this code is not going to work. If some data set is deleted, the code will have different problems. Now how can we solve this? We can solve this with the help of dictionary.tables. Now let us briefly try to understand dictionary.tables. I have made a couple of videos on how to use dictionary.tables and proc SQL into class, and link for the same I will give in the description below. And I have also discussed about dictionary.tables little bit more in depth in those videos. And now let's look into dictionary.tables and what kind of information it has. Dictionary.tables has all the information related to tables which we have in a SAS session. Now let us quickly try to run select star from dictionary.tables, but let's only look into 5 records real quick. Now when I run this proc SQL out of equal to 5 select star from dictionary.table semicolon quit semicolon, we see that we have 5 rows in which we have the information related to data sets, and in here you can see that we have lib name, mem name and many other variables. And for our case we do not really need these many variables to understand, but we are interested in two variables. The first one is lib name and the second one is mem name. If you see here, libname tells about the library and memname says about the dataset name. As I was explaining earlier, we are interested only in SAS help library. So to look into or to get the information from SAS help, we just need to modify our code little bit, and we need to add here a where condition, and we need to say where libname equal to SAS help. It gives us all the tables related to SAS help. Now let us quickly run this piece of code and see the result in here. Here again I am using out of equal to 5 and it gives me all the 5 data sets. And now I am actually interested in all the data sets which starts with A. How can I do that? After writing where libname equal to SAS help, I just need to say and memname like quote A percent symbol quote, means I want to find dataset names which start with A but it can have anything after A. And let's quickly run this. Now here we can see all the datasets related to A. Now all we need to do is we need to run the same code and make each one of these as a macro variable and run this in the loop to do the proc print. Now let us look into that code. I have placed my code into this macro wherein I am using the same where condition which I have discussed earlier, but I am capturing these memname values into macro variable and the count also into a macro variable. Now we are running the same loop what I have shown you n number of times before, wherein we are saying %do I equal to 1 to %2 ampersand cnt, and in this case this is going to be 8, and dsn1 will resolve here as whatever the data set in there, and it will do the proc print, and then when I becomes 2, then this becomes ampersand dsn2, and whatever the value is for ampersand dsn2, that resolves and that also gets printed. And let's now quickly run this code and see what is happening in here. Now here you can see that we have printed 7 datasets in here, 8 datasets in here. But if you see, even the code is wonderful, it works fine, you don't have to manually do anything, but there is one slight problem with the proc prints in here. We do not know from which datasets these are. To know each proc print belongs to which dataset, all we need to do is we need to have the same code, but we need to have a title, and here I am saying title printing of SAS help dot ampersand dsn ampersand I quote semicolon. Here again I have double quotes because macro variables resolve in double quotes only. And in here this becomes ampersand dsn1, whatever its value is there, that will be printed in our title. Now let us quickly run this code and see what is happening in the result here. Now you can see that it tells us what data set it belongs to also. So not only we have automated a lot of things, but we have proc printed the datasets in a such a way that it tells us which dataset it belongs to. Now that we have looked into two different ways of using macro variables related to proc SQL into clause, now let us look into the third way. The third way is another important way, and it is by creating control tables. Before going into the details of this, now let us look into our requirement. Requirement is to print 5 tables, and this list can change. And also, this proc print should be done by 20 people in a team, which means you need something which happens at one place and everybody uses the same thing. Say for example, if I told 20 people to do a proc print of 5 tables, they will do it. If it changes, I need to communicate with the 20 people saying that, hey, now you need to add one more data set. So this kind of communication and trying to do without automating is problem. So in these kind of scenarios, what we want is we want a solution in which we are handling everything from one particular table, and this table is known as control table. So this control table will have all the information. In here I have 4 tables. Sorry, here I have mentioned 5 tables, but I am creating my control table with 4 tables in here. So my table will have all the table names which I wanted to proc print. This is known as control table. And we use this control table and we will create macro variables from this control table, and then we will do the proc print out of it. So what happens if somebody adds a row? It's fine. When we are doing dynamic coding, like what I have been showing you from past half an hour or so, it will take care of everything. And in here, let's first create our control table which has all the information we need. Now I have created my control table and it has 4 rows. And again, I can proc print by doing the same thing what I've been showing you over and over. That is by doing select and then the variable name into macro variables which we want to create, and also count star into count, and then we are doing our proc print. And then let's quickly run this. And here you can see that it has proc printed all the 4 data sets. So if I want to make 20 people to do the same thing, then what I can do is I can create a control table. Here if I want to add a row, I can simply add a row. That is, I want to proc print one more data set. I can quickly run an insert statement, and this inserts the row. And once the insert is done, I don't have to do anything to my macro, or not even the 20 people who are using that macro has to do anything. So I can simply run my macro once again and it will proc print this data set too. And now let's see the proc print. It will show the proc print of the data set which I have just added. So apart from directly using the values into data set and also dictionary.tables, control tables is another way to create macro variables by using proc SQL into clause and then solve some problems. Before wrapping up this topic, I would like to inform one another thing. So if you looked into all of our macro variables which I have created, are many macro variables I have created and looped through them. But I have not used a single macro variable of this sort and solved a problem. I will show this kind of solving the problem once I talk about macro functions, and then I will show you how to solve this with the help of percent do, percent until, and percent do, percent while. In that way, we will know another way of solving the problems, and also we will know how to use percent do, percent while, and also percent do, percent until in the next sessions. And that's all for this topic. In the last part, that is part 5 of SAS Macro series, we were discussing about Proc SQL into clause where we were able to create macro variables. Today we will be talking about how to create macro variables in data step using call SYMPUT or call SYMPUTX, and also I will very briefly compare how to create macro variables by Proc SQL into clause and also call SYMPUT, especially to show you which one is easier, not to contrast something but to show how easy one is above other. Now let us quickly look into what are the topics we are going to cover. The topics I'm going to cover today is what is call SYMPUT and what is call SYMPUTX, and what are the differences between both of these, and what are the advantages of call SYMPUTX. And also we will briefly look into the comparison of proc SQL into clause with call SYMPUTX. Now let us go into brief introduction. This is the introduction which is pretty much close to what I have discussed with proc SQL into clause. Both proc SQL into clause and call SYMPUTX helps us to create macro variables from data. But call SYMPUT and call SYMPUTX help us to create macro variables in data step. And both of them helps us to avoid hard coding, and these are great tools to handle metadata. By using dictionary.tables and macro variables, we can have n number of applications. Now let us quickly look into call SYMPUTX. In here I am using a data step. In here, as I do not have any data or I do not want to create any data, I am saying data underscore null underscore, and in here I am having a variable var and I am giving its value as hello world. In here I am using call SYMPUT to create macro variable. For call SYMPUT, the first argument which I am giving in here, which is in quotes, is macro variable. Second argument is my variable, both are separated by comma, and in here it need not be the variable, but it could be directly the character value in here. That is, I can just use hello world in here, and I can create my macro variable which has the value of hello world. But in this case we are using var as my second argument, which is nothing more than my variable. And call SYMPUTX is also pretty similar. We have two arguments. The first argument is nothing more than my macro variable name, and the second is my variable name, and this macro variable will have the value of var. And I am putting both of these values into the log by using pipe in front and back of my macro variable. In here I am doing both for ampersand macvar and ampersand macvar1, and both the values resolves to hello world. This is to show that we are able to capture the value of variable and we were able to take that value into a macro variable. So this is one important thing to remember. By using data step call SYMPUT and call SYMPUTX, we were able to capture the value of variable into a macro variable. Now we have looked into a character variable. Now let us look into a numeric variable in here. In here everything is same, but my variable value is a numeric value, and I am doing a call SYMPUT and call SYMPUTX, wherein I am saying nmacvar and then putting that into quotes, comma var And for call SYMPUTX, I'm saying nmacvar1 quotes comma var. Again, this var value is captured into the macro variable. Same is the case with call SYMPUTX. And I'm having a pipe as previously what I've shown you for both of these call SYMPUT and call SYMPUTX macro variables, that is ampersand nmacvar and ampersand nmacvar1. Here I want you to focus little bit more. For call SYMPUT, you can see there is a left space, whereas in the case of call SYMPUTX, there is no left space. So call SYMPUTX, what it does is, whenever we have a numeric value, it does not keep the left space, it removes the left space, whereas in the case of call SYMPUT, it does not remove the left space. If you look, or if you remember from what we have done in the proc SQL into clause, in the proc SQL into clause also, whenever we were taking a numeric value into a macro variable, we were having left space and we used trimmed there. So proc SQL into clause plus trimmed is what is call SYMPUTX. So call SYMPUTX you can use in the data step, and you can take a number, and it also creates a macro variable and removes the left spaces. Now let us quickly look into what are the differences between call SYMPUTX and also call SYMPUT. One of the major differences what we have seen was call SYMPUT, whenever we create a macro variable from a numeric variable, we have left space. For call SYMPUTX, we do not have left space. Another difference is whenever we use a numeric variable and we create a macro variable, as I am showing with the call SYMPUT here, we will have a note in the log saying numeric values have been converted to character values at the place given by line and column. Whereas with the call SYMPUTX, we do not see those kind of note. So with these two aspects, the call SYMPUTX looks little bit more comfortable to use. Now let us look into another aspect or another difference between call SYMPUT and call SYMPUTX. Before going into those details, I need to discuss one important point. That is, whenever we create macro variables in a macro, usually they are local macro variables that are created. Local macro variables means macro variables are just related to that particular macro, but they are not available outside of the macro. But when we create macro variables outside of the macro, they are usually known as global macro variables, are available for macro and for any other programs to use. I need to tell one important point here. This is a gross generalization, I am doing it. More on this topic we will learn when we talk or when we discuss about scope of the macro variables. And again, call SYMPUT is little bit more complicated when we talk about their scope, especially when we are creating them in a macro. For now, let's just focus on what are the differences between call SYMPUT and call SYMPUTX in the context of options they provide. Here I have a macro. In the macro I am saying macro test and I am saying var equal to. My parameter is var and then I am saying equal to. And then I am saying data underscore null underscore, and I am using my call SYMPUT and I am creating my macro variable m underscore macvar and ampersand var. Means whatever the value of ampersand var will be the value for this new macro variable m underscore macvar. And call SYMPUTX, if you see here, I'm having a third option. As I said to you, whenever we create macro variables in a macro, they are usually local macro variables, but call SYMPUTX gives me another option, that is G in here, to create a global macro variable. Again, this topic is much more complicated than what I'm saying, but what I want you to focus on in here is call SYMPUTX can take 3 arguments, whereas call SYMPUTX takes 2 only. And after my data step is completed, after run, I'm doing %put underscore user underscore. And after %man, once I compile this macro and execute this macro, here I am passing the value of hello. In this macro, we have asked to do %put underscore user underscore. That is, we want to see all the user defined macro variables. And that is what we see in the log in here. We see many more macro variables, but I have not shown you that for simplicity. But I want you to focus on these 3 macro variables and their scope. Whenever we have a result like this, the first one is scope, second one is the macro variable name, third one is its value. Here, my macro variable scope is test, means the macro variable m underscore macvar just belongs to this macro and its value is hello. Same is the case with the var, its value is hello in quotes and it just belongs to this test macro, which means both of these are local macro variables, whereas m underscore macvar1 is a global macro variable. As I have given an option of G in here for call SYMPUTX, so it has become a global macro variable, and m underscore macvar again has a value of hello. The important point to remember here is call SYMPUTX gives an additional option to define the scope. It is not that we can only define G, we can also define L, that is local, but again all of this we will discuss in future sessions. Now let's move further ahead. Till now we have been taking one value and we have been putting into a macro variable. Now let us see how we can make multiple macro variables using call SYMPUT. And in here what I want to do is I want to take all the values in a particular variable. In here I have SAS help.class and I have the variable name as name and it has 19 values. I want to make macro variable for each value. Now let us see how we can make this possible. In here I'm using call SYMPUTX, but I have not shown you something before is using a data set in here. So I'm starting with data underscore null underscore followed by a set statement wherein I'm saying set SAS help.class semicolon and then I'm using call SYMPUTX. And in here I have 2 arguments. The first argument is cat, which is CATT, followed by parenthesis nm comma underscore n underscore parenthesis closed. This whole is one argument and this argument contains my macro variable name and the second one is my variable name. So let us look little bit deeper into this argument wherein I am giving more of a SAS expression wherein I am trying to concatenate nm with underscore n underscore. Underscore n underscore represents the number of times data step has iterated and it starts with 1. I have made a video on this topic and link for the same I will give in the description below. As I said, it starts with 1. So when in the first iteration we will have the value as Alfred, that is name will have the value of Alfred, and this becomes nm1 because we are concatenating both of this. Now our macro variable name will be nm1 and it will have the value of Alfred. When it goes into the second iteration, that is when it reads the second observation, what will happen is this becomes nm2 and the name will be Alice. And in the same fashion, this underscore and underscore will become 3 and we will be reading Barbara. So our new macro variable will be nm3 and it will have the value of Barbara. In the same fashion, as we have 19 observations, what will happen is it will create 19 macro variables and underscore and underscore will increase by 1 after each observation and the name value will also change. In this fashion, what will happen is we are creating 19 macro variables with nm1, nm2, nm3, nm4, nm5, nm6 till nm19. So in this way, we can create multiple macro variables in call SYMPUTX. So to do that, here what we are doing is we are using underscore and concatenating with a string to create multiple macro variables. Now let us see how we can reference these multiple macro variables. And I have made a very detailed video on this topic, how to access multiple macro variables. The concept is absolutely same. The only difference is the way we create macro variables, which I am showing you in here from data underscore null and run, and the do loop wherein we are going to access all the macro variables is exactly same as what I have discussed in Proc SQL into class, and link for the same I will give in the description below. Now to go into the details, here I am creating a macro and I am calling its name as mini macvars, and in here I have data step wherein I will be creating many macro variables as shown in here and we have discussed in detail in the previous slide. Apart from that, we are also creating another macro variable CNT, and in here I am saying call SYMPUTX CNT comma n. Now let us try to understand what this n is and what its value is. So after our set statement, we are also saying n ops equal to n. What this n ops equal to n does is it will create a temporary variable n and it will have the value of number of observations in SAS help class. Again, n ops is a little bit complicated topic. It is not as straightforward as what I'm trying to say, but for now, for this topic, this is good enough. What we are doing is we are capturing the value of number of observations and putting it into a temporary variable n, and now the macro variable CNT what we are creating in here will have the value of 19 because n is 19. And now we are looping through this. How are we doing it? We are doing %to I equal to 1 %to ampersand CNT semicolon. As I said to you, ampersand CNT is nothing more than 19. So now our loop starting point is 1 and ending point is 19. And by using %put statement, we are going to access these macro variables by writing ampersand nm ampersand I. And this kind of reference in which we do multiple ampersands is known as indirect reference. And I have made a video on this topic also, and link for the same I will give in the description below. And in here what happens is wherein we have ampersand nm ampersand I, 2 ampersand will become 1 ampersand in the first pass, ampersand I will become 1 in the first iteration. So now we are accessing ampersand nm1 and its value is Alfred. That is what we see in the log. When I moves to 2 in the second iteration, this ampersand name ampersand I becomes ampersand nm2 and it resolves to Alice. In the same fashion till 19 we will be creating macro variables starting from ampersand nm1 to ampersand nm19 and we can access the macro variable values by doing so. Here in the result you can see that we are having the values of Alfred, Alice, Barbara, Carol to William just by having this ampersand nm ampersand I. Now, please also check out my another video of Proc SQL into clause. I go little bit more deeper on this aspect in that particular video and I do not want to again repeat myself. Now, let us try to compare call SYMPUTX with Proc SQL into clause. Functionally, they are both same. What we are trying to compare here is ease of use, in which we can easily get the results we want. Now let's try with call SYMPUTX. And in here I am trying to show something different than what I have shown you previously. In here we have call SYMPUTX and we are creating a macro variable yr. For second argument what I am doing is I am using today function. Today function gives the information related to current date. On top of it I am using an year function. An year function pulls year from any date which we provide. As we have provided today's date, the year function what it will do is it will pull the current year and this current year value will be taken by our macro variable, which means our macro variable will have the value of 2022. And if we do a percent put ampersand yr, here you can see that the value is 2022. Now, before going into Proc SQL into clause, I would like to say one more word. So, the second argument need not be just a string, number or a variable. It could be any SAS expression which resolves into a result and this result can be picked up by this macro variable. And to do the same in Proc SQL into clause, we need to write Proc SQL no print and then we need to say select distinct and then we need to apply our two functions in here and then do into and then colon our macro variable name from SAS help.class or any data set here. So the main problem in here is Proc SQL does not allow us any query to be valid without having a from clause. So what will happen if we do like this, it is going to read all the records from SAS help.class even though we are not using anything from it. So what looks like a pretty simple thing in call SYMPUTX looks unusual and complicated in Proc SQL into clause because we are using a distinct here and also we are using some data set which has no relevance with this one. So whenever we have to use a single value without a table, call SYMPUTX is best. Something like the year and today functions which we have been using, and to create a macro variable, always go for call SYMPUTX. Now let us look into the next comparison. Concatenating all the variable values into a single macro variable. Now let us try to understand this by looking into SAS help.class dataset. What here we want to do is we want to take the name variable and we want to concatenate all of these values into one macro variable. And let's see how we can do this by using Proc SQL into clause. With Proc SQL into clause, all I need to do is I need to say select name into colon macro variable name separated by a delimiter. Here the delimiter is space from SAS help.class. What this does is it concatenates all the variable values if you can see in here. And what it again does is it puts all the concatenated values into a single macro variable, and in here we are calling that macro variable name as all names. And when I do %put ampersand all names, you can see that this macro variable has all the values of variable but in a concatenated form. Now to do the same thing in data step and to use call SYMPUT or call SYMPUTX, it becomes little bit more complicated. In here, it is not as automatic as in here where I am just saying separated by a delimiter, everything gets concatenated in the back end and then we get our macro variable with all those values in it. Here, we need to provide a logic, and that logic in the data step concatenates all the values. Once that concatenated value we get, then we can do a call SYMPUT or call SYMPUTX to get that value into our macro variable. From length statement to end, we have that logic wherein we concatenate all the values and put it into a variable, and this variable which we have created and which has all the concatenated values is then used in call SYMPUT. Now if you see here, this is lot of logic. But whereas in the case of into clause, this is way simpler. So whenever we want to concatenate variable values into single macro variable, I would always prefer proc SQL into clause. And now let's look into another aspect. That is how we can use or apply these macro variables which we have created in call SYMPUT or call SYMPUTX. And we can do this application by three different ways. The first one is by simply using dataset values and creating macro variables out of it and then solving some problem. Or we can use dictionary.tables or related tables. And when it comes to data step, that is where we are creating our macro variables for call SYMPUTX. These tables are known as SAS help v tables. And the third application is by doing control tables. I have made a very detailed video on this topic in proc SQL into clause, and link for the same I will give in the description below. Even though we can create macro variables by call SYMPUT or by proc SQL into clause, the way we use them is same. And basically we use in one of these three styles and we solve some general problems. Now it's time to wrap up the whole topic. When compared between call SYMPUTX and call SYMPUT, call SYMPUTX removes left space when we try to make numeric value as macro variable, whereas call SYMPUTX does not do that. Call SYMPUTX also can take more options to make a macro variable global or local. And also, call SYMPUTX does not throw a note when we are using a numeric value and converting into a macro variable, but call SYMPUT does gives us the note. And also, when comparing call SYMPUT or call SYMPUTX with proc SQL into clause, call SYMPUT is good to handle single value into single macro variable than proc SQL into. Concatenating variable values into a single macro variable is easy to handle in the case of proc SQL into clause rather than by doing it with call SYMPUT or call SYMPUTX. That's all for this topic. We are going to talk about SAS Macro series part 7a, and it is about macro functions, and especially it is about macro quoting functions. I will be also having another part 7b, which is again also related to macro functions, but everything other than macro quoting functions. Macro quoting function is often a complicated topic and it is sometimes very difficult even to understand. So I have made my efforts to make it as easy as possible, but this is a little bit longer topic. Now, in the macro functions, we have quoting functions and also other types of SAS macro functions. But for today's topic, we will be completely focusing on macro quoting functions. These functions are very useful to mask special characters and mnemonics. Now let us try to understand coding functions with the help of an example. Here I have a %let statement wherein I am saying %let h equal to proc print data equal to SAS help.class semicolon var name age semicolon run semicolon and then final semicolon for this %let statement. I would like to iterate one another thing which I have been telling from the very first class, that everything and anything in a macro variable is nothing more than a text. And now what we are really doing here is I'm trying to put a bunch of text in here and then try to run my %let statement. But when I run the %let statement, I get an error here. That error says that var is something excess in here. Means this should have ended somewhere in here. That is my %let statement h equal to proc print data equal to SAS help.class. This should end here. That is what my error is telling about. What does that mean? It means that this semicolon here is interpreted as end of %let statement by microprocessor. But I want this to be treated as text, which means I want this also as a part of my macro variable. And also when I do my %put, the value I see is only proc print data equal to SAS help.class. Even though I want whole of this till run semicolon to be part of my macro variable, but it is not happening because a macro processor is thinking that this semicolon in here should be the end of %let statement. What now I want to do is I want to apply some function which will tell the macro processor that this semicolon is not really the end of this %let statement, but this is the part of text. Now let us try to do that by using %str function. In here I am using %let and I am saying h equal to %str and I am putting everything into parenthesis in here. That is, I am applying %str function on the text what I have shown you before, and this final semicolon is for this %let statement. Now all these semicolons are treated as text. How they are treated as text, I will go in detail into that topic also, but for now let's try to think that this %str helped us to treat this semicolon as text. And when I do %put here, it gives me value as proc print data equal to SAS help dot semicolon var name age semicolon run semicolon. And before going into anything else, what I would also like to say here is I have been showing you a new way of looking into macro variable. That is, I'm using %put ampersand equal to h semicolon. Earlier I was just trying to use ampersand h and then looking into the log. But what you can really do is you can really do %put ampersand equal to h. It will show the macro variable values as follows. It tells macro variable equal to and the macro variable value. This is a new way of looking into macro variable value, and I think it started somewhere from SAS 9.4 M4 or something of that sort. And then this is easy to see in the log. Now let us look into our main topic. What this macro quoting function is doing is it is instructing macro processor to treat semicolon as text. Now let us look into what are the other special characters which gives us problems with macro processor, like the semicolon we have seen. And also after that we will look into how macro coding functions work behind the scenes. Now let's look into what are the characters which give us problems. Some of the characters which give us the problems are shown in here. Those are plus, minus, star, and forward slash, and others. And also some mnemonic characters also give us problems, and those are and, equal to, greater than, gt, and others. So what our quoting functions they do is they mask these special characters which cause problems during compile and runtime. I will also get into what does compile and runtime quoting functions means, but first let's quickly look into quoting functions and how do they work. In the earlier slide, I have shown you the way we can apply a masking function. That is by simply writing the name of masking function. Here it is %str followed by parenthesis and whatever we want to write in here, and closing the parenthesis followed by the semicolon for this particular scenario. In here, what macro coding function really does is it applies hexadecimal masking characters, and these are also known as delta characters, and later they are unmasked. Here we need to also understand that macro subsystem understand these special characters and they mask them. Here if you see that the special characters are semicolon and they are masked. And also I want to tell one another thing here. The beginning and ending of this whole thing is also masked, but that is not important to know, and I'm not going into very fine details of the masking. But what I want you to understand is special characters are masked here, and that is when we are applying our %let statement. What is happening is this %let statement wherein we are saying h equal to all of these, what happens is all of these semicolons are here masked. So once they are masked, system does not understand it, or our macro processor just simply doesn't understand that as semicolon, and we do not have any problem with the semicolon after masking them. And I also said that once we mask these characters, they are also unmasked. And now let us see how we can understand that these things are also unmasked. Once we apply option symbol gen and then we do our %let statement in here, and after that once we do our %put ampersand equal to h semicolon, we can see a message in the log. That message is some characters in the above value which were subjected to macro quoting have been unquoted for printing. That means the values were quoted here and they were unquoted when we were doing our %put. This is very important to know. Now let us see how we can understand this visually. This kind of visual we have seen earlier when I was discussing about introduction and also about %let statements. Now whenever we run a piece of code, first it goes into input stack and word scanner looks into it, and what it does, it tokenizes into literal numbers, name, and special tokens. Here the %let is a special token. As it has a % symbol, macro processor understands it because they are macro triggers. macro processor understands it, and what it does is, because we have a %str in here, it stores the macro variable macvar in simple table by masking of all of these values in here. And once the macro processor is done, that is when we do our %put, the values are demasked, and especially this is done once our macro processor work is done. And here you can see that we have demasked values. So the important thing to understand in here is only one. That is, when the macro processor is working, what we are doing is we are masking those special characters which are interpreted in a wrong way by the macro processor. In our case, what we were discussing that as semicolons, because whenever we use %lt statement, semicolon is usually treated as end of that %lt statement. By masking, what we have done is we have not allowed this macro processor to see that semicolon. So our %lt statement has not ended here, but whole of this has been our macro variable value. This was done with the help of masking, and once the macro processor work was done, it is demasked and we can have all the values back. Probably I should use the word unmasked rather than demasked. In here, what I mean to say when I say that the values are unmasked and the values are back means the values or the text which were masked, in our case semicolon, they are unmasked and they are part of the text in here. Now let us talk about different kinds of macro quoting functions. If we talk about the categories, there are two categories of macro functions. The first one is compile time and the second one is runtime. Till now, we were talking only about %str, and %str is compile time function. And it masks all the special characters which we have earlier discussed except % and ampersand. nrstr also masks all special characters and it also masks % and ampersand. Now coming to runtime functions, there are three of them which are important. One is %bquote. This also works very similar to %str, but it's more a runtime function. And it masks all the special characters, but it does not mask % and ampersand. nrbquote masks % and ampersand along with other special characters. Percent super q is very similar to %nrbquote, but it has its own nuances and it is little different. In here, the macro variable never resolves, and the way we access macro variable is also different. More on this in coming slides, but for now, just try to understand that %super q is similar to nrbquote, but it is little different. I have discussed only few macro quoting functions. There are few more macro quoting functions. I feel that these are most of the time enough to run our macro code. And also it is very important to understand that macro quoting is often little complicated topic, and its complexity often comes from the difference in compile time macro quoting functions and runtime macro quoting functions. Now let us try to understand what is the difference between compile time macro quoting functions and runtime macro quoting functions. It is not very easy to understand the differences between the compile time and runtime macro quoting function when we do it or when we try to understand it from open code. Whenever we create macro variables or do something which is not embedded in a macro is often known as open code. Now let us try to understand the differences between compile time and runtime macro coding function. And then we are going to do this with the help of a macro. In here I am creating a macro and I am calling it as test1. In here what I am doing is I am trying to create two macro variables. The first one is S and the second one is B. And here I have the same text what I have shown you previously related to proc print. In here I am using %str, which is a compile time macro coding function, and in the second case I am using %b code. Apart from creating macro variables, what I am doing is I am also trying to access these macro variables, or rather I would say I am trying to see how these macro variables are stored in symbol table. And I can do this by simply doing %put underscore user underscore. What this does is it shows all user defined macro variables in this macro. That is, we have two user defined macro variables. The first one is S and the second one is B. And once we run this code from %macro to %men, this is what we call as compilation. It is very important to know what happens in the compilation phase. In the compilation phase, what the macro processor does is it looks into macro statements. As you can see, there are no macro statements in here. And the second one, what it does is it creates all the things which are needed as text. That is, whenever we have any macro variable to be created in here, it is created and stored in a symbol table. As I said to you, everything needed as text means macro variable is also nothing more than a text. So once the compilation is over, we can also execute our code. And execution of code is done by %test1. In here test1 is the macro we have compiled earlier and we are executing. Here I have a semicolon. In here we do not need a semicolon for execution, and this gives error. More on this error in a minute, but first let's look into our macro variables that are created. We wanted to create S and B, and we have used %put underscore user underscore to see our macro variables, how they are stored in symbol table. Now when we do this %put underscore user underscore, this gives our results as something as I am showing below. Whenever we do %put and do something like underscore user underscore, we often see three parts to it. The first part is it tells the macro variable which it belongs to. Here the macro variable S and B belong to test1 macro. And the second part is the macro variable itself. Third one is its value, how it is stored in symbol table. Here you can see that S is the value of proc print data SAS help dot class var name age run. Here there is something interesting in here. You can't see the semicolons and other special characters in here because all of them are masked. What does this tell us is %str has worked and it has created our macro variable, and also it has masked all the special characters. Now we do not see any value for another macro variable which we are created by using %b code. And let's see what is happening in here, why we do not have any value for here. The error we are seeing comes from this %let statement. If you look into the error itself, it says that expected close parenthesis after macro invocation not found. So the error is saying that It expected some close parenthesis, but it was not able to find one. This sounds little weird, but let's try to understand what it is exactly trying to say. Now, as I said to you, %b quote is not a compile time quoting function, so it does not work while we are compiling. So when we apply %b quote, what is happening in here is this semicolon is not masked. So %let statement thinks that everything has ended here and it doesn't go much further to see anything in here, because of which this closed parenthesis is ignored. So we have an open parenthesis, %let statement has ended here. We do not have a closed parenthesis, and that is what this error is all about. And because of this, the macro variable itself is not created. Now we have looked into compile time functionality in a detailed manner. Now let us also quickly try to understand about runtime functionality. Now again, to understand this runtime macro quoting function, let's try to understand it through an example in here. In here, I'm creating a macro variable in my data step wherein I'm using a call SYMPUT and I'm saying macvar in quotes followed by comma and variable. What I'm trying to do is I'm trying to take this variable value into my macro variable. Now I will explain you the runtime functionality with the help of two macros. The first one is macro test3 and second one is macro test4. In test4 I am using %str, whereas in test3 I am using %b quote. Before going into the details, again I want to remind you that %b quote is a runtime macro quoting function, %str is compile time macro quoting function. Now let me explain things through test4 macro. In here, what I'm trying to do here is I'm trying to use my %if statement and trying to compare this macvar value with another text. The macro variable, as I said to you, is nothing more than a text. So what happening in here is when I run this macro, that is during compilation phase, what happens is these %if, %then statements are checked for syntax, and as we do not have any macro variables to be created, nothing else happens in the compilation phase. And when I execute this macro %test4, what happens is this becomes %if, and here I have a caret symbol as my macro variable. Here what happens is %if caret symbol equal to j, then %put ampersand macvar, %else %put ampersand macvar. So what is happening in here is this %if and this caret symbol, once it resolves, equal to j it will become. So caret generally means a not symbol. So whole of this thing becomes not equal to j. But if you look into, there is nothing to compare in here. So it thinks that I'm saying %if not equal to j and then do something here or else do here. So what I wanted to be compared as a text is becoming a problem for me, because here it is picked up as a symbol and it becomes not equal to j, but there is nothing to compare over here, so I get an error. This is because While executing this macro, only this functionality works. And while executing, %str will not work because it works only during compilation phase. Again, during compilation phase, two things generally happen, that is checking of macro syntax, and also if there are any macro variables, they are created. Nothing of that sort is there during compilation. Only during execution we are having a problem, because during execution this not equal to or caret symbol is treated as a symbol rather than text. Now I have the same code in here, but now I have %b code. Now again we compile, there is not much to do during compilation phase. There are no macro variables to be created and nothing to be done of that sort, and only the syntax is checked. While executing, that is, my runtime functionality comes into picture. This %b code, what it does is it masks this special character during execution phase, or we can say while this macro variable is getting resolved. And this helps us to compare this caret symbol as text with the value or text j. As they are not equal to, this %l statement works, and then what it does is it puts this value of macro variable equal to &macvar in the log, and you can see the same result in here. To sum it up, we can say that compile time macro quoting functions generally work during compilation phase, whereas runtime macro quoting function generally work during execution of the macro or while resolving of macro variable. And in here I want to add one more point, that is runtime macro functions work pretty late, whereas compile time functions are applied as early as possible. Now that we have understood about compile time and runtime, and we also have looked into special characters, now let us quickly focus on mnemonic operators. This is not very different than special characters, but I just wanted to deal with this topic so that it looks complete. Now in here I have a macro in here. In this macro, what I'm doing is I'm saying %if ampersand state equal to ny, %then %put this is ny state, else %put ampersand state. Here in this macro I also have a parameter wherein I am saying state equal to. If I pass state equal to or during my execution, what happens in here is or can be treated as an operator. That is, when or is treated as an operator, what happens in here is this code becomes %if or equal to ny. This or is treated as a regular or operator. So after %if we are directly going to or, and there is nothing to compare in here because this or is an operator, that's why we get an error. So this or, which is treated as mnemonics, if we do a %b code while executing, what happens is this or is masked and it will be treated as text, and now we are comparing or equal to ny as text. Actually or means Oregon, and now what we are doing is we are comparing text or with ny because of %b code doing the masking. Now as this is not equal to, this else statement runs. Again, this is something we have earlier seen also. It is just that now we are talking about mnemonics. Now let us talk about NR coding functions. NR here means no rescan or no resolve. Again, we have three types of NR functions. The first one is %NRSTR. It masks all the special characters along with percent and ampersand, and this is a compile time function. So you can think this as an extension of %str, and runtime NR functions are of two types. The first one is NRB quote, another is %superq. Here again, these are not the only ones. I am just discussing what I feel are important. In here, we are talking about %NRB quote and %superq. NRB quote is kind of extension of %B quote, and superq is a little different, and both of these are runtime quoting functions, that too NR quoting functions. These three NR macro quoting functions are very different, and the way they work is also different. So I would like to discuss each one of them separately. And also I want you to remember one important point. This %NRSTR, %NRB quote or %superq mostly we use when we want to mask percent or ampersand symbols. In here, I want to tell one another thing. For most of the examples which precede now, I will be discussing only for ampersand symbol. First, let's start with %NRSTR. Again, the important point here to remember is how these three are different. And I'm not going to talk about compile time functionality and runtime functionality. We have gone into that in much larger detail. But the focus is mainly on how these three are very different and how we can use them as per our requirement. Now, first let's start with %NRSTR. And this we can do with the help of an example. In this example in here, I am using a title, and in here I am saying quotes. This is %NRSTR and then open parenthesis, ampersand sysdate, close parenthesis, and then quotes, semicolon, and I have my proc print statement. In here, once I run this whole of this code, what happens is the result will be shown as follows. Here we have our proc print result, and also you can see that our title is this is ampersand sysdate. If you remember, ampersand sysdate is a automatic macro variable which is system date in date7 format. And %NRSTR, what it does is it masks this ampersand immediately so that this value is never resolved. That means this macro variable is never resolved because this ampersand is immediately masked. So that is the reason we see the value or the title as this is ampersand sysdate. So this is the important thing to know about %NRSTR, that is macro quoting is applied immediately and no macro variable is ever resolved. And now let us look into one example where this can be useful for us. Again, I have same proc print, and here my title says this class consists of boys, and in here I am using %NRSTR on ampersand girls. In here actually I do not have macro variable girls, and I am applying %NRSTR. If I don't apply %NRSTR, the macro processor will look into this macro variable and will give us a warning saying that girls macro variable was not found. And by applying %NRSTR, This ampersand is masked immediately, and this value of macro variable is never looked upon, and we do not have any warning. Now let us look into %nrb quote. %nrb quote is a runtime macro quoting function, and it tries to resolve ampersand and percent once, then it masks the resolved value. Now let's look into an example to understand this better. In here I am doing a percent put with a bunch of text, and then I am using %nrb code, and then I am using it on ampersand sysdate. And when I run this piece of code, this is what I see in the log. In here you can see that ampersand sysdate has resolved. And now the macro quoting function is applied on the resolved value. Now I would want you to understand the difference between %nrstr and %nrb quote. Here the main difference is %nrstr is applied immediately and masks this ampersand immediately. So this value never resolves. So whenever I say the quoting function is applied and masking is done, what is really happening is we are masking the special characters and making them to be treated as text rather than special characters. In here, ampersand is a macro trigger, and what we are trying to do here is we are telling macro system that this is not a ampersand, it's a plain text. Don't treat this as macro trigger. And that is what %nrstr is doing immediately, whereas in the case of nrb code, the masking happens after the value is resolved. Now let us look into one last macro quoting function, that is %superq. This is a runtime macro quoting function, and this also masks percent and ampersand. And here one important thing to know is it masks the macro variable reference within a specified macro variable. What does this sentence means? We will look into it in a minute. But first let us see how we are going to use superq. Here I am creating a macro variable using call SYMPUT, wherein we have created macro variable myMacVar, and it has a value of hello world. Here I am using %put %superq myMacVar, and then once I run this, this is what I see in the log. Now this looks very similar to NRB code, but I want you to look into one important thing is whenever we use %superq, we are not going to use ampersand. So we are referencing our macro variable without ampersand. That is the specialty of %superq. That is the first specialty of superq. Whenever you want to use %superq, we are not going to use any ampersand on the macro variable. And in here, as we have used %superq, the macro variable value got resolved. So we get an impression that this is very similar to %nrb code, but it is not, and let's look ahead to understand it more. Now I'm again creating a macro variable, and in here I'm doing call SYMPUT, and I'm creating a macro variable macvar, and it has the value of Tom, ampersand Jerry. Ampersand in general means and for us, right? But once I do %put %superq macvar and run this %put statement, what will happen is we will see Tom and Jerry. What is the great thing about this? In here we do not have Jerry as macro variable, and as I said to you earlier in the definition, that it masks macro variable reference within a specified macro variable, which means it masks this ampersand. Within the macro variable, we have Tom and Jerry as the value. So it marks this ampersand, and when we run this, we do not get any warning saying that the Jerry macro variable was not there. So it masks this value. Now let us try to compare with %nrb code and try to understand this little bit more. In here again I am creating a macro variable, and this macro variable is word, and the value it will have is Ben and Jerry, and I'm using %put %nrb code ampersand word. Then what happens in here is whenever I run this %nrb code, as I said to you, it tries to resolve ampersands at least once. So what happens is it looks into macro processor and it tries to find whether there is an ampersand Jerry or not, and it gives as a warning apparent symbolic reference Jerry not resolved. Whereas in the case of %put %superq and word, what happens is we get the value of Ben and Jerry in the log, but we do not have a warning. Why don't we have a warning? Because %superq will not look into macro variable reference within a macro variable. Now this is an important thing to remember. So if we have to sum it up between %nrb code, %nrstr and %superq, we can think of this as follows. %nrstr macro variable is never resolved. Whereas in the case of %nrb code, all the macro variable references will be resolved and the masking happens on the resolved value. So everything is resolved once at least. Whereas in the case of superq, it resolves only the macro variable. Any ampersand references within the macro variable are not resolved. Now let us enhance this comparison of %superq with nrb code, and then we will finish this topic. In here I have %let Jerry equal to Jamin. Means I am creating a new variable Jerry and it has Jamin. Again I have same data step wherein I am creating my macro variable word and the macro variable is Ben and Jerry. In here I am using %put %nrb code ampersand word. What happens is, as NRB code always try to resolve ampersands at least once, what it does is first it resolves to Ben and Jerry, and as ampersand Jerry has a macro variable in here which has the value of Jamin, so it becomes Benjamin. Whereas in the case of %superq, it resolves to Ben and Jerry, and as I said to you earlier, it doesn't look into macro variable reference which is defined within a macro variable, so nothing happens in here. I know I have gone into a very long video for just macro coding, but believe me, I have just scratched the surface and there is more to this topic than what I have discussed. But these fundamentals will help you to understand macro coding better. Now to prepare these slides, I have taken the help of couple of papers, and link for these papers I will give in the description below. That's all for this topic. We are going to discuss about SAS Macro Series Part 7 B. If you remember, earlier we had Part 7A wherein we have discussed about macro coding functions. In Part 7B, we are going to discuss about evaluation functions, %sysfunc, and character-based macro functions. Now let us discuss about various types of macro functions. There are four types of macro functions. The first one, the coding function, which I have mentioned in here, we have discussed in detail in our earlier videos. Now coming to evaluation functions, what these functions do is they give the numerical ability to a macro variable so that you can do calculations with macro variables. And the next one is character macro functions. These are very similar to regular SAS character functions, but these are macro functions. And the next one is by using %sysfunc, we can use data step functions itself as macro functions. About each of these functions, we will go in detail in coming slides. First, let us start with evaluation functions. Before going into the evaluation functions, we need to understand one important thing, or I would like to reiterate one important point in here. Everything and anything in a macro variable is a text. I have been repeating this up to a number of times, but I think this is a very important point to remember. So that's why I repeat it over and over again. So whenever we are going to create a macro variable, in here I am saying %let a equal to 10 plus 2. Everything in here is text. None of them is treated as a number or anything else but as text. So when we want to do a %put and we want to look into the value of macro variable, what we will get is we will get a equal to 10 plus 2. And again, I have discussed about %put ampersand equal to macro variable in my earlier videos. Please have a look into if this is something new to you. But in short, whenever we want to do a %put, we can do ampersand equal to, and this will show the result in the log as a equal to and the macro variable value. Here the macro variable value is 10 plus 2. But what if we want to do some kind of calculation in here? Then we are going to do one thing, that is we are going to tell that please treat these values as numbers and this as a mnemonic operator wherein you can do plus in here. So this %eval tells the macro system to treat these values as number and this as the operator, and then when we do %put ampersand equal to b, we get the value of 12. Not only plus, we can do other things also. In here I am doing %eval 10 multiplied by 2 and this gives the value of our macro variable c to be 20. So %eval gives the ability to do some calculations. In here we have explicitly used %eval and we were able to do some kind of calculation in here. Actually, there is one important point to remember is not every time we have to use %eval, but some of the conversions happen automatically. Now let us look into an example for that, and this is known as implicit or implied %eval. About this I have discussed in one of my earlier videos, and link for the same I will give in the description below. But let's also quickly try to understand what is meant by implied %eval. In here I have a macro. In this macro I am defining my macro variable %let z equal to 2, and also I am doing a %do loop in here wherein I am saying I equal to ampersand z plus 2 %2 10 plus ampersand z %by ampersand z, and I am also saying to put the value of this macro variable in here, and then I am ending this do loop in here, and finally I am ending my macro in here by using %mend. Before going into any other details, now let us try to understand what is happening in this %do loop. In this percent do loop, we are creating a macro variable I, and in here we are saying ampersand z plus 2, which is our starting point, and we are saying our ending point as 10 plus 2, and also we are saying that to increment by 2 because our macro variable z has a value of 2, and we are also trying to put the value of this macro variable I after every iteration, and then this loop ends when it reaches this endpoint. Now let's compile this macro by running the code from percent macro to mend the macro by running percent %ys, and after executing the macro, this is the result we see in the log. Now let's try to understand what we see in the log in here, and in here you can see that the value of I is 4. What does this mean is this ampersand z plus 2 became 4, and the starting point is 4, and we are doing a percent put, that's why we have 4. And once this iteration is completed, in the second iteration it increments by 2 and becomes 6, and then again increments by 2 8, and then again increments by 2 10, and again one last time it increments and comes to 12, and 12 is our endpoint in here. So what I wanted to tell you in the whole of this thing is, even though we are doing addition here without percent eval, the addition is happening, and this is known as implicit or implied percent eval. Here I want to tell you one thing, that is, even though we have not used percent eval, in certain scenarios the percent eval runs behind the scenes and it does all the calculations, and this is the one of the scenario which I am showing you in here. Now let us quickly move on to another topic. Even though percent eval is very useful in giving numeric ability to the macro variables, it has its own limitation. Especially it is very limited when we are trying to use any macro variables which have decimals. Now let us look into an example and try to understand it better. Here I am saying percent let a equal to 10, and then herein I am doing percent put ampersand a plus 1.2, and I'm also doing percent put percent eval ampersand a plus 1.2. Here ampersand a plus 1.2 gives 10 plus 1.2, that is our ampersand a gets resolved to 10, and then we have 1.2, and we also have the plus symbol in here. Here it is a simple straightforward macro variable property. But when we are trying to do a percent eval and then trying to do the calculation, we get an error saying that a character operand was found in percent eval or percent if condition 10 plus 1.2. So it has a problem with this decimal. Now to address this, what we can simply do is we can use percent sys eval f. And when we do percent sys eval f and then we say ampersand a plus 1.2, it gives us 11.2. Now we have discussed our evaluation functions. Now let us move forward with character-based macro functions. Character-based or text-based macro functions are very similar to data step functions, but they work on macro variables and text. Now let us look into an example and let's try to understand what is different in here. So first let's try to create a macro variable. In here I'm saying percent let n equal to hello world, and I'm doing a percent put and I'm saying value is at, and in here I'm using my percent index function. This is very similar to index function what we use in data step. And in this function my first argument is my macro variable ampersand n, and then followed by comma, and my second argument is world. That is, I want to find the location of world in this macro variable. Obviously the macro variable value is hello world, and we are trying to find where world is. There are two different between macro functions and also our regular data step functions, especially related to character based functions. The first one is pretty obvious, that is whenever we used macro functions we use a percent symbol in front of the function. And the second one is more important and subtle. That is whenever we are trying to do an index function in the data step, when we have two arguments, the first argument what we do is we usually use our variable, and the second argument what we do is we use some kind of character value and we put them in the quotes. And when we compare that to our percent index function, we again have two arguments. Here the first argument is generally macro variable, and the second argument here will be a text. We don't put any quotes in front of it because we are searching for this particular text in this macro variable. And if we try to put quotes in here, what happens is this will try to search the world along with the quotes and it will never find it. So an important thing to remember here is we are trying to check for a text in here. And I think instead of telling character based macro functions, I should have probably used the word text based macro function. Now after this, let's look into what happens to our result. It finds the word world at the 7th position. This is again very similar to our data step index function, but we are using on macro variables and comparing with the text. Now let us discuss another aspect of macro functions. For every regular macro function, there is a quoting macro function related to it. Now let us try to understand this through an example. And for this example, let us take percent upcase. To understand percent upcase, let's create a macro variable. In here I am saying percent let h equal to my world. And in here I am doing a percent put and using a percent upcase on this macro variable h. And you can see here that in the result we have my world upcased. That is, by using percent upcase we were able to upcase the value of macro variable, and there is nothing special about this. Now to understand Q functions, let's get into another example. In here I am creating three macro variable A, B and C, and for A we have the value of test and for the B we have the value of semicolon. To pick up the value of semicolon into the macro variable we need to use %str. I have discussed in lot detail in my earlier video about %str and how quoting functions work. And now also I have another macro variable C equal to hello. Now after creating these three macro variables, I want to do upcase all these three macro variables. Before going into the details of this %upcase, please check out my video on quoting functions wherein I discuss about %str in detail, and link for the same I will give in the description below. And another thing is, if we would have not used %str here for the semicolon, what would have happened is this %let would have ended here. That is where the semicolon is there. And what would have happened is it would have had no value in here. But for this macro variable B, we want the value of semicolon. So this %str, what it does is it helps to treat this semicolon as text. Now let's get into our %upcase. In here I am doing %upcase on three macro variables together at one time. And what I am doing here is I am saying %upcase, and in the parenthesis I have &A, &B and &C. Once we run this %put statement, this is the result we see in the log. In here we see that &A value test is upcased and also &C value hello is upcased. But we also see an error. The error at this point is because whenever we are starting our %put statement, it ends with a semicolon. Because ampersand b is semicolon, our put statement ends in here, and hello seems to be something which is not related to this %put statement. That is why we have an error in here. To avoid this kind of error, all we need to use is %q upcase. What this does is it does upcase and also it does quoting. And because of this quoting, it masks the semicolon and the semicolon is treated as text. And when we do this %put now, we don't see any error in here. Regarding the quoting functions, I have made a very long video of close to 45 minutes, and link for the same I will give in the description below. Now let us look into the last topic, that is using data step functions with the help of %sysfunc. We can use most of the data step functions with the help of %sysfunc, except very few like input function, put function, lag function, and others. Now let us look into some examples to understand this better. In here, I am creating a macro variable %let name equal to smith.john. I want to create another macro variable x, and what I want to do is I want to have the macro variable value of name, that is smith.john, but I also want this dot to be changed to underscore. Transvert function is one function in data step which locates a particular character and it replaces that particular character with another character. We can use the transvert function in this %let statement by simply using a %sysfunc followed by our transvert function. In here we are saying %sysfunc and we are starting a parenthesis, and then we have our transvert function. For this transvert function we have again a parenthesis, and then we have our three arguments, and this parenthesis is closed, and this is for our transvert. These three arguments are nothing more than, first is macro variable, the second one is the character we want to replace, and the third argument is what is the character we want this to be replaced with. We want to replace dot with underscore, so here we have dot and here we have underscore, and finally we close with another parenthesis for this %sysfunc. If you remember simple data step functions, we have transvert and all of this set. Only new thing here we are doing is we are using %sysfunc, and then we are having a parenthesis start and parenthesis closed. In this fashion, we are able to access transvert function from data step into our macro facility. Now, another important thing to remember here is I do not have quotes around this dot or underscore because everything here I am dealing is with text. Here I am not dealing anything particular with character variables or anything. That's why we don't have any quotes here. If I have kept a quotes in here, what would have happened is this would have looked for in this particular macro variable for quotes and dot, and that is not what we want. And once we have created this macro variable, we can simply use %put statement and see the result, and the result we can see that result is smith_john. So %sysfunc is helping us to access data step functions very easily. Now we have used one of the character functions of data step. Now let us try to use one of numeric data step function. Again, pretty straightforward, pretty same. All here I am doing is I am creating three macro variables k1, k2, k3, and I am having the value of 10, 22, and 55. And what I want to do is I want to find a max value from these three macro variables, and I can simply do with the help of max function followed by my three macro variables which are my arguments for this max function. All again I need to do is I need to add a %sysfunc, parenthesis enclosed with the parenthesis. Now I am able to access the max function, and when I do the %put for this macro variable, I can see the value as 55. So In here, we are able to easily access numeric functions of data step also. Now let us go further ahead and try to understand how to nest these functions. We have done these kind of things in data step, or we do these kind of things in data step quite often, wherein we have to use more than one function on a particular scenario. In here, what I want to do is I want to do two things. The first thing is to find the max value within these three macro variables, and whatever the max value I get from these three macro variables, I want to do a mean, and that mean I want to do with a value of 10. So first I can simply do is %sysfunc, and then max value I can find it out here like this. This we have seen before. And here, as we can find our max value by using %sysfunc and the max function of data step, to do a mean is again also super simple. All we need to do is we need to modify very little bit. That is, we need to do one more %sysfunc, and then I need to mention mean, and then I need to start a parenthesis 10 comma, and I need to have this %sysfunc for max value. So this nested %sysfunc on the max will give me the max value, and in this case it is 55. And once we have this value, the second %sysfunc is applied and we get our result of mean, that is 32.5. So the important point I want to mention is this is very similar to data step, wherein we have to use multiple functions. What we simply do them is we nest them. We can also nest %sysfuncs, and then we use our functions very similar to what we do in data step. Now let us look into what else we can do with our %sysfunc. We can also apply formats by using putn and putc function. One another thing I want to remind you is we cannot use put function with %sysfunc, but we can use putn and putc. Putn allows to apply numeric format, whereas putc allows to apply a character format. Now let us look an example for both of this. In here I am doing %let c1 equal to 22281. This is a numeric value, even though this is a text, and we can apply a numeric format by doing a %sysfunc followed by putn, and then we are using our macro variable c1 which we have created here, followed by our format, that is ddmmyy10 dot, and this is a numeric format. And we are also doing %put to see this value in the log, and once we run these three lines of code, this is the value we see in here, that is 01012021. So by using %sysfunc and putn, we were able to apply format to this value, and we have applied here numeric format. And also we can apply a character format also. To apply character format, we need to use putc. In here we have a macro variable b, and we are saying hi, how are you, as a part of this macro variable. We can do a %put, and here what I am doing is I am using %sysfunc put c, and then I am applying this on macro variable b, and in here the format I am using is uppercase 14 dot, and here you can see that once we run this piece of code, we have the value hi, how are you, and the value is uppercased. So we have applied the formats to display the data we want it to be. I'm not going to discuss about what is a format and any details about putn and putc, because we are majorly concerned about %sysfunc and what it can do for us. If I go into the details of format and all those things, it will become a long video on itself. Now let us look into some informats. We can apply informats by using input n and input c function. And now let us look an example for both of this, that is for input n and input c. Here I am creating my macro variable b1 by saying %let b1 equal to 01 backward slash 01 backward slash 2021, and then I am creating another macro variable and wherein I am saying %let b2 equal to %sysfunc, and I am applying here input n in format, and here I am using my macro variable as my first argument, and in here I am applying my in format. And once I apply this in format and create this macro variable and use a %put, and once I run all of this code, I see the value as 22281. Now here we have used in format. In formats are mostly to read the data. Formats are to display the data. I don't want to go into details of this, but if you want to do something and want to change the macro variable appears, you can do it. You don't have to go to data step and do it, but simply you can use %sysfunc and use put n, put c, or input n. Now let's also look into one example of input c. Input c allows us to apply character in format. In here I have macro variable %let a equal to quotes hello world and quotes close semicolon. And what here I am doing is I am doing a %put, and here I am using %sysfunc. Followed by it I am using input c and applying a character in format, and in here I am saying $12 dot, and my first argument is the macro variable a. And once I run these two lines of code, I see hello world. If you see, we have started with double quotes around, and by using this particular in format, now we have hello world without having any quotes. So I have gone through briefly on formats and in formats and how you can change the values of your macro variables with the help of them. Now let us go ahead and look into one application of this %sysfunc, and I will also discuss about a quoting sysfunc, and then we will wrap up this topic. In here I have a macro. What this macro does is we are trying to see whether a particular file exists or not. If it exists, we want to read it with the help of proc import and create a data set. If the file itself is not there, then what we want to do is we want to say that the particular file is not there. And in here we have a parameter that is our file name parameter. What we will do is whatever file we want to check, we can just pass it as parameters. Again, we can do whole of this with the help of %sysfunc. Here I am writing %if %sysfunc, and in here we are using a data step function file exists on macro variable file nm, and then I am closing my parenthesis %then do, and in here we are doing two things. The first thing is we are giving a file name statement which is as follows: file name followed by a file ref and the location of the file in the parenthesis. As I said to you, this file comes from our macro variable, and that macro variable is file nm. And once we have used this file name statement, this file ref we are using in the proc import, and in here we are also creating a data set. And this part ends here with the %end. If we do not have the file here, we are saying else %do %put this file ampersand file name does not exist %end %ment. So once we compile this macro, we can execute this macro by saying %file checking and then passing our file name in here. And if you see in here, the dataset was created because this particular file was there. And in the same macro, if you pass a file name which is not there, we are going to get the message that this particular file does not exist. With the help of %sysfunc, we were able to use datastep function file exist, and also by creating a macro, we were able to automate a process. This process, what it does is, it checks whether there is a particular file or not, and if it is there, it will create a dataset. If it is not there, it will tell us that particular file is not there. And now let's look into our last topic, that is %q sysfunc. And we can understand this with another example. In here, I am creating a macro variable wherein I am saying %let x equal to %nrstr, and then in here I am having %proc a, %proc b. If I do not use %nrstr, I may get a warning saying that %proc a and %proc b macros were not there. And now what I want to do is, I want to use %sysfunc and datastep function substr and want to extract something from this particular text. What I want to extract is %proc a. So what I am saying is %sysfunc substr, and then I'm using this macro variable itself, and then I'm saying that to extract starting from 1 position to 6th position. So what it does is, it extracts this particular value. But when we run these 2 lines of code, we also get a warning. This warning says that apparent invocation of macro proc a not resolved. Means it is looking for macro proc a, because whenever we execute macro, we simply give a % and macro name. To avoid this kind of thing, all we need to do is, we need to use %q sysfunc just instead of sysfunc, and then we can use our substr and %x, 1, 6. And when we run these 2 lines of code, now we are not going to see any error, but we are going to see the value of %proc a in the log. In here, what I wanted to tell is, whenever we use datastep function and sysfunc, and if we feel that we have some special characters and we need to mask them, we can simply use qsysfunc. And in here, I'm not going to go into any details regarding how quoting works and what quoting does, but I have made a very long video on that, and link for the same I will give in the description below. That's all for this topic. This topic is about macro libraries, and this is part 8 of our SAS Macro series. First, let us try to understand what SAS Macro library is and what kind of SAS Macro libraries are available for us. Before going into those details, first let's try to understand why we need a macro library. Till now, the major focus was how to write a macro and other nuances related to this macro code. But it is very important to know how to store this code or our macro. The reason being, whenever we are writing macro, the intention is that one person creates or one programmer creates the macro, and many people or many programmers will use this macro code. To use this macro code in such a way, we need to either store the macro or macro code in one location, and all others can use from that particular location. There are 2 main advantages of this approach. The first one is ease of use. One programmer builds the program and everybody can use that program or macro. Another advantage is it avoids copying the macro code into each programmer's program separately. Whenever macro program is copied into separate programs, what could happen is the programmer could change the code according to his or her wish, and then what finally will happen is we will have a different copies of same macro, but the macro itself might have been modified a whole lot, and this kind of thing is not good in any organization. There are three ways to create macro library. The first one is %include. %include is nothing more than pointer to our code. And the second one is SAS stored compiled macros, wherein we compile macros and store in a particular location. The next one is autocall library, and this is very similar to %include, but it is little different than %include. We will discuss all those in upcoming slides. Now let us try to understand %include. As I was earlier saying, %include is nothing more than a pointer to code. To understand this, let us look into one of .sas file in here. In here, I have one of my .sas file wherein I am saying it's test1.sas. Let me click on this one. Once we click on this one, we can see that I have a macro in here wherein I am saying macro pp, and then I am also saying proc print data equal to sashelp.cars and then run %mint. I do not have any parameters. I just made a very simple macro in here. And I have saved this code in this particular location sometime back just to illustrate whole of this. Now let me close this, and let me also right click on this and see where is the location. The location of this file is in this particular location. And if you see in here, I have also have my %include statement, and I have given the exact path in here. Now by doing this, what I am doing is I can access my macro which is stored in here. Now let us quickly run this %include statement. Once I run this %include statement, my macro will be compiled. And I can execute this macro by giving macro name, and before the macro name all I need to do is I need to put %. And in here I can execute my macro by saying %pp, and once I run it, it will do my proc print of sashelp.cars. If you remember, our macro is nothing more than code related to sashelp.cars. Now let me again close this. Not only this is the one way to do a %include, we can also do %include with the help of file ref. What is meant by file ref? File ref is nothing more than, it is another pointer wherein I am saying file name and we give file ref followed by path. Whenever I want to use this path, instead of writing my path, I can just give this file ref. So whenever I say this file ref, it means this particular location. Now I can do a %include and I can use this file ref. When I'm using the file ref my file, this means I'm using or I'm accessing this particular path. So our include becomes, or our %include becomes %include and this whole of this path. In here I have a different file, that is test2.sas. Let's look into test2.sas real quick. In test2.sas I have a macro which is known as PM, and I have a parameter dsn equal to, and in here I have proc means data equal to ampersand dsn run, and then I'm closing my macro with %mint. Whenever I say test2.sas means I'm just telling about the relative path, but what I mean is whole of this path which I can get by clicking on the properties. That is what I mean by test2.sas, means the whole of this path. Now once I have run this particular code, what it does, it compiles my macro, and now I can access my macro by simply doing my macro name followed by passing the parameter. Here I want to pass sashelp.class, and here you can see that it does the proc means. And here what I wanted to tell is, now I want to tell one important thing in here. Percent include is just not for macros. We can also use our regular code also. So percent include is not very specific to macros, but we can use it also for macros. Now in here I have another folder wherein I have said my new folder 1, and in here I have ds.sas program in here, and in here I have a simple data step. This simple data step also I can execute through percent include. Now if I run this percent include, what it does is it immediately executes the code which is there in this ds.sas. That is our simple data step where we are doing a set statement and copying the data to another data set class. There are a couple of other specialty related to percent include. Now in here if I look into test1.sas, I have only one macro. I need not have one macro. I can have 10 macros in this particular .sas file. This is something special about percent include. And when we do a percent include for this test1.sas, if I have multiple macros in it, what will happen is all the macros will be compiled. And not only I can have many macros in this particular .sas file, but I can also include some other code also in here. Like I can have my proc print, or I can have my data step, something which is not even related to macro also I can keep it in a file, especially in this particular file. So what you need to understand is percent include is just not meant for macros only, but you can use it for other purposes also. That is, you can keep your other code also in here. Whenever you have macro, when we use percent include, the code will be compiled, and if you have a general code, what will happen is it will be executed immediately, as I have shown you earlier in the case of this data step. Now we have looked into a lot more detail for percent include. Now let us look into the next topic, that is SAS stored compiled macros. Now let us quickly try to understand what happens during macro compilation. I'm not going to provide any details regarding macro compilation because I have made a very extensive video on the same topic, and link for the same I will give in the description below. But once our macro compilation is successful, a macro will be stored in macro catalog. And by default, this catalog is in work library. And in here, this catalog name is known as SAS MAC1. As I'm using SAS Studio, it is SAS MAC1. For others, it could be SAS MACR. For others, it could have a different catalog name. Now, if I run a proc catalog and say proc catalog equal to work.sas mac1 semicolon content semicolon run semicolon and quit semicolon, I can find what all macros which are compiled are available to me. In here you can see that I have close to 6 macros in here. I have just taken the partial print of this one and kept it in here. The first 4 are by default created by SAS Studio and is not related to this topic, but the other 2 macros, PM and PP, are the macros which we have just created, and they have been stored in this particular location. The problem with work.sas mac1 is these macros are there only for a particular session. Once we restart our session or once we end our SAS session, these macros will not be there. So they have to be compiled again. To avoid this recompilation over and over again, whenever we need a macro, what we can simply do is we can store these compiled macro, and this concept is known as stored compiled macro facility. or we can simply say stored compiled macro. To store a compiled macro, we need three things. The first thing is we need to do a libname statement wherein we have to give libname, libref, and we need to give the path. Why we are doing this is we want to store our macro to this particular location. So we have to state the libname. And we also need to give an options wherein we need to say options mstored SAS mstore equal to this libref which we have defined in here. So what we're trying to tell here is whatever the macro we are going to store, please store it in here. And we are telling that that store is this libref which is pointed to this location. And whenever we run the macro, we need to say after the macro name /store. And when we do all of these things, what happens is this macro will be compiled and it is stored in this particular location. Now let us quickly run libname, these options, and also this first macro. Everything in the log seems clean and also our libname has worked fine. Now let us quickly go ahead and run the proc catalog in here wherein I am saying proc catalog equal to myslib.sasmacr. So I'm interested to look into the catalog which is there in myslib. Myslib is nothing more than this particular location where we have stored our macro. Now let's quickly run this and see the result. And once I run this, I see the result that this particular macro is there in this particular location. Whenever I say or whenever anybody says libname, he is directly telling that it is pointed to a particular location. In our case, that location is this one. So we have stored our macro. Now you have seen that how we can compile a macro and store in one particular location. Now let us say I don't have this code anymore, but I only have the stored compiled macro. How can I retrieve the code? This can be easily done, but before doing that I want to show you something interesting. I have another macro. Again, it is the same like this first macro, but all I am doing is I am adding one more option after store, that is source. And once I compile this macro is stored. Because I have this option source, I can retrieve the code also. Code retrieval is pretty simple and it can be done in many ways, and whatever the way suits you, you can do in that particular way. And in here, what I want to show here is, once let's quickly run proc catalog to see our macro 2 also. Here we have our macro 2 also. Let us quickly remove all the code in here, and we do not have any code in here now. And here what I wanted to show you is, see, I have compiled my macro, but I do not have the code related to it, or I forgot to save it. Now how can I retrieve the code? As I have already used the word source, I can do a %copy and write my macro name followed by /source. Whenever I do this, it will write the code to the log. Now let me quickly run this. Now the macro 2 is written to log. Now here we simply wanted to do a copy of this macro 2 to the log. Not only that, what I can do is I can also copy this particular code to a particular location also. To copy the code of macro to a particular .sas file is also straightforward. All we need to do is we need to write %copy followed by macro name /source, and then we need to mention lib equal to whatever the library from which we are copying. Here it is my slib, which we have defined earlier, in which our macro resides. Rather, I would say our compiled macro resides, and then out equal to the location we want to write that particular .sas file. In here I want to write to this particular location and my file name is jkl.sas. Now let us quickly run this piece of code and then see what happens. And once I run this code, you can see that there is a new .sas file in here, and in here it has the code related to macro 2. Now we have discussed in detail about stored compiled macros. Now let us quickly try to understand the significance of stored compiled macros. As I said to you, we can compile once and we can use it at a later point. To explain this point, let us refresh our session by clicking reload or refresh in here, and then now we are getting into a new session. Once we get into our new session, I need not compile this macro again, and what I just need to do is I need to define my libname, and then I need to also tell the options mstored SAS mstore equal to libref, which we have defined above. Now let us quickly run this libname and options mstored SAS mstore equal to. Now I can easily execute my macros in here. Now I am executing my one macro and gives the result. The important thing to know about in here is when compared to %include, whenever we run %include, the compilation happens again, and whenever you start another session and you do another %include, the compilation happens again. But in the case of stored compiled macros, this does not happen. Once you store the compiled macros, all you need to do is you need to give libname statement and options like this, and then you can execute the macro. One of the major challenges of stored compiled macros is we also store our code at one location, and we also store our compiled macro at another location. Often this causes confusion. Compilation of macro usually takes very less time. Usually it will be within seconds. So there is rarely any need of creating stored compiled macro. And from the discussions what I see in SAS communities, it is being said that stored compiled macros are hard to maintain also, especially when stored compiled macros have to be migrated. And the discussion regarding stored compiled macros in SAS communities, I will give the link in the description below. One last point about stored compiled macros, and this is from my experience. I have never seen a stored compiled macro in the real environment. And now let's get back to another important topic, that is autocall library. As explained to you before, autocall library is similar to %include, but we need to understand one important thing here. %include is just not for macros. We can write any SAS code and we can store and we can call with the help of %include. But in the case of autocall library, this is exclusively about SAS macros. Now there are many other differences, but this is the first difference which I want you to remember. Before telling about the differences with the %include, let's first discuss about autocall library itself. Autocall library is usually a folder or a directory which contains one or more .sas files, And this .sas file contain one macro in each file. Here I have my autolib, and this folder I'm going to treat as my autocall library. And in here I have two .sas files. The first one is known as test1.sas and second file is known as test2.sas. And each of these file has one macro in it. Now let me quickly click on each one of them. In here in test1.sas I have a macro. Again, this macro name and this file name should be same. Here it is test1.sas and my macro name is also test1, and I have only one macro. So very specific, unlike our %include. And now let me close this and let me open test2.sas. Here in test2.sas I have another macro, but only one macro, and this macro name is test2. That is, it has the same name of our .sas file. And now let us see what else I need to do to make this work. First we need to use a file name statement wherein I need to say file name followed by file ref and the location of that file. And here this is the location of our file, and in here you can see that I have the same location pasted in here. Now after that I also need to say options m auto source sas autos equal to, and I need to mention this libref in here. Once I run these two lines of code, I can access all the macros which are there in this particular folder. Now let us quickly execute this test2 macro. And once I execute this test2 macro, you can see the result also. To conclude, by simply using file name and using the options m auto source sas autos equal to file ref which we have mentioned above, we can access many macros. This is a very clean way of accessing many macros and giving access to many other users all these macros which we have kept in this autocall library. And in here I want you to look into one another important point, that is, after SAS autos equal to, I have mentioned a parenthesis and then I have given a libref and then I have closed parenthesis. I have done this to show one another thing, that is, if you have another file name, I can use that another file name also in here along with this, something like putting a comma and another file ref, I can put it in here. I do not want to go into details of that topic, but I just wanted to tell you that that particular option is there. Now that we have looked into all three of macro libraries, now let us discuss the final topic, that is order of macro search. What do I mean by order of macro search? When I'm trying to execute a particular macro, what it will see is, it will try to see where is the compiled macro available or in which location that compiled macro is there. First it looks into work.sas mac1 location. Then it goes and looks into stored compiled macro. Then finally it looks into autocall macro libraries location. And with this we have completed whole of this topic, but I would like to tell one another thing. To prepare a whole of this presentation, I have taken the help from one of Art Carpenter's paper, and link for the same I will give in the description below. That's all for this topic. This topic is about macro facility interaction with the call execute. And this is part 9 of SAS Macro series. Now let us briefly look into call execute. Here I will give a very general introduction about call execute And more on this we will look into and try to understand with the help of code. Now call execute is a data step function. Call execute, what it does is it allows us to pass character string to macro facility for immediate execution during data step. This point is very important to know. Whenever we try to mix macro facility and data step, what will happen generally is macro facility generally runs first, and this is due to macro triggers ampersand and percent. And we have discussed in detail about this topic in the very first video of SAS Macro series, that is SAS Macro series introduction. Now what call execute does is call execute allows us to interact a data step with macros facility, and how this happens we will discuss in detail with the code. And now there is one another important point here is whenever there are SAS statements generated during call execute, they are stacked in input stack, which will run once the current data step completes. These 2 points are very important to know in the call execute. So most of the time the problem comes with the call execute is understanding the timing. With this brief introduction, let's try to look into the code and try to understand call execute more. Now let us try to understand call execute with a very simple example. In here I'm highlighting my example. In this example we do not have any macro reference. I have taken this simple example to explain how call execute works. In here, if you look into, we have a data step in which we are saying data underscore null underscore, and we are saying then call execute, and in the parenthesis we are having a code, and in this code we are writing proc print data equal to SAS help.class semicolon run semicolon, and then I'm closing my code and also my parenthesis. And what will happen is once I run this code, it will generate a SAS statement. This SAS statement will be saved in input stack. And once the data step is completed, then only this SAS statement gets executed. Now let us try to quickly run this piece of code. And here we can see our result. This is not very important, but let's quickly go into the log. And in the log, if you see, we have our data step in here, and in here it shows that this data step is complete. And once this data step is complete, we can see a note wherein it says call execute generated line, and this line is nothing more than proc print data equal to SAS help.class semicolon run semicolon. And in here this particular statement was generated during data step, but it got executed only after data step is complete. And now let us try to understand this little bit more with the help of an example which is a little bit more useful to us. Here this is super simple, rarely we use this kind of thing for call execute. Now in here I have a data set. In this data set I have a variable, and the variable name is DSN, and I have three observations in here. The first one is SAS help.class, second one is SAS help.class, third one is SAS help.air. My goal here is to generate statement as follows: proc print data equal to SAS help.class semicolon run semicolon, and then I want to generate proc print data equal to SAS help.class semicolon run semicolon, and same with the SAS help.air. Now what we can do for this is simple. In here we are again using data step to generate the lines we want. And in here I am saying set P, that is from this data set wherein we have three observations. And in here what I am doing is using a set statement, I am saying set P. And also I'm doing a call execute. And I want you to focus here. This call execute which I have earlier discussed and this call execute is very similar except one change. Here what we are doing is I am directly writing SAS help.class and this generates this proc print statement wherein what I am doing here is I am writing everything up till in here in quotes, and then for this part SAS help.class part what I am doing is I am concatenating with DSN variable, and the DSN variable value comes from this data set, and the remaining semicolon to run semicolon again is the same, and again I am concatenating it with this DSN. So let's see what is happening in here. So when SAS reads the first observation, this DSN will become SAS help.class. Whole of this statement will become proc print data equal to SAS help.class semicolon run semicolon. This SAS statement will be generated and it will be stored. And then it reads SAS help.cars and this becomes proc print data equal to SAS help.cars semicolon run semicolon, and then again it reads the third observation and this does proc print data equal to SAS help.air run semicolon. And if you see in this fashion we are reading each observation and then we are able to dynamically create SAS statements. Here because we have three observations we have created three proc prints, and one important thing to remember here is all of these three statements generated will be stored in the input stack. And one another important thing to remember is all of these three statements will be executed one after another once data step is complete. Now let us quickly try to run this and see what is happening in here. And let's quickly look into the log to understand this better, and what is happening exactly we can only know from the log. Here if you see, first we have created our data set and everything was clean, and then we have run our call execute. If you see here it shows that this data step is complete. If we see in here, we can see that the first SAS statement which was generated during data step got executed, and we can also see about it in the results in here. And also once we go little bit down we can see that the second SAS statement also has been executed followed by the third SAS statements. We need to understand that the SAS statements got generated during data step, and once the data step is complete all the SAS statements which were in the input stack execute one after another. Now till now we have seen what happens when SAS statements are generated during call execute. But now let us quickly look into what really happens when no SAS statements are generated during data step. Here I have a data step wherein I am saying data underscore null underscore, and in here I have set SAS help.class. And in the call execute what I am doing is I am doing %put and name is in single quotes. The important point I want you to remember is I have kept the whole of this thing in single quotes. Why is this important? If I have put this in the double quotes, what would have happened is this %put would have executed even before the data step starts, because these percent and ampersand are macro triggers, and when they are in double quotes they execute immediately. So what will happen is this step executes immediately even before reading anything from SAS help.class. Now let us see how this whole thing works. In here, as I have written percent put name is in single quotes, and I'm concatenating it with name variable which is there in SAS help class. First, what will happen is the first observation in the SAS help class will be read, and the name variable has the value of Alfred here, and the text in here will become percent put name is Alfred. And if you can see in here, there is no SAS statement in here. When I say SAS statement like proc print or any data step, there is nothing of that sort. So what will happen is this will execute immediately. So this percent put will put the value of name is Alfred into the log. And then what will happen is it will read the second observation. The second observation, I know the value of variable name is Alice. So what will happen in here is the same thing which we have seen before, and this puts the value of name is Alice into the log. And if you can see in here in the same fashion, it will be reading each and every observation in SAS help class, and it will get executed immediately. And now let us quickly run this and see what happens in here. In the note here you can see that call execute routine executed successfully, but no SAS statements were generated. This you can generally see after our data step completion. But if you see in here closely, all our put statements, or rather I would say percent put statements, have been executed, and they are here, they are well before our data step completion. For example, if I would have added another call execute, and in that call execute, if I would have added something which creates SAS statements, then what would have happened is I would have had these values in here and all the SAS statements after my data step completion, but I have not done that to keep it simple. The important point to remember is call execute executes immediately when there is no SAS statement. But if there are SAS statements, what will happen is they are stacked up and they are kept in input stack, and once the data step is complete, all of those SAS statements get executed. So there is a timing difference when there is SAS statement created and when there is no SAS statement created. Till now, we have been looking and trying to understand how the call execute works. But till now, we have not tried to look into how call execute interacts with the macro facility. Now let us look into that aspect. To understand this concept, what we need to do is we need to look into an example. Now, to understand this example, let's quickly look into this data step. But before the data step, I would like to explain what we want to do in here. In here, the target is to create data set from each name in SAS help.class. So I want to create a data set from each name in SAS help.class. One way to do it is write something like this: data Alfred set SAS help.class where name equal to in quotes Alfred semicolon run semicolon, and this creates Alfred data set. And to create Alice data set, all I need to do is I need to change in here and also where name equal to Alice. Instead of writing all of these 19 names in here and here to create 19 data sets from SAS help.class, why I'm saying 19 data set is I know that SAS help.class has 19 different names and we can create 19 data sets. Instead of that, we can create a simple macro, something like this, wherein I am writing percent macro test, and in the parenthesis I am writing nm equal to, and then in here what I'm doing is I'm mentioning data ampersand nm set SAS_class where name equal to ampersand nm in the double quotes, run semicolon, and then I'm closing this macro. So once we create this macro, what I can do is I can pass Alfred, Elise, and each name. But the problem with this kind of approach is I have to pass each name. Even though I'm not writing a lot of code again and again and again to create data sets, but I have to pass parameters over and over again. And this is not efficient. And this kind of problems are more easily solved in a dynamic fashion, wherein we do not pass parameters but we bring it from a data set. These kind of things can be solved by using proc SQL into clause and also followed by a %do loop in a macro, or by using call SYMPUT and then using a %do loop. And I have discussed about how to do that in one of my videos of proc SQL into clause, and link for the same I will give in the description below. But whenever we want to do those kind of things, the code becomes little bit more complex. That is, first we have to create macro variables and then we have to use do loops. But these kind of things can be easily solved using call execute. Now let us see how we can do this thing using call execute. Now in here what I am trying to do here is I am having my data step wherein I am using a set statement and I am mentioning SAS_help.class. And in here if you see, what we are doing is we are using call execute. And this call execute is going to generate these macro calls. And how is that happening is, in the single quote I'm using %test, which is very similar to this, and also I'm using parenthesis and name equal to in here in quotes, very similar to what we have in here. The Alfred comes from this SAS_help.class when we read the first observation, and then I'm also adding this ending parenthesis with the help of concatenation, and then I'm adding this part. So in a way I'm generating this statement. In the same fashion, after reading each observation, we are going to change our parameter and generate this statement. And in here important thing to remember here is this macro has a SAS statement. So this gets executed only after data step is complete. And to understand this, now let us quickly try to compile this macro. And now let us also quickly run this data step which is called execute. And in here you can see that 19 data sets were created. And let's also quickly look into the log to understand this better. In here you can see that our data step is complete in here. After the data step is completed, you can see that call execute has executed first SAS statement which was created during data step, that is this one. And after that it has executed second SAS statement which was created. So here you can also see the numbers 1, 2. In that fashion you can see that 19 SAS statements are executed one after another with the help of call execute. And now what I want to explain from whole of this is, instead of using proc SQL into clause or call SYMPUT and then trying to run %do loop, That is, whenever we want to do dynamic programming, whenever I use the word dynamic programming in these particular cases is using data set and achieving what we want to achieve without giving any manual input. So a data driven programs when we want to create, which again we can say in here as dynamic programming, we can use call execute, and call execute the code is much simpler. Now that we have looked into call execute, now let's look into what are the challenges which are posed by call execute. To understand the challenges, we need to run a different macro in here. Here I have a macro and this macro is test2. The striking or important factor or important thing about this macro is I have a data step in this macro, and also I have %put statement wherein I have a macro variable reference. So if I want to execute this macro with the help of call execute, here I need to be focusing on two things. The first one is the data step, which is a SAS statement. This does not run till this data step is completed. But the macro references and things which do not have SAS statements get executed immediately. So let us quickly compile this macro, and let me also quickly run this call execute. Here we see a warning. Before going into the warning, let me tell you one another thing, that is, this gets executed immediately, this gets executed later. That is after data step is complete. After this data step complete, only then this part of SAS statement runs. But this runs immediately as we have macro reference in here and there is no SAS statement in here. So because this has run immediately after I have ran this particular call execute wherein I am executing this macro, what will happen is this ampersand macvar is a macro variable which is created in the step above, but this runs even before that. So we get a warning saying that this particular macro variable is not resolved, because if you see in here, this has executed immediately. That is, this part of our macro has been executed immediately. But if you see in here, our data step has run much later. So whenever you have macro reference without any SAS statement, it gets executed immediately. And anything related to SAS statements runs later. So here there is a timing issue. So you need to be very careful of that when you are trying to have macro references and SAS statements in a macro, and if you are executing through a call execute. Now there are ways to handle that and we will discuss that in a minute. Before going to do that, let me also quickly delete the macro variable which we have created in here. The problem with the call SYMPUT in this particular scenario is it creates a global macro variable, and this is a special case of global macro variables getting created in a macro. More on this topic I will discuss when I talk about scope of macro variables, which would be my next part of my macro series. And in here, let me delete the macro variable by saying %symdel and giving the macro variable name followed by semicolon. As we have created global macro variable in here, I am deleting it, and deletion of the macro variable is successful. So we no longer have our macro variable present in our session because we have deleted this global macro variable. One way to address this issue of timing is by simply using nrstr. So whenever you have macro references and you want to use along with the call execute, you always need to either use %nrstr, or there is another way to do it, but I will discuss that later. So what this %nrstr does is it delays the macro execution itself. So nothing get executed, unlike in here wherein it got executed in the data step itself, and then this got executed first because it did not had any SAS statement and it has a macro reference. In here it delays the macro execution itself. Now let us quickly run this. In here you can see that nothing has happened up before the data step is completed, but after the data step the macro gets executed, and everything gets executed in the order it was there in the macro. First this gets executed, then this gets executed. That is what we can see in the log also in here. I've also used mprint, and it shows the SAS statement was generated first, and then the another %put statement which was there with the macro reference was done next. That is in the order it was available in this macro itself. So nrstr helps with timing issue. Another one which helps us with the timing issue is do_subl. Do_subl is a new function wherein it has properties of call execute, and also it addresses the macro reference timing issues. For this, the code is pretty simple. Instead of call execute, I am saying in here rc equal to do_subl, and then I am giving exactly the same what I have in here, and then closing with the parenthesis. One important thing to remember here is, here I have mentioned rc equal to, and then I am using do_subl, and whatever I want to have in here I am putting in the parenthesis in here. The important thing to remember here is this rc could be anything. This is a simple assignment statement. And now let us quickly run this. Before doing that, let us delete the macro variable by using %simdel macvar, and this deletes our macro variable macvar. And after that, let's quickly run our data step which has do_subl. Once I run this, here first I see that our data step runs first, and then our macro reference works next. What do I mean by that is it exactly runs the way the code is set up in my macro. So there is no timing issue with do_subl also. So to sum it up, whenever we have macro references along with SAS statements, we need to be careful. We need to either use %nrstr or do_subl to address the timing issues. That's all for this topic. Today's topic is about SAS Macro Series Part 10, and in this we are going to discuss about scope of macro variables. This is the last part in SAS Macro Series, and I also believe that this is one topic which each macro programmer should understand in detail. If this concept is not understood in detail, then there could be some problems. What are those problems and other things we will discuss very quickly. And now let us quickly talk about some theory. First, let's talk about local and global scope of macro variables. And in here, I have used the word generally. Means whatever I am going to discuss, this is accurate or correct to more than 90% of the times, but 10% of the time this is not exactly right. And what are those scenarios we will discuss. But first let's look into some theory. Macro variables created inside macro has local scope and they belong to local symbol table. And macro variables created outside macro has global scope and belong to global symbol table. Now, macro variables are stored in symbol table and these symbol tables are nested. Local is nested in global. Now we have covered enough of this theory. Now let us look into some description of this and some examples. Now this is the symbol tables which I was talking about, wherein the macro variables are stored in global or local symbol table. And if you see the global symbol table, local symbol table is nested in local, and all the macro variables created in global is also available in local, but whatever are available in local are not available in global. That means macro variable which we create outside of the macro are available outside of the macro, and also they are available to that particular macro. Whenever I use local, it means that particular macro in which macro variables are created. Now let us move forward and try to understand this better with simple example. In here I am creating a macro variable and I am saying %let a equal to my test. And in here I have a macro also, and in here I am creating macro variable and I am saying %let b equal to your test, and I am also doing a %put for macro variable a and also for macro variable b, and I am writing %ment. And this macro explain I am executing. Once I execute, I can see the value of a my test and also the value of macro variable b your test. So this explains us that the macro variable which I have created outside of the macro I can use in here, and I can also use the same macro variable which I have created in the same macro. This is nothing special. Now let us try to do %put %a and %b outside of the macro, and let's try to run this piece of code. And once we run this, we get one warning. It says that apparent symbolic reference be not resolved, which means the macro variable which we have created in this particular macro is not available outside. Now let's conclude this slide by 2 points. The first point is, whenever we create a macro variable outside of the macro, what it does is it creates a macro variable in global symbol table and it is available everywhere, and it persists or it stays throughout the SAS session. But whenever we create a macro variable inside a macro, what happens is it goes into local symbol table and it is available only to this macro, and also it persists only when we execute this macro. Now if you want to access this macro variable outside of the macro, to do that also is simple. All we need to do is we need to use a %global statement followed by the macro variable which we want to make it as a global macro variable so that it is available outside of the macro also. Now once we run this %let statement followed by compiling this macro and then executing this macro, and if we do a %put %a and %b, And if we run this %put also, we can access both these macro variables, and you can see from the results which I have pasted in here. By doing a %global followed by the macro variable name in a macro, I can access this macro variable anywhere, which means pretty much it's a global macro variable. Now that we have looked into %global, now let us look into a different aspect which is very interesting. Now in here I have %let a equal to my test, and in here I have a macro wherein I am creating a macro variable and I am saying %let a equal to your test. So here the problem is we have two macro variables with the same name, and scope of this macro variable is global, whereas the scope of this macro variable is local. Whenever you have two macro variables with the same name, there is a problem. Now let us try to understand that problem. First, when we run this %let statement, and it creates a macro variable which will have the value of my test. Now, once we compile this macro and once we execute this macro, what will happen is this local macro variable value, what it will do is it will override this macro variable name, and this value will become your test. Now let us quickly go 3 to 4 slides back, and we are here. And in here we have a macro variable a and its value is my test. And once we compile the macro, explain, and then execute this macro explain, what will happen is here also we are creating macro variable a. What it does in here is it always looks into a level up. In this case it is global. So what will it do is this macro variable a, it has a value of your test, it will go ahead and update this value also. So this is a problem. And if you see in here, when we execute this particular %put statement, you can see that the value of macro variable here is your test. Means this value has overwritten this value because we can access only a global macro variable outside, and this is a local macro variable, and this has overwritten this. And this is a serious problem, especially when you are trying to build a lot of macro variables inside and outside of the macro. The conflict between the macro variables is real and it's problematic. Now how can you avoid this so that this macro variable will not go and update this value? This can be easily done with the help of %local. So whenever you create a macro variable in a macro, if you write a %local and mention that macro name, what it will not do is it will not look into this global space and it just get restricted to this, and it doesn't care whether the same name macro variable is here. So the way to avoid the conflict when you have the same macro variable is by using %local and the macro variable name in here, so that now we are kind of protecting our global macro variable. Now once I run this %let statement followed by my compilation of macro and execution of macro, and then I do a %put $a, the macro variable value will be my test. So this value is kind of protected from this local macro variable by simply writing %local and the macro variable name. So more than often SAS macro programmers don't use this %local very much. but it's a very good practice to use %local whenever you can think of there could be a conflict and there can be a chance of overwriting global macro variable. Now let us look into another factor related to local macro variables. In here, to understand this, let's look into an example. In here, I have %let t equal to hello, means I'm creating a global macro variable in here, followed by a macro in here, and here I'm naming that macro as one more, and in here I'm using a macro parameter, and this is a keyword parameter. And in here we are also creating a macro variable t, and then when we execute it with a particular value, we are giving it a value in here. In here I am passing a value high, and once we run this %let and then we compile this macro and then we execute this macro by passing a parameter, we are creating a macro variable, a local macro variable. This local macro variable will never look into global symbol table. Unlike when we use a %let, %do or proc SQL into clause. So this is very important to know. I have not told anything about call SYMPUT or call SYMPUTX. It's even more little trickier, and we will have a separate topic on call SYMPUT. And then what will happen is when I do %put $t, we are accessing this macro variable, and we can see in here once we execute we have the value of hello. So this macro variable, which has the same name, doesn't override this macro variable. As I said to you, macro parameters only look for local symbol tables. They do not try to update global symbol table. Now that we have looked into this aspect, now let us get a little bit deeper. Now let us discuss about overwriting of macro variables when we nest macros. To understand this concept, let's look into an example in here. In here I have two macros. The first one is test2 macro, in which I am creating a macro variable g and it has a value of y, and also I am doing a %put and saying $g of macro test2. And in here I have another macro, and this macro is test, and in here I have a %let statement. In here I am giving the value of z to this g, and also I am executing this particular macro, and also I have a %put $g of macro test, means I just want to access this macro variable in here, and I'm closing this macro with the %ment. And when I execute this %test, what will happen is first this macro variable g, which belongs to test, will get created, and then this %test2 gets executed, and this test2 has another macro variable g which has a value of y. And what these particular test2 macro variables will do is, as it is nested, it will overwrite the above macro variable or the above level macro variable which has the value of z. And when I do the %put $g of macro test, as we have created the value of macro variable z with y, it overwrites the macro variable a level up, and then both of them will have same value. It is the same thing what we have seen earlier. It is overwriting of macro variables to the level up. Now let us try to understand this pictorially. In here I have a symbol table, and in this symbol table this is a global symbol table, and test2 is nested within this test macro. If you see in here, we have test and test2 is nested within this test. And in here, our test2 has the value of y. So what it will do is, even though we have created macro variable with value of z, this value of y also looks into this and it will update it. So again the same problem of overwriting. Earlier what we were looking was, we were looking into a local macro variable and we were looking into a global macro variable and overwriting of local macro variable to the global macro variable. Here what is happening is, a nested value updates the higher level local macro variable. Now I do not want to go too much into nested macros. I have never written a nested macro myself and I just wanted to tell or give this information out. So how do we avoid this? It's the same way. We are going to do a %global and then we are going to mention the macro variable here, and then once we nest it, it will stay local to this one only, that is to test2. It doesn't overwrite, and once we execute this %test in the log, you can see the result as in here. You see in here the value of test2 is y, whereas the value of macro test is z. So nothing has been overwritten. So this is an important point to remember, whereas in here it was overwritten. Now by this you could understand the importance of %global and %local. Now to explain about scope of the macro variables, we also need to discuss about call SYMPUT. Call SYMPUT and call SYMPUTX are little different. Now let us look into the first category where I want to discuss about macro variables created by call SYMPUT or call SYMPUTX in a macro. In here, if you see, I don't have any parameter. Whenever we do not have any parameter and we use call SYMPUT, we are going to create macro variables in global symbol table. The reason for this is, whenever we use call SYMPUT or call SYMPUTX, it cannot create a local symbol table on its own. It has to be created first for this particular macro. To do that, we can have a parameter. If we do not have parameter, call SYMPUT and call SYMPUTX will create these macro variables in a global symbol table. And once I run this particular macro, or I compile this macro and execute this macro, I can access these macro variables outside of the macro by simply using %put and using the macro variable names here. And you can see I can access these macro variable values. I have made a very detailed video about call SYMPUT and call SYMPUTX, and link for the same I will give in the description below, and I would not like to talk about call SYMPUT and call SYMPUTX in here. I just want to talk about the scope. And in here, another important point to remember is, whenever we use a %let statement, a %do loop or proc SQL into clause, even without parameter, they create local macro variables. Only call SYMPUT or call SYMPUTX is little different. And it creates global macro variables even in a macro. And this is an important point to remember. If it creates global macro variables, how we can make them local macro variables? You know, that is very simple. All you need to do is you need to use a %local. We have discussed about %local before. Now I would like to show you something different in here. Call SYMPUTX allows one more argument. That is, it can have three arguments. The first argument is a macro variable name, second argument is macro variable value, and third argument is scope of the macro variable. As I said to you, in here the macro variable is going to be created is a global, but I set the scope to be local. And another way is simply using a %local and mentioning this macro variable name. But here we are doing it through third argument, and we are saying L in here means local. Now if we try to access this macro variable outside of the macro, we will get a warning saying that this particular macro variable is not there. That is because it is now a local macro variable and it cannot be accessed outside of macro. Now we have looked into this aspect. Now let's try to look something different in here. Actually, this is something very similar to other macro variables which we have created in macro. Here we have very similar kind of macro, but in here we have a parameter. It does not matter what parameter this could be. If this macro has a parameter, and this parameter will create a local symbol table, and this local symbol table, what it will do is it will help these particular two macro variables to go into local symbol table. So now what will happen is, now when we pass the value of the macro variable in here, that is var equal to hello world, these two macro variables also go into local symbol table along with var. And when we try to access them outside of the macro, it will fail because these two macro variables are now of local scope. To make these macro variables global, it is again simple. In call SYMPUTX, we can give an additional parameter and we can say G. This creates a global macro variables. And another way to do is simply writing %global and writing the macro variable name. So to reiterate the whole thing, I just want to tell in one line. Whenever you do not have any parameter, call SYMPUTX or call SYMPUT will create global macro variables. Whenever you have a parameter, it is going to create a local macro variable. And the reason for that I have already discussed, that is call SYMPUT and call SYMPUTX on itself cannot create local symbol table for that particular macro. So it needs the help from parameter. And one last thing I would like to say is the third argument option is only available for call SYMPUTX, not for call SYMPUT. And also whenever we use call SYMPUT and we want to change the scope, all we need to do is we need to use %local or %global as we require. That's all for this topic. Now that you have watched 6 hours of SAS macro video, I have couple of advice for you. The first one is to become better at anything, you need to practice a lot. SAS macro is no different. Please keep trying to solve lot of SAS macro related problems. In my SAS macro playlist, I have lot of problems related to SAS macro. Please check them out. And also I have some videos on about how to design SAS macros. And also I would suggest Art Carpenter's macro book, which is pretty good and very helpful if you really want to go deep in SAS macro and want to learn more. That's all for this whole of this video, and thank you so much for watching.